Hi there. It's great to have you here. In this course, we'll explore the essential aspects of securing digital assets in the cloud. And by the end of this course, you'll have a well-rounded understanding of the tools and techniques needed to protect your organization's data and infrastructure. Before we dive in, let me introduce myself and tell you a bit about how I got into the interesting world of cloud security. I'm Manny, and I'm a security engineer. Like some of you, I started in a different field before finding my way to cloud security. I started my career in IT. I worked as a help desk technician for a few years, then I moved into systems administration role. I enjoyed working in IT, but I was always fascinated by security. My unexpected journey took me to exploring vulnerabilities and challenges in the cloud space. I looked into Google Cloud projects to understand the various resources I could deploy, like compute instances, and how to configure firewalls for a home network lab. I realized that cloud security was a rapidly growing field, and I wanted to be a part of it. From my experiences and learnings, I'm now an offensive security engineer at Google, where I simulate real-world attacks against Alphabet and keep our data, systems, and users safe. Venturing into cloud security can be an exciting challenge, offering great opportunities. As we journey through this course, you'll gain key knowledge and insights, shining a fresh light on how to defend our digital infrastructure. Now, let's dive into the content and build skills essential for safeguarding digital assets in the cloud. First, you'll explore cloud security fundamentals, including identity management, access controls, trust boundaries, and the differences between zero trust and traditional perimeter security. Next, you'll learn about the cloud-native architecture and data protection, secure configuration, threat and vulnerability management, and data protection techniques, like encryption and data masking. Then, you'll learn about cloud-based operations and continuity, including business continuity planning, disaster recovery, and infrastructure as code. Finally, you'll be introduced to automation, continuous integration and continuous delivery, service accounts, and secure management of credentials in cloud-native environments. Now, let's examine each topic in more detail. In the Cloud Security Fundamentals section, you'll learn more about the essential concepts and practices related to securing cloud environments. Your primary area of focus will be identity management principles and effective access controls in cloud environments. This includes how you'll learn to effectively manage user access. Next, you'll examine the concept of trust boundaries in cloud security. This will enable you to better understand and manage the flow of sensitive information within your organization. You'll then compare two widely used security models, zero trust and traditional perimeter security. By comparing these two models, you'll discover the knowledge and insights needed to determine the best security approach for your organization. In the cloud-native architecture and data protection section of this course, you'll review best practices for secure configuration and the effective management of threats and vulnerabilities in the cloud. This knowledge is essential for assuring the security and integrity of your cloud-based applications and infrastructure. During this section, you'll learn the details of cloud-native architecture and design considerations, focusing on key components like containers, serverless computing, and orchestrators. You'll also examine various data protection and privacy techniques that are crucial for safeguarding sensitive information and upholding privacy standards in the cloud. These techniques include encryption, data masking, the use of certificates, and the implementation of robust governance models. In the cloud-based operations and continuity section, you'll first focus on business continuity planning within the world of cloud computing. You'll inspect the steps organizations take to develop a robust plan that enables recovery from any potential disruptions that may occur. You'll also explore various key concepts and technologies that are crucial for efficient cloud-based operations. These include infrastructure as code, or IAC, automation and continuous integration and continuous delivery, or CI/CD. Along with these concepts, this section will also cover the usage of service accounts within cloud-native environments and the topic of secure credential handling. Throughout this section, you'll learn the importance of automating processes and securely managing credentials. After completing this material, You'll be on your way to becoming an effective and knowledgeable cloud security expert who is capable of addressing challenges and protecting an organization's cloud assets. Join me as we continue the exciting journey to expand your cloud security skills. Hi, I'm Manny. I'm a security engineer on Google's Red Team. My job is to simulate real-world attacks against Alphabet and keep our users safe. I make it harder to hack Google by hacking Google. I started out as a civil engineer, but I was always fascinated by the idea of protecting people's data and systems from attackers. I learned most of my hacking knowledge through free online resources like YouTube, books, and other helpful hands-on learning material. I also tinkered with virtual machines and looked at foundational security certificates, technical books, and programming to learn more about the field. I did extensive sandbox testing on different platforms. I was able to explore security topics in depth. I connected with friends already working in the field to get a better understanding while researching the various paths into cybersecurity. Additionally, Google's Cybersecurity Professional Certificate gave me a comprehensive foundation into cybersecurity and helped build my security mindset. I started my career as a parking garage attendant in college. I then worked in IT at a help desk, where I learned a lot of my initial computer skills. After graduating, I realized that I enjoyed troubleshooting and tearing computers apart. I pursued IT full-time, and from there, I became eager to learn more about the various disciplines within cybersecurity and how to protect organizations from cyber attacks. I've gained a lot of transferable skills along the way, from communicating effectively with stakeholders, to leading projects, to working with colleagues and friends. And involvement with community service has given me a variety of skills to work with when collaborating with security engineers and tackling some of the hardest challenges each day. I accepted an amazing opportunity with Google's Information Technology Residency Program, where I honed in on my computer, programming, and networking skills. I participated in a security rotation program and realized that I enjoyed the work, from defending devices and networks against malicious activity to analyzing logs and deep diving into issues. I realized that cybersecurity was a great career, and so I followed my passion. I continued to learn independently so that I could transfer into the security org. Eventually, I made it, and I'm still here today. It often helps to think about the big picture. In this course, we'll provide you with a comprehensive overview of the latest cloud security concepts, tools, and best practices. We'll cover three main topics that are crucial for understanding the cloud environment. First, we'll discuss identity management and access control in a cloud environment. We'll also review related concepts including single sign-on, or SSO, multi-factor authentication, or MFA, and identity and access management, or IAM, services. Second, we'll explore the different types of access controls employed in a cloud environment, including role-based access control, or RBAC, and attribute-based access control, or ABAC. And third, we'll provide you with an overview of trust boundaries, best practices for configuring and managing defense, and the zero trust security model. By the end of this course, you'll have an understanding of cloud cybersecurity concepts and be able to apply these concepts to scenarios you might really encounter in the workplace. Let's get started. Good security starts by knowing who has access to what. In this video, we'll be discussing the core principles of identity management in a cloud environment and how it aligns with least privilege and separation of duties. We'll also explore how these concepts differ from traditional on-premises environments. Then we'll dive into key topics like role-based access control, single sign-on, multi-factor authentication, and identity and access management services. Let's get started. Identity management is a core component for access control in cloud environments. Combining identity and network control strengthens the defense of cloud environments. One of the key differences between cloud-based and on-premises identity management is the scale and variety of providers and platforms available in the cloud ecosystem. Organizations are no longer limited to the in-house infrastructure and can now choose from a multitude of service providers, technologies, unique tools, and interfaces. This diversity while offering flexibility and choice, also requires a unified approach to managing user identities and access control. Centralized and consistent identity management is essential for several reasons. Let's discuss 5 of them. Reason 1. Use streamlined access control when you have multiple platforms and services in play, and centralize the process of granting, modifying, and revoking access to resources, as opposed to managing these resources in a separate environments. Reason 2. You enhance security when you minimize vulnerable systems by consolidating access controls and preventing potential breaches. Reason 3. You improve compliance when you fulfill requirements to meet compliance, rather than when you just focus on implementing controls on data access and user authentication. Reason 4. You simplify administration when you provide a single interface for managing users, groups, and permissions across many systems in your environment. Reason 5. You save operational and resource cost when you centralize multiple identity management systems into a single identity platform. Now, let's go over some key topics in identity management for cloud environments. Role-based access control, or RBAC, is a method for controlling access to resources based on roles assigned to users. This helps ensure users only have permissions and access to the resources necessary for their job. Single sign-on, or SSO, is a technology that combines several different logins into one. It simplifies the authentication process by allowing users to access multiple applications using a single set of credentials. This minimizes the risk of password fatigue, which is when users feel overwhelmed by the number of different login credentials they need to manage. Multi-factor authentication, or MFA, is a security measure that requires a user to verify their identity in 2 or more ways to access a system or network. MFA adds an extra layer of security by requiring users to prove their identity using multiple methods, like a password and a fingerprint scan. Identity and Access Management Services, or IAM, is a collection of processes and technologies that help organizations manage digital identities in their environment. These services enable you to create, manage, and delete users and groups, and assign and enforce access policies. And that's a wrap. Understanding key concepts of identity management in the cloud, like RBAC, SSO, MFA, and IAM services, and how to apply them to cloud-based resources will increase your effectiveness as a cloud security professional. By implementing these principles, you'll be way on your way to securing your cloud environment. In our ever-evolving digital world, security is essential to protect sensitive data and prevent unauthorized access. With the growing threat of cyber attacks, it's essential to have robust security measures in place to safeguard against potential breaches. Fortunately, the AAA framework provides a reliable and effective way to help ensure security in computer systems. So, what are the 3 essential components of AAA? Authentication, authorization, and auditing, or AAA for short, describes a security framework that is used to verify the identity of users or groups in systems and grant them access based on their privileges. Let's examine each component. First is authentication. Authentication is the process of verifying who someone is. A common example is using a password to authenticate a user on a server, but relying solely on passwords is insufficient, leading to the development of multi-factor authentication, or MFA. MFA is a security measure that requires a user to verify their identity in 2 or more ways to access a system or network. Importantly, MFA prohibits the use of identical factors for authentication, adding an extra layer of security that helps protect against unauthorized access. Examples of MFA include combining a password with a fingerprint scan or a one-time code sent to a user's phone. This approach significantly reduces the risk of unauthorized access, as malicious actors would need multiple forms of authentication to breach the system. Next, we have authorization. Authorization is the concept of granting access to specific resources in a system. One form of authorization is role-based access control, or RBAC. RBAC is a method of controlling access to resources based on the roles assigned to users. RBAC streamlines the process for administrators, allowing them to manage permissions collectively rather than individually. Understanding the differences between authentication and authorization, their respective roles in identity management and access control, and their importance in maintaining system security is crucial. By implementing strong authentication and authorization processes, organizations can ensure that only authenticated and authorized users access their systems, and that those users can access only the resources they need to perform their job functions. Finally, there's auditing. Auditing is the process of recording and reviewing system activity to ensure compliance with security policies and identifying potential security breaches. The primary purpose of auditing is to ensure that any deviations from the expected behavior of a resource are identified and addressed. Auditing also helps identify potential security threats and vulnerabilities. There are several types of audits that can be conducted, including compliance audits, security audits, and operational audits. Compliance audits ensure that the organization is complying with the relevant laws and regulations. Security audits assess the security posture of the information system. Operational audits evaluate the effectiveness and efficiency of the system's operations. An audit is only effective when its objectives are clearly defined from the beginning. These objectives should be specific, measurable, achievable, relevant, and time-bound. These are called SMART goals. Audit objectives should align with the organization's overall goals and objectives. By establishing clear audit objectives, auditors can focus on the efforts on areas that are most critical to the organization's security. Simultaneously, auditors need to choose suitable tools and techniques that also align with the audit objectives and scope to help streamline the audit. The AAA framework, authentication, authorization, and auditing, provides a comprehensive and effective approach to ensure the confidentiality, integrity, and availability of cloud resources. By implementing this framework, organizations can safeguard their data and systems against cyber threats and breaches. With this in mind, use SMART goals to audit your organization's compliance, security, and operational systems to identify potential security threats and vulnerabilities. Remember, prevention is always better than response. You may come across security practices in your everyday life. For example, businesses lock their doors when they close for the day and often keep security cameras on premises. You can compare these business security practices with a cloud security team's security principles to keep their organization's services and accounts safe. In this video, we'll discuss important topics related to security risk and best practices to help keep systems and data secure and protected. Specifically, security principles will include credential management, secrets management, non-interactive access, and security protocols to protect your systems from security risk. As a cloud security professional, credential management is a good place to start. The risks associated with unauthorized access to data are primarily because of inadequate credential management practices. If your organization's users create weak passwords, share their credentials, or fail to change credentials regularly, threat actors can easily gain access to your systems. To avoid such risk, it's important to require strong and unique passwords for all user accounts, and require users to regularly change passwords. Users can also use a password manager to securely store and manage their credentials. Another important concept is secret management. Secrets are sensitive information like application programming interface, or API, keys, passwords, and certificates that are used to authenticate and authorize access to systems. Your cloud security team will want to manage your organization's secrets to prevent threat actors from compromising sensitive information, which may lead to negative consequences. Best practices for managing secrets include using a centralized secret management tool, strong encryption methods to protect them, and regular rotation of API keys, passwords, and certificates. This way, unauthorized users are unable to use secrets to exploit services or gather data. Non-interactive service accounts are another security risk that your security team needs to address. These accounts are created for automated processes and services and are often overlooked. If not properly managed, they can provide an easy entry point for malicious actors to infiltrate your systems. To mitigate this risk, it's important to regularly review and audit these accounts, rotate keys associated with service accounts regularly, and limit their privileges. Now that we've covered some primary security risk, let's dive into some important security protocols that can help protect your systems. MTLS, OAuth, and OpenID are three common protocols that provide secure communications between different systems and services. Let's explore each of the protocols and understand their role in securing user communication and network access. MTLS, or Mutual Transport Layer Security, is a protocol that provides mutual authentication and encryption between servers. It's a variation of the Transport Layer Security, or TLS, protocol that secures communication between a client and a server. With MTLS, both the client and the server authenticate with each other, ensuring that the communication is secure and private. This helps prevent potential breaches or attacks and ensures that only authorized parties can access the information being exchanged. Open authorization, or OAuth, is a method that allows users to grant applications access to their information on other sites or systems without the need to share their passwords. For example, if you want to allow an application to access your Google Drive account, you can use OAuth to securely authorize the application to access your account without sharing your credentials. This ensures that your credentials will not be compromised and you have control over the access given to the application. Finally, OpenID is a protocol that is used for single sign-on functionality, allowing users to authenticate once and access multiple services. The process involves the user authenticating with an identity provider in exchange for an identifier. This identifier can then be used on another site or service without the user having to authenticate on that site or service for a second time. This simplifies the login process for users and reduces the risk of password fatigue and credential reuse. It's critical to implement best practices for credential management, secrets management, and non-interactive access and security protocols to protect your systems from security risk. By following these practices, you can ensure that your systems and data are secure and protected, allowing the appropriate people to reach the information they need. Imagine you're a receptionist working at a front desk of an apartment complex. It's your responsibility to decide who you let in. The concept of access controls and security works in a similar way. In this video, we'll discuss the different types of access controls and how they can be implemented to keep your cloud resources secure. Let's get started. Access control is a crucial element of cybersecurity because it ensures that only authorized individuals can access your data and resources. There are three main types of access controls: discretionary, mandatory, and role-based access controls. First is discretionary access control, or DAC, a security model where the owner of the data or resource has the discretion to grant or revoke access to other users. For example, in Google Drive, it's possible to share only view access with an individual to one specific file, while simultaneously providing edit access to a different file. Both files can reside within the same directory. These varying levels of access, from partial to full, from the owner of the files are discretionary. In a cloud environment, DAC can be implemented using Access Control List, or ACLs. ACLs specify the permissions for each user or group. Next is Mandatory Access Control, or MAC, which is a strict security model in which access is granted based on predefined security policies. For example, a private company's information is classified into three categories: confidential, internal, and public. The company controls the distribution of crucial information under the confidential classification by granting access on a need-to-know basis. By assigning individual permissions based on the required access levels, the company successfully secures its proprietary information. In a cloud environment, MAC can be implemented using security labels or tags, which are assigned to both data and users. Access is only granted if the user's security label matches the data's label. Now, Let's discuss role-based access control, or RBAC. RBAC is a method of controlling access to resources based on the roles assigned to users. In a cloud environment, RBAC can be implemented by assigning users to different roles and managing permissions at the role level. In some cases, it may be necessary to implement role hierarchies to simplify the management of permissions. Role hierarchies allow higher-level roles, such as a user with edit access to a Google Drive directory, to inherit permissions from lower-level roles, such as a user with view access to a Google Drive directory, ensuring that the users with more responsibility have the necessary access to perform their duties. In other words, a user that can edit can also view documents in a directory, though a user with view access will not be able to edit documents in a directory. Finally, attribute-based access control, or ABAC, is a security model where access is granted based on the attributes like user resource and environment. In a cloud environment, ABAC works by creating policies that define the conditions under which access is granted or denied. These policies can be based on a variety of attributes like the user's job title, the sensitivity level of the data, or even the current day and time. Implementing ABAC in a cloud environment typically involves setting up a policy decision point, or PDP, and a policy enforcement point, or PEP. The PDP evaluates policies and makes access decisions, while the PEP enforces those decisions by granting or denying access to the resources. As a cloud security professional, you'll need to apply a multifaceted approach to effectively implement access controls in the cloud and secure your data. One key component to implementing access controls in the cloud is identity and access management, or IAM. Remember, IAM allows you to manage users, groups, roles, and permissions across your cloud environment. Along with IAM, organizations must consider policies and resource hierarchies. These are crucial for structuring and enforcing access controls. Now that you know the different access control types, let's discuss some best practices for implementing access controls in cloud environments. The top 3 best practices include: 1. Apply the principle of least privilege, granting users only the permissions they need to perform their tasks. 2. Separate duties to minimize the risk of unauthorized access or actions. 3. Regularly audit access controls in your cloud environments to ensure access permissions are up to date. Then review and update and add or revoke access when necessary. By implementing these access controls, you can ensure the security of your data in the cloud. Remember, as a receptionist of the cloud, you only want to let approved guests and visitors into the building. Setting boundaries is important. In this video, you'll learn the different types of perimeter protection, explore various types of defenses, and learn about the importance of trust boundaries. Finally, you'll learn best practices for configuring and managing these controls. This is all very exciting stuff. Let's get into it. With the increasing adoption of cloud environments, perimeter protection has been more essential than ever. In a cloud environment, perimeter protection refers to the security measures implemented at the edge of a network or system to defend against unauthorized access and cyber threats. As a cloud security professional, there are several types of perimeter defenses that can be implemented to protect a cloud environment. Let's explore some of them. Identity and context-based access is increasingly becoming the first line of defense because it offers a robust security solution compared to traditional methods. Firewalls typically are only for internal networks and can help prevent lateral movement within the system. Intrusion detection systems, or IDS, monitor network traffic, check for signs of suspicious activity, and alert administrators when detected. Moving along the same lines as the intrusion detection system, IDS, we come across a similar yet distinct system, the intrusion detection and prevention system, IDPS. Intrusion detection and prevention systems, or IDPS, monitor network traffic for signs of malicious activity and either alert the administrator or actively block the threat, or both. Virtual private networks, or VPNs create a secure, encrypted tunnel for data to travel between the cloud environment and the user, ensuring that data remains confidential and safe from prying eyes. Finally, access control lists, or ACLs, restrict access to resources in the cloud, ensuring that only authorized users have access to specific data or services. Trust boundaries are a crucial aspect of perimeter protection because they define the points in a network where the level of trust changes, like transitioning from a trusted internal network to an untrusted external network. For example, you can use systems like firewalls and routers to separate the public internet from the internal corporate network at both physical and logical levels. This action establishes and maintains a clear boundary between trusted and untrusted environments, providing a vital layer of security for the organization. An office building is like a trusted network, with each floor representing different sectors. Inside this network, doors and walls represent the firewalls. Think of the outer walls of the office building as the shift from a trusted network moving into untrusted territory, like the public internet. Now, imagine some offices in the building. These offices are trusted spaces with an extra security measures like locked doors. These spaces are like a company's private secure zones that contain critical information. Other rooms, like the lobby or an outdoor patio, would be the untrusted spaces. They're more open, like public areas in a company's network, but still have basic security. The key point is that trusted or untrusted isn't about the room itself, but about the level of protection and the sensitivity of the information within. Regular checks like office security inspections help keep both real and digital environments secure. Without clearly defined trust boundaries, your network is at risk of unauthorized access, data breaches, and other security issues. Establishing trust boundaries can help you better manage access to sensitive data and identify potential vulnerabilities. Now that we understand the importance of perimeter protection and trust boundaries, let's discuss some of the best practices for configuring and managing these controls to ensure your cloud environment is secure. These best practices can be categorized into 3 primary areas: improve cloud network security, monitor and control access, and maintain security policies and training. Here's how you can improve cloud network security. Implement network architecture that always requires user authentication. Segment networks, use microperimeters and apply context-aware access controls, and define trust boundaries between network zones based on risk and required access controls. To monitor and control access, follow these best practices. Regularly review and update firewall rules. Deploy cloud-based IDS, IPS solutions for protection, and implement secure remote access solutions and enforce strong authentication methods. Lastly, you can maintain security policies and trainings in these ways. Audit and update IAM policies for least privileges. Train employees on cloud security best practices and enforce strong password policies and multi-factor authentication, or MFA. By understanding the concepts of perimeter protection, trust boundaries, and implementing cloud security best practices, you can significantly improve the security of your cloud environment. Remember, the best defense is a good defense. Think about what it's like for someone just learning how to play a new game. There are rules or guidelines to follow and strategies to win. Just as in learning a new game, knowing how malicious actors operate allow you as a cloud security professional to stop them more easily. In this video, we'll discuss attack vectors and their significance for network and system security. We'll explore various attack vectors, understanding their impact on security, and discuss common examples, along with effective countermeasures. Let's first explain attack vectors. Attack vectors are pathways attackers use to penetrate security defenses. Now, let's learn the guidelines of using attack vectors. 1. Gain insight into attack vectors that are vital for network and system security. 2. Once you gain insight into attack vectors, pinpoint potential vulnerabilities and effectively defend against these targeted attacks. Next, We'll discuss strategies using countermeasures to help you overcome common attack vectors that impact perimeter and boundary protections. Malicious actors may use social engineering techniques that exploit human mistakes to gain access to sensitive data or valuables. Examples of social engineering are phishing, vishing, smishing, and spear phishing attacks. These types of social engineering attacks involve the use of digital communications to trick people into revealing sensitive data or deploying malicious software. To counter this, you can implement user training and email security measures. Next, password attacks are a widespread threat that usually involve brute force techniques in which attackers use trial and error to reveal private information. To significantly improve security, strengthen your password policies and incorporate multi-factor authentication. Cybercriminals might also exploit vulnerable software by taking advantage of known vulnerabilities. Remember, a vulnerability is a weakness that can be exploited by a threat. To counteract this, it's crucial to regularly patch and update software and use vulnerability scanning tools. Then there's malware, or software designed to harm devices or networks, which infiltrate and compromise systems. To combat malware, use advanced malware protection solutions and regularly update your software. Lastly, distributed denial of service, or DDoS attacks, are a type of denial of service attack that uses multiple devices or servers located in different locations to flood the target network with unwanted traffic. This can cause service outages and potential unauthorized access. To protect your company from these attacks, deploy DDoS mitigation services and monitor network traffic. It's important to know the threat actors you might encounter and how they think. You'll first need to understand guidelines of using common attack vectors. Next, you can utilize strategies to implement robust perimeter and boundary protection measures. Then, you're in a position to keep your network and systems secure. User authentication, or verification, is similar to receiving a phone call, and the phone displays the caller's name and number. Verification allows organizations to help ensure that an individual accessing any asset or piece of data is who they claim to be. In this video, we'll explore the Zero Trust security model and how it differs from traditional models. We'll also discuss its core principles and the network security mechanisms involved. Traditional access control models like role-based access control, or RBAC, and discretionary access control, or DAC, were designed with the assumption that everything within a network perimeter could be trusted. But this assumption can no longer be made because organizations have embraced remote workforces, cloud-based infrastructure, and Internet of Things, or IoT devices. In these new environments, the perimeter is no longer a clearly defined boundary, creating opportunities that can be exploited by malicious actors. In recent years, the adoption of the Zero Trust security model has been one of the most significant shifts, offering a more robust and adaptable approach to security in today's complex distributed IT environments. Zero Trust is based on the principle of never trust, always verify. This means that every user, device, or system must be authenticated and authorized before accessing any resources or data. This approach assumes that any user or device, whether inside or outside the network perimeter, could be compromised. So every access request must be validated and authorized on a case-by-case basis. By shifting the focus from perimeter security to securing individual resources, Zero Trust offers a granular approach to access control. Granular access control allows for more defined control over access, as permissions can be granted or restricted based on specific conditions. Let's discuss the core principles of Zero Trust. The first principle is verify explicitly. This means that every access request must be authenticated and authorized before access is granted to any resource. The second principle is apply least privilege access. This means that users, device, and systems should only be granted the minimum access necessary to perform their task. The third principle is assume breach. Organizations embracing zero trust should operate on the assumption that a breach has already happened or will happen and design their security measures accordingly. Now, let's discuss how organizations can implement zero trust policies using key access control mechanisms. These mechanisms include identity and access management, or IAM, multi-factor authentication, or MFA, microsegmentation, and network access control, or NAC. We've already defined IAM and MFA. Now, let's focus on microsegmentation and NAC. Microsegmentation is a security technique that divides a network into smaller, isolated segments to limit unauthorized access and reduce the potential attack surface. Note that an attack surface includes all the potential vulnerabilities that a threat actor could exploit. This approach ensures that even if an attacker gains access to one segment, they can't easily move within the network. Network Access Control, or NAC, is a security solution that enforces policy-based access controls to network resources, ensuring that only authorized devices and users can access the network. NAC's core function doesn't just stop at policy enforcement. It extends to identification, monitoring, and control of devices and users on the network. By employing these mechanisms, organizations can strengthen their security posture and minimize the potential attack surface. Another critical aspect of zero trust is the use of context-aware access controls. Context-aware access controls are decisions about granting or denying access to resources based on the user's identity and contextual information. Resources can include the user's location, device, and system access patterns. By incorporating this additional data, zero trust can make more informed access control decisions, reducing the risk of unauthorized access. As a cloud security professional, it's essential to understand how Cloud Access Security Brokers, or CASBs, and Secure Access Service Edge, or SASE, platforms can assist organizations in implementing zero trust policies, or ZTP. CASBs act as intermediaries between cloud service users and cloud service providers, enabling organizations to enforce security policies and maintain visibility over cloud-based activities. By incorporating ZTP, CASBs can restrict access to sensitive data based on user identity, device, and context, ensuring that trust is not automatically granted. SASE platforms, on the other hand, combine network and security functions into a single cloud-based service. By integrating ZTP with SASE, organizations can apply adaptive security policies based on real-time context like user identity, device, location, and application. This approach eliminates the traditional trust boundaries and ensures that access is continuously evaluated and granted only when necessary. Both CASBs and SASE platforms play an important role in helping organizations implement ZTP by providing granular access controls, continuous monitoring, and adaptive security policies based on context. To wrap up, the Zero Trust security model represents a shift in the approach to access control, better securing today's complex, distributed IT environments. In a future role as a cloud security professional, you'll be well prepared to help organizations stay ahead of emerging threats and protect critical assets in an increasingly interconnected world. Congratulations, you made it! During this section, you gained essential knowledge and practical abilities to maintain an organization's asset securely within cloud environments. We dove into the intricacies of identity management and access control, gaining insights into vital concepts like single sign-on, or SSO, multi-factor authentication, or MFA, and identity and access management, or IAM services. You also learned about various access control mechanisms, the significance of trust boundaries, and the foundational principles of the Zero Trust security model. You began this course by exploring the core principles of identity management and access control within a cloud environment, focusing on SSO, MFA, and IAM services offered by cloud providers. Second, you explored the different types of access controls employed in a cloud environment, including role-based access control, or RBAC, and attribute-based access control, or ABAC. Finally, you learned about trust boundaries, identified best practices for configuring and managing defense, and how the Zero Trust security model employs mechanisms like IAM, MFA, microsegmentation, network access control, and encryption to strengthen security posture. Great job with the progress you made so far. You're doing awesome. Welcome. I'm so glad you're here. We have a lot of fascinating topics to cover. This section will cover three main topics: effective threat management, asset management and cloud security, and vulnerability remediation and posture management. The first topic you'll start by exploring is the significance of effective threat management in protecting an organization's assets, reputation, and operational efficiency. Then, you'll dive into the elements of a successful threat management strategy, including risk identification, assessment, prevention, detection, and response. Next, you'll uncover how to address challenges in executing threat management programs, like limited resources and evolving threats, by emphasizing continuous employee training, proactive risk management, and collaboration with industry experts to stay informed on trends and best practices. In the second topic, you'll discuss best practices for asset management in cloud security, and dive into the crucial aspects of managing and optimizing your organization's resources. Our focus will be on ensuring you're well-versed in the most effective strategies for tracking, maintaining, and optimizing your assets. You'll also find out about various tools and technologies for streamlining asset management. You'll then learn valuable tips for maintaining accurate and up-to-date records of your assets, and emphasize the significance of data integrity and consistency. This knowledge is crucial for making informed decisions and minimizing the risk of expensive errors. The third and final topic covers vulnerability remediation and posture management. You'll inspect secure configuration and posture management in cloud environments, and give you the knowledge to protect your organization's data and resources from potential threats. You'll also dive into best practices for vulnerability remediation and posture management so that you can effectively and efficiently identify, assess, and tackle potential risks. Finally, you'll review information about emerging trends and technologies in threat management to keep you updated on the latest advancements and innovations, so you can enhance your organization's security posture. By the end of this section, you'll have a comprehensive understanding of threat management, asset management, and vulnerability remediation and posture management in a cloud environment. This will have you well on your way to navigating the cloud security environment with ease. As technology continues to advance, cyber threats are becoming more sophisticated and widespread. It's no longer if an organization will be targeted, but when. That's why having an effective threat management strategy is crucial for protecting your organization's digital assets. In this video, we'll discuss the essentials of establishing a strong threat management strategy. A threat management strategy is a comprehensive plan that addresses the various types of cyber threats an organization may face. This strategy should include preventive measures, incident response procedures, and regular audits. The key component of effective threat management strategy are prevention, detection, response, and recovery. Prevention involves implementing security controls to prevent cyber attacks from occurring in the first place. This includes firewalls, endpoint protection software, and access controls. Detection involves monitoring systems and networks for any signs of suspicious activity. This includes intrusion detection systems, log analysis, and security information and event management, or SIEM systems. Response involves quickly identifying and containing any cyber attacks that occur. This could include incident response plans, communication protocols, and emergency response teams. And finally, recovery involves restoring systems and data to their pre-attack state. This could include backups and disaster recovery plans. As a cloud security professional, implementing an effective threat management strategy is not without its challenges. One of the biggest challenges is the constantly evolving nature of cyber threats. As soon as you think you've handled one threat, another one emerges. Another challenge is the lack of resources and expertise in the field of threat management. A lot of organizations struggle to keep up with the latest threats and don't have the staff or resources to effectively manage them. Finally, there's a challenge of balancing security with productivity. Organizations need to ensure that their threat management strategies don't hinder their employees' ability to do their jobs. So, what can organizations do to overcome these challenges and implement an effective threat management strategy? The first step is to stay informed about the latest threats and trends in cloud security. This can include training, attending conferences, and staying up to date on the latest industry news. The second step is to invest in the right tools and technologies to help you manage threats more effectively. This can include next-generation firewalls, NGFWs, intrusion detection systems, and threat intelligence platforms. Ultimately, organizations must encourage and reinforce cybersecurity awareness among their employees, especially because people represent the most susceptible element in security systems. For step 3, organizations can support their employees when they create a culture of awareness through regular training and maintaining clear communication about the importance of security measures. Organizations rely heavily on IT systems to operate efficiently. But without proper maintenance and regular audits, systems can be vulnerable to cyber attacks and downtime. Regular audits can help identify vulnerabilities in your system that may have gone unnoticed. By being proactive, you can address these vulnerabilities before malicious actors can exploit the system. Downtime can be a severe issue for any business. It can lead to lost revenue, decreased productivity, and even damage the business's reputation. Regular audits can help increase system uptime when the system is working by identifying potential issues before they cause downtime when the system isn't working. Audits provide valuable insight into the health of your cloud resources. By understanding your audit results, you can make informed decisions on where to invest resources to ensure your systems are working at peak performance. In summary, regular audits are critical to protect organizations from cyber attacks, increase system uptime, and uncover vulnerabilities that may have gone unnoticed. In this video, you explored the fundamental components of a threat management strategy, uncovered how to address potential challenges, and learned the importance of regular audits for enhancing cyber defenses. By taking these insights into account, you'll become better prepared to actively protect your organization from the rising regularity of sophisticated cyber threats.
My name is Ari. I am the lead security engineer for Google's threat analysis group. Basically, we try to protect Google's users as well as Google itself. And we do this by having these 3 different missions, namely tracking financially motivated threat actors, tracking disinformation, as well as tracking various government-backed threat actors. My favorite thing about my job is that we are basically protecting the more vulnerable population of the internet. This includes activists, dissidents, journalists, as well as other political entities. How did I get started? Somewhere between my junior and senior year of undergrad, I ended up joining a cybersecurity competition. I haven't been around other people that were very much interested in security before. So going to the cyber camp, I was like, oh, this is awesome. And I love the vibe, and everyone was so friendly and sharing tips and all that. I was actually enjoying myself. So I was like, yes, this is for me. A lot of companies have information or data in the cloud, and it's very important to protect these assets. Having knowledge of how to secure these assets in the cloud is very important as a skill, especially when you're trying to work in cybersecurity, as everyone is moving all of their data into the cloud. If you're just starting out in your cybersecurity career, my advice would be to go seek out mentors. Aside from trying to learn everything you can, trying to watch videos, trying to take time to read books, I would also reach out to a few people that you admire. A lot of the people in cybersecurity are very helpful. You can go to a lot of conferences, or you can join various different local communities, as well as basically just going through your local cybersecurity meetups. There's a lot of people that have helped me out and pointed me to the correct resources in order for me to further my skills as well as further my career. Working in cybersecurity, I think, is very much like an adventure. Sometimes you don't know what you're gonna get, right? Sometimes it's gonna be awesome and it's gonna be amazing. Sometimes like it's a very difficult adventure, but at the end of the day, you actually end up learning something.
Organizing a closet is one of those chores we might put off. The longer you wait and the more you pile into the existing pile, the more work you'll have to do later. When you access a well-organized closet, it'll take you less time to get what you need, and so you'll be more efficient. Maybe you'll even save some money because you won't have to buy something you couldn't find in a messy closet. Proper asset and resource management, similar to a closet, saves time and increases efficiency and can help cut costs. In this video, you'll learn more about the role of asset management in maintaining a secure and well-organized digital environment. We'll uncover best practices for managing your assets and tools and technologies that can help streamline these processes. You'll also learn tips for maintaining accurate and up-to-date records to ensure a smooth and efficient asset management process. Ready? Let's get started. You may be wondering, what is asset management? Asset management is the process of tracking assets and the risks that affect them. Effective asset management is key for maintaining a secure environment because it helps organizations identify and track critical assets, detect and respond to security incidents more effectively, and mitigate risk associated with unauthorized access, data breaches, and other cyber threats. In the context of cybersecurity, asset management involves identifying all devices, software, and data within the organization, classifying assets based on their sensitivity and criticality, tracking assets throughout their life cycle, from procurement to disposal, and ensuring proper security controls are in place for each asset. Let's examine some best practices for asset management. First, it's important to develop an asset inventory and create a comprehensive, centralized inventory of all digital assets, including devices, software, and data. This inventory should include information like asset type, location, owner, and any associated security controls. Next, categorize assets based on risk. Assess the risk associated with each asset and categorize them accordingly. This will help prioritize security efforts and allocate resources more effectively. It's important to establish ownership and accountability. Assign clear ownership and accountability for each asset to ensure that they are properly managed and protected. Then, you can make sure to implement access controls. Establish access controls to limit who can access specific assets and ensure that only authorized personnel have access to sensitive data. Finally, monitor and audit assets regularly to identify any potential security risk, unauthorized access, or changes to the asset. There are a variety of tools and technologies that can help streamline the asset management process. The first tool we'll discuss is IT Asset Management, or ITAM software, a centralized application designed to manage and track the lifecycle of your organization's IT assets. ITAM software offers a comprehensive inventory of software and hardware within a business environment, including details like purchase dates, prices, license information, and serial numbers. ITAM software also streamlines the process of tracking, monitoring, and managing your IT assets. Next is the Configuration Management Database, or CMDB, a repository designed to store data about your entire IT environment, including its relationships between hardware and software assets. This provides a holistic view of your IT infrastructure, allowing for better understanding and management. Then, there are network scanners and discovery tools, which can help identify and catalog all your devices connected to your network, providing visibility into your organization's assets. Last but not least are vulnerability scanners. Vulnerability scanners can help identify potential security risk and vulnerabilities in your organization's assets, allowing you to prioritize remediation efforts. To ensure a smooth and efficient asset management process, it's essential to maintain accurate and up-to-date records. Here are 4 useful tips to help you achieve this. 1. Establish a centralized asset repository. Create a single, centralized location for storing all asset-related information to make it easier to manage and access. 2. Automate asset discovery and updates. Utilize tools and technologies that can automatically discover and update asset information, reducing the risk of human error and ensuring that your records are always current. 3. Implement a regular review process. Schedule regular reviews and audits of your asset records to identify and correct any discrepancies or outdated information. Finally, train your staff. Provide training and resources to your staff on the importance of asset management and clearly define their role in maintaining accurate records. Effective asset management is an important aspect in a robust cybersecurity strategy. By following best practices, utilizing the right tools and technologies, and maintaining accurate and up-to-date records, you can ensure that your organization's assets are well protected and secure. In this video, we'll discuss how a comprehensive asset management system provides transparency and continuous monitoring for cloud resource usage. You'll also learn the steps for effective asset management, including identifying assets, categorizing them based on risk levels, and maintaining accurate digital records. It's important to call out. Our discussion in this course should not be considered legal advice. As a cloud security professional, the first step in effective asset management is to identify all the assets within your cloud environment. When the cloud security team identifies assets, it helps them understand the scope of their cloud environment and prioritize resources based on their criticality. Assets include servers, like virtual machines, which run your applications and services within your cloud environment. Databases, which holds your organization's data and are important components of your cloud infrastructure. Applications including various software programs and tools, web applications, mobile apps, and application programming interfaces, or APIs. Other resources like load balancers, storage buckets, and network components are also part of your cloud environment. Once you identify assets, you'll continue to the second step in effective asset management, risk tiering. Risk tiering is a process that enables organizations to identify and categorize their assets based on their importance and potential impact. There are 3 tiers. You'll devote a different amount of time, energy, and resources to each tier. For high-risk assets, you'll provide the most attention and protection to assets like sensitive data and mission-critical applications. For medium-risk assets, you'll provide substantial attention and protection to assets like internal documentation and finances. For low-risk assets, you'll provide a small amount of attention and protection to assets like public information and non-copyrighted material. Risk tiering helps organizations allocate resources effectively and focus on the most critical assets. Let's examine an example of risk tiering in a healthcare organization. High-risk assets include electronic health records, or EHR, which contain sensitive patient information, proprietary research data, and mission-critical applications like hospital management systems. These assets require the highest level of protection, like access control and regular security audits. Medium-risk assets include internal communication systems, employee records, and billing information. While not as critical as high-risk assets, medium-risk assets still require a solid level of protection to prevent unauthorized access and data breaches. Low-risk assets include general information about the organization, like marketing materials, public-facing websites, and non-sensitive internal documents. Even though low-risk assets need protection, they can be allocated fewer resources and are a lower priority compared to higher and medium-risk assets. By risk tiering their assets, the healthcare organization can allocate resources more effectively. The organization can then focus on protecting the most critical assets that have the highest potential impact on the organization, should the assets be compromised. After you perform risk tiering, it's time for the third step in effective asset management. Maintain effective oversight. As a cloud security professional, it's a must to have an accurate and up-to-date inventory of all your cloud assets. This inventory should include information like asset type, location, ownership, and risk level. Regularly updating your inventory helps ensure you have a clear understanding of your cloud environment at all times. Implementing a comprehensive asset management system involves monitoring and tracking changes to your assets. This includes monitoring asset configurations, access controls, and vulnerabilities. By continuously monitoring your assets, you can quickly detect and respond to potential security issues. The process you follow to monitor and track assets is called asset lifecycle management, which helps organizations optimize their cloud resource usage and reduce potential security risks. Asset lifecycle management encompasses planning, which entails defining procurement requirements and handling capital expenditure, and addressing all aspects of the asset lifecycle, from acquisition and deployment to maintenance and disposal. Planning ensures a seamless process. Let's check out an example of lifecycle management. A software company recently migrated its application and services to a cloud environment. To ensure effective asset management, the company follows these steps. Acquisition. The company selects the appropriate cloud resources like virtual machine, storage, and databases based on their specific requirements. Deployment. The company deploys these resources in a well-organized way to ensure seamless integration with their existing infrastructure. Maintenance. The company regularly monitors the performance of its cloud resources and updates assets as needed to maintain optimal performance. They also ensure that security patches and updates are applied to reduce any potential vulnerabilities. Disposal. When a cloud resource is no longer needed, the company securely disposes of it by following the proper decommissioning process. This includes deleting any sensitive data and ensuring that the resource is no longer accessible, reducing the risk of unauthorized access. By following these steps, the software company can effectively manage the lifecycle of its cloud assets, optimizing resource usage and minimizing security risk. In this video, you learned that implementing a comprehensive asset management system is vital for maintaining transparency and oversight over your cloud resource usage. By identifying and risk-tiering assets, maintaining an accurate inventory, monitoring changes, and managing the asset lifecycle, you can ensure the security and efficiency of your cloud environment. The more you can effectively establish the security of a cloud environment, the more confidence you and your organization will have in the security of your assets. As a cloud security professional, sometimes you can correct or even mitigate problems when you take a step back and try to view the whole picture and identify what the end result is supposed to be. In this video, we'll explore vulnerability remediation and posture management in a cloud environment, review secure configuration, and discuss the importance of these concepts in maintaining a secure cloud environment. Let's first examine vulnerability remediation. Vulnerability remediation is the process of identifying, assessing, and resolving security vulnerabilities in your cloud environment. Vulnerability remediation is a process that typically involves 6 steps. 1. Identify vulnerabilities through automated scans, manual testing, or third-party reports. 2. Assess the severity and impact of these vulnerabilities on infrastructure and operations. 3. Prioritize vulnerabilities based on their severity, potential impacts, and ease of exploitation. 4. Implement patches, updates, or configuration changes to address those vulnerabilities. 5. Verify the remediation efforts to ensure that you've effectively resolved the vulnerabilities. And 6. Document the details of the vulnerabilities, your remediation efforts, and any lessons learned for future reference. This comprehensive approach helps ensure a secure and resilient cloud environment for your organization. Now we'll explore posture management, or the continuous process of monitoring, assessing, and maintaining the security stance of an organization's cloud resources. During this process, your cloud security team ensure that the cloud infrastructure is configured and operated securely, adhering to best practices and compliance requirements. Posture management typically follows 6 steps. 1. Monitor the cloud environment. In this step, you'll detect potential security threats, misconfigurations, and compliance violations. 2. Evaluate the security posture. In this step, you'll assess the robustness of the security posture by comparing the current state to establish security standards and best practices. 3. Report. In this step, you'll create regular reports and dashboards that highlight areas of concern and improvement. 4. Remediate. In this step, you'll address security issues through vulnerability remediation, configuration changes, and other corrective actions to ensure a secure environment. 5. Implement and enforce security policies. In this step, you'll ensure that cloud resources are consistently configured and operated securely. 6. Regularly review and update security policies, procedures, and controls. In this final step, you'll keep pace with evolving threats, technologies, and business requirements, fostering continuous improvement in cloud security. Now let's review the definition of secure configuration. Secure configuration refers to the practice of setting up your cloud resources with the proper security settings and configurations to minimize potential risks. This includes following best practices, like limiting access to sensitive data and regularly updating software and applications. So why are secure configuration and posture management important in a cloud environment? Well, they help prevent unauthorized access, maintain data integrity, and protect your cloud resources from potential threats. In conclusion, vulnerability remediation and posture management are crucial aspects of maintaining a secure cloud environment. By adopting secure configuration practices, you can effectively prioritize remediation efforts and ensure the safety of your data and applications. Once you know where your organization might be vulnerable, you can take additional steps to properly secure those assets. Identifying weaknesses is just as important as developing security infrastructure. In this video, we'll discuss vulnerability remediation and posture management as they relate to software development. As a cloud security expert, it's important for you to understand and apply those concepts to ensure the safety of your software and systems. Let's start off by reviewing vulnerability remediation and posture management. Recall that vulnerability remediation is the process of identifying, assessing, and resolving security vulnerabilities in your cloud environment. This can include system patching, package rebuilding, or other external mitigations. Now, let's return to posture management, the continuous process of monitoring, assessing, and maintaining the security stance of an organization's cloud resources. This process helps organizations stay ahead of potential threats and minimize risks. In the world of software development, it's important to ensure the security and integrity of applications. One key aspect of this process is vulnerability remediation and management, which helps prevent security breaches and protects data while maintaining the integrity of applications. Imagine a software development team is working on a web application that handles sensitive user data, like personal information and financial transactions. During the development process, the team discovers a vulnerability in the application's authentication system, which could potentially allow unauthorized users to gain access to sensitive data. The software development team will complete the following steps to address vulnerabilities in an application. First, they need to identify the vulnerability. To do this, the team must understand the vulnerability and how potential attackers could exploit it. Tasks may involve reviewing code, consulting documentation, and researching known security issues related to the active technologies the organization uses. The team can conduct an impact analysis on vulnerabilities to complete these tasks. This analysis will help the team address potential consequences and set how they prioritize the urgency of issues. After that, the team needs to develop a remediation plan. Once the vulnerability has been identified, the team needs to develop a plan to address the issue. This may involve updating software libraries, modifying code, or implementing new security measures. Next, they need to implement the remediation. The team must implement the changes outlined in the remediation plan to ensure that the vulnerability is effectively addressed and that the application is no longer susceptible to the identified security risk. Then the team needs to test the solution. After implementing the remediation, the team should thoroughly test the application to ensure that they've resolved the vulnerability and that they didn't introduce any new issues as a result of the changes. And finally, they need to monitor and maintain. The team should continuously monitor the application for any new vulnerabilities and be prepared to address them as they arise to ensure the ongoing security of the application. By effectively addressing vulnerabilities through remediation, the software development team can prevent security breaches, protect user data, and maintain the integrity of their application. This will also ensure they provide a safer and more reliable experience for their users. There are several types of remediations. Let's explore 4 of them. Hotfixes are quick, temporary fixes for critical vulnerabilities that require immediate attention. Hotfixes are unscheduled because of urgent and time-sensitive needs. Also, hotfixes are usually added into patches at a later stage, which helps to make the system stronger over time. Security patches are updates that address specific security vulnerabilities. Unlike hotfixes, they're usually scheduled and systematically planned. A key feature of security patches is their ability to simultaneously fix multiple security issues, enhancing the overall security of the system. Updating dependencies involves updating or replacing third-party libraries and frameworks to more secure versions. Feature patches are updates that not only fix vulnerabilities, but also introduce new features or improvements. Follow these 5 best practices for vulnerability management and a strong security posture. First, implement a vulnerability management program that includes regular scanning, assessment, and remediation processes. Second, prioritize vulnerabilities based on severity, exploitability, and potential impact. Third, quickly apply patches and updates to minimize exposure to threats. Fourth, monitor and analyze logs and alerts for signs of potential security incidents. And fifth, continuously improve your security posture through training awareness and process improvements. Now that you have a better understanding of vulnerability remediation and posture management, you can begin applying these concepts to cloud security-related scenarios. Automation is becoming increasingly common in technology. It can help improve the efficiency of systems and strategies. In this video, we'll explore automation tools for posture management and vulnerability remediation. We'll also discuss best practices for validating security remediations to ensure compatibility and minimize potential disruptions. The features and benefits of IT automation tools include flexibility, efficiency, and consistency. These tools are flexible because they support various platforms and environments. These tools are efficient because they allow for faster deployment of updates and patches. And these tools ensure consistent configurations across systems. IT automation tools streamline the process of resource provisioning and configuration management and improve the detection and remediation of vulnerabilities. These tools play an important role in how you, as a cloud security professional, can manage complex IT infrastructure and ensure security compliance. Let's compare 2 popular IT automation tools. Ansible, a fast and simple configuration management tool, and Puppet, a more powerful but complex configuration engine. First up are the key features of Ansible. Ansible is an open source IT automation tool that helps organizations manage their infrastructure and applications more efficiently. Ansible has agentless architecture and does not require any additional software to be installed on the managed nodes. It uses yet another markup language, or YAML, for defining automation tasks. YAML makes it easier to create and maintain automation scripts. Ansible's modular design allows for the creation and sharing of reusable components, which can be used to automate tasks across multiple systems. With Ansible, you can also integrate with security tools like vulnerability scanners and intrusion detection systems to automate security tasks and enhance overall security posture. Next, here are the key features of Puppet. Puppet is another popular IT automation tool that helps organizations manage their infrastructure and ensure security compliance. Puppet uses a declarative language to specify the desired infrastructure configuration. This approach allows it to manage the implementation details itself. Puppet is designed for scalability. Puppet is suitable for organizations of all sizes because you can match the software to meet the needs of your organization, from small businesses to large enterprises. Puppet also provides comprehensive reporting and auditing capabilities, enabling organizations to track changes, demonstrate compliance, and identify potential security issues. And created with extensibility in mind, Puppet includes a wide range of modules and plugins. This enables organizations to extend its functionality and tailor it to meet their needs. Along with IT automation tools, businesses also need to have robust update and patch management tools in place. Update and patch management tools are essential for businesses to mitigate security risk. They ensure timely installation of updates and patches and address vulnerabilities, decreasing the possibility of cyber attacks. Organizations are recommended to have proper patch management processes in place to ensure the security of their systems and data. These tools help maintain compliance with various industry regulations and standards. Also, regular updates can improve system performance and stability by fixing errors and optimizing code. Finally, the automation of update and patch deployment can reduce the manual effort required from IT teams, allowing them to focus on other critical tasks. Before deploying security remediations, it's important to validate them to ensure compatibility and minimize potential disruptions. Some best practices for validating security remediations include canary testing, rolling deployments, and blue-green testing. Let's quickly review each best practice. Canary testing involves deploying a security update to a small percentage of the environments first, monitoring its impact, and then rolling it out to the rest of the environment if no issues are detected. This approach helps minimize the risk of widespread disruptions caused by a problematic update. Rolling deployments involve gradually deploying a security update across the environment in stages. This approach allows you to monitor the impact of the update on each stage and address any issues before moving on to the next stage. Blue-green testing involves creating two identical environments, blue and green, and deploying a security update to one of them while the other remains unchanged. Once the update is tested and verified in the updated environment, traffic is gradually shifted from the unchanged environment to the updated one. This approach helps minimize downtime and allows for easy rollback when appropriate. The key to helping an organization maintain a secure and well-managed cloud environment is threefold. First, use IT automation tools like Ansible and Puppet. Second, implement robust update and patch management solutions. And third, follow best practices for validating security remediations. The more you know about these tools and concepts, the more prepared you'll be to navigate modern cloud security environments. Consider the role of a vehicle mechanic responsible for maintaining and enhancing the performance of cars. Just as a car may seem to be operating smoothly, it's vital to conduct regular inspections and make necessary improvements to keep it in top condition. Systems, much like cars, also require periodic checkups and updates to maximize their effectiveness. In this video, we'll explore two key system maintenance methods, patching and rehydration. Let's get started. First up is patching. Patching is the process of installing updates to software to address vulnerabilities, improve stability, or add new features. In the context of system maintenance, patching plays an important role in keeping systems and applications secure and up to date, reducing the risk of cyber attacks. As a cloud security professional, you'll follow these mechanics of patching steps. Step 1. Develop a cloud-based inventory and baseline. The first step is creating a baseline of all the resources in your environment. This baseline is a reference point for tracking any changes. Be sure to maintain and update this list regularly. Step 2. Identify vulnerabilities and available patches for the system. Next, identify possible vulnerabilities on resources in your environment. Tools like vulnerability scanners can help you in this process. After identifying these vulnerabilities, find patches that are compatible with the system. Once you have appropriately identified the vulnerabilities and their corresponding patches, it's crucial to examine how these patches will affect the system. Step 3. Assess the patch's impact on the system. Patches may affect the performance of the system. A system evaluation should consider effects on stability, software compatibility, and performance of the patch. This evaluation should also consider the risk associated with leaving the vulnerability unpatched. Step 4. Download and test the patch in a non-production environment. Download the patch from a trustworthy source. Before deploying it in the production environment, test the patch in a non-production environment that closely resembles the existing system. This ensures the patch operates as intended without causing any additional problems. But we're not done yet. Step 5. Schedule the downtime or plan a service restart. Installing patches may require system downtime. To minimize the impact on operations, schedule this during off-peak hours. Also, make sure to communicate the estimated downtime to stakeholders. Step 6. Backup data and system configurations. Next, back up all the essential data and system configuration files. Doing so will enable you to restore the system to its previous state if the patch causes unexpected issues. With all important data and system configurations securely backed up, you can start to apply the patches. Step 7. Apply the patch to the system. Now you can apply the patch to the system. This step includes the actual installation of the updates. Step 8. Verify the patch's effectiveness and stability. The final step of the patching process is to confirm whether the patch has successfully fixed the intended vulnerabilities and monitor system performance to make sure no new issues have emerged. Now, let's discuss rehydration. Rehydration is a cloud-native process where new servers are created with the latest updates and patches, allowing for the workload to be transferred from old servers and for the outdated servers to be decommissioned or destroyed. Unlike conventional patching, rehydration emphasizes continual replacement with up-to-date instances. Let's review each rehydration step in detail. Step 1. Inventory of all cloud-based resources. In the first step of rehydration, establish a system baseline that includes all of your cloud resources as a point of reference. This will assist you in tracking system or configuration changes. Step 2. Identify vulnerabilities and available upgrades. The second step is to identify any vulnerabilities in your resources from the baseline. This includes known bugs, outdated software, or poorly configured settings. Step 3. Run updated and old instances to compare. Once you've created new resources with updates, run them alongside the existing ones. This helps identify and fix issues or compatibility problems before they replace production resources. Step 4. Slowly redirect traffic from old to new instances. Next, slowly redirect traffic from the old resources to the new patched resources to minimize downtime. Doing this gradually ensures that the new resources can handle the workload and that no data is lost in the transition. Step 5. Decommission or destroy old instances. Finally, after all the traffic has been successfully redirected to the new resources, decommission or destroy the old instances. This final step ensures that only updated systems are in the production environment. In this video, we explore the concepts of patching and rehydration system maintenance methods. You gained a better understanding of the mechanics, benefits, and limitations of both methods. Remember, choosing the right approach depends on your system's architecture, environment, and organization's requirements. Be the vehicle mechanic your security system needs. Stay up to date with the latest security updates, and regularly refine your process to ensure your systems remain secure and perform optimally. Hi there. Let's discuss the differences between the patching and rehydration maintenance methods. We'll also cover when to use each approach and the advantages and disadvantages of both. Let's dive in. Patching is a common method of updating software or systems to fix vulnerabilities, errors, or improve performance. It involves applying a small piece of code called a patch to an existing software or system. Rehydration is a more recent approach to updating systems and applications in the cloud. Rehydration involves creating new servers with the latest updates, patches, and then decommissioning or destroying the outdated servers. This method is different from patching, which introduces minor updates to the current system without needing a complete replacement. Now, let's discuss when you, as a cloud security professional, might use patching and when you might use rehydration. Patching is an effective method for making targeted updates, particularly necessary for old systems or monolithic applications. It is especially useful when downtime is unavoidable, ensuring system performance and integrity. Cloud-native rehydration is a process that minimizes downtime and ensures consistency for serverless and containerized applications. It allows easy system updates and is great for maintaining uniform configurations and security settings, making it efficient for large-scale changes. Both methods help keep operations running smoothly, but they have their own unique advantages and disadvantages. Let's start with patching. There are several advantages of patching. Patching includes targeted updates to specific components and doesn't require the entire system to be rebuilt or reconfigured. Also, patching has compatibility with legacy systems. But there are also some disadvantages. Patching can lead to increased complexity and potential for human error. It can also have incomplete updates, leaving systems vulnerable. Cumulative patches can also lead to performance issues. Now let's shift our focus to rehydration. The main advantages of rehydration are speed, consistency, immutable infrastructure, and simplified management, reduced downtime, and reduced human error. Let's discuss these differences in more detail. First is speed. Rehydration is faster, as it replaces components rather than updating existing systems. Second is consistency. This method ensures that all instances of a cloud resource run the same software version, eliminating issues caused by patching. Third is immutable infrastructure. This approach promotes unmodified components after deployment, reducing risk. Fourth is simplified management. Rehydration can be automated for easy cloud resource management and large-scale updates. Fifth is reduced downtime. Rehydration minimizes downtime as it creates new instances with the latest updates. The last is reduced human error. The automation aspect of rehydration decreases the potential for human error. We've listed the advantages of rehydration. Now, let's review some of its disadvantages. The integration of rehydration with legacy systems managed by the organization's or underlying system may present a compatibility issue. On the other hand, the organization's IT professional or team bears the responsibility of mitigating potential data loss risk by ensuring proper data management practices are in place. Next, what's a good example of how to apply rehydration? Use rehydration with systems running on Google's Kubernetes engines, or GKE. This is a good example of taking advantage of immutability's benefits for containerized applications. By creating new containers with updated dependencies, a stable environment is established. This process minimizes downtime, enabling seamless traffic switching and easy rollbacks. Maintaining an immutable infrastructure using disposable components enhances reliability, ensuring Kubernetes application stability with smooth management. Patching and cloud-native rehydration are two distinct approaches to updating systems and applications. Understanding the advantages and disadvantages of each will help you choose the right approach for your specific use case, ensuring optimal system performance and security. We can't predict the future, but we can prepare for it. In this video, we'll discuss current and future trends in vulnerability and threat management. We'll also explore emerging trends and technologies like machine learning, artificial intelligence, and the Internet of Things. We'll also discuss cloud security posture management and cloud attack surface management solutions. Let's dive in. Machine learning, or ML, and artificial intelligence, or AI, have had a significant impact on cloud security. These technologies have revolutionized the cybersecurity landscape by enabling the analysis of massive data sets, pattern recognition, and proactive threat prediction and prevention. ML, a subset of AI, uses algorithms to learn from data, allowing computers to make decisions and predictions without explicit programming. In cloud security, ML can analyze vast amounts of data, detect anomalies, and automate threat detection and response. AI, a broader concept encompassing ML and other technologies, creates systems capable of learning, reasoning, and problem solving. In cloud security, AI enhances ML capabilities, improves threat intelligence, and enables the development of sophisticated security tools. The synergy of ML and AI actively drives significant advancements in cloud security, including real-time threat detection, advanced analytics, and automation of routine tasks. These advancements enable continuous adaptation to emerging threats, ensuring secure and well-protected cloud environments. Next, let's discuss the Internet of Things, or IoT. IoT refers to the interconnection of everyday objects and devices that enables them to collect, exchange, and analyze data through the internet. IoT devices like smart home systems, wearable devices, and industrial sensors rely on cloud-based computing infrastructure for data storage, processing, and analysis. This seamless integration allows for real-time monitoring, automation, and remote control of various processes, ultimately improving user efficiency and convenience. The rapid growth of IoT devices brings exciting possibilities, but it also presents new cybersecurity challenges. To safeguard user privacy and ensure data integrity, it's crucial to secure both the cloud infrastructure and the connected devices in this ever-evolving digital landscape. Lastly, let's discuss Cloud Security Posture Management, or CSPM, and Cloud Attack Surface Management, or CASM solutions. These tools help organizations maintain visibility and control over their cloud environments, ensuring adherence to security best practices and threat identification. CSPM tools continuously monitor and assess cloud environments and identify misconfigurations, vulnerabilities, and compliance violations. Key features of a Cloud Security Posture Management (CSPM) solution include automated assessment, compliance monitoring, policy enforcement, and real-time alerting and reporting. CASM solutions focus on identifying, monitoring, and minimizing an organization's cloud attack surface. Key features of a Cloud Attack Surface Management (CASM) solution includes asset discovery, vulnerability assessment, threat intelligence integration, and risk prioritization. Integrating CSPM and CASM solutions into an organization's cloud security strategy ensures a comprehensive approach to the security posture and proactive threat management. Some of the most significant trends in cloud security include the following: zero trust architecture, container security, edge computing security, security as code, automated incident response. Each of these trends presents unique challenges and opportunities for organizations. For example, AI and ML can help automate threat detection and response, but may also introduce new attack vectors. Similarly, zero trust architecture can enhance access controls and monitoring, but it requires a significant shift in cloud security and infrastructure management. You'll evaluate technologies and approaches to protect your organization's digital assets and mitigate security challenges. Here are 5 key steps to help solve cloud security challenges. Step 1. Assess the effectiveness of various technologies. Assess the performance and capabilities of security technologies and methods, and choose solutions with a proven track record of success in managing similar challenges. Step 2. Determine suitability for unique cloud environments. Each organization needs to determine if they need a unique cloud environment, potentially requiring customized security solutions. Assess whether a specific technology aligns with your organization's unique needs. Step 3. Consider scalability for growth and changing needs. As your organization expands, so will your cloud security requirements. Ensure that the technologies you select can scale to support future growth and adapt to emerging challenges. Step 4. Evaluate compatibility with existing systems and processes. When choosing a security solution, evaluate its compatibility with your organization's current systems and processes. A solution that integrates with your existing infrastructure will be easier to implement and manage. And step 5, examine ease of integration for smooth implementation. Examine how easy or how complex it will be to integrate selected technologies into your organization's cloud environment. A straightforward solution will reduce disruption to your operations and expedite your organization's ability to benefit from cloud security. The future of cloud security will be shaped by emerging trends and technologies. By staying up to date on advancements and implementing the appropriate security measures, organizations can protect their cloud environments and ensure the safety of their data. Now that's what I call future-proof. In this video, we'll cover several important threats and vulnerability topics. The significance of regular reporting and assessments, analyzing potential business risk, evaluating the role of reporting and assessments, and some emerging trends and technologies in cloud security. Let's get started. Regular reporting and assessments are important to maintaining a strong security posture. They help organizations identify vulnerabilities, detect security incidents, and monitor the effectiveness of security controls. By conducting these evaluations, organizations can proactively address potential threats and reduce the likelihood of cyber attacks. Also, regular assessments help organizations stay compliant with industry regulations and demonstrate their commitment to security best practices. For example, imagine the ABC Company, a financial services provider, understands the importance of a strong security posture. To achieve an improved security posture, they've implemented a comprehensive security assessment and reporting strategy. First, the ABC Company conducts regular vulnerability scans of their network infrastructure, web applications, and critical systems to identify potential weaknesses. Second, to ensure timely incident detection and response, the ABC Company utilizes advanced security monitoring tools and has a trained incident response team ready to quickly assess and mitigate threats. Third, periodic internal and external security control audits are conducted to assess the effectiveness of security controls and ensure compliance with industry regulations. Fourth, the ABC Company also provides ongoing employee security training to keep employees aware of the latest threats and best practices. Finally, the security team regularly generates monthly and quarterly security reports, sharing the results with senior management to drive continuous improvement. By implementing the security assessment and reporting strategy, the ABC Company proactively addresses potential threats, maintains compliance, and fosters trust among users and partners. By following this approach, the ABC Company has successfully implemented an effective program. An effective program involves the following steps. First, identify assets like devices, applications, and data. Then, assess vulnerabilities and potential threats to these assets. Next, prioritize remediation efforts based on risk and impact. Then, implement fixes, patches, or other security measures. And finally, monitor progress and continuously adjust strategies as needed. By following these steps, organizations can effectively manage and mitigate risk associated with cyber threats. Failing to conduct regular reporting and assessments can lead to severe business risk. These include financial losses because of data breaches, reputational damage as clients lose trust, and legal penalties for non-compliance with industry regulations. Organizations that don't conduct ongoing security evaluations leave themselves vulnerable to cyber attacks and potential breaches. This can result in long-term consequences and hinder a company's growth and success. Emerging trends and technologies in cloud security offer a lot of advantages. Some benefits of these advancements include stronger data encryption, more efficient threat detection, streamlined security management, automation, increased visibility, and improved detection and response capabilities. But there are also potential disadvantages to consider, like increased complexity and reliance on third-party vendors. These trends usually require continuous learning and adaptation to maintain a secure cloud environment and stay ahead of evolving threats. When organizations adopt new technologies, they must ensure that their security teams have the knowledge and expertise to manage these tools effectively. So it's essential to carefully evaluate these factors when adopting new security solutions. Balancing the advantages and disadvantages of emerging trends and technologies can help organizations make informed decisions and optimize their cloud security strategy. In this video, we explored the importance of regular reporting and assessments, and the potential business risk of not conducting them. We also discussed the role they play in threat and vulnerability management, and the advantages and disadvantages of emerging trends and technologies. By understanding and implementing these concepts, you can strengthen your organization's cloud security posture and protect against cyber threats. Great to see you! Let's recap what you've been learning. So far, you've gained an understanding of threat management, asset management, vulnerability remediation, and posture management in a cloud environment. We started by exploring the importance of threat management in protecting an organization's asset, reputation, and operational efficiency. Then you learned the components of an effective threat management strategy, including risk identification, assessment, prevention, detection, and response. We also explored challenges faced by organizations when implementing threat management programs and gave you some helpful tips for overcoming these challenges. Next, you learned about the aspects of maintaining and optimizing your organization's resources and best practices for asset management. You were also introduced to tools and technologies for asset management and learned some tips for maintaining accurate records of your assets. Then you learned about the aspects of maintaining a secure infrastructure in today's digital landscape. We also explored the importance of secure configuration and posture management in a cloud environment, and discussed best practices for vulnerability remediation and posture management. Finally, we examined emerging trends and technologies in threat management to keep you informed about the latest advancements and innovations. Great job with the progress you made so far. Keep the momentum going. Hi there. I can't wait to join you on your journey through cloud-native concepts. We'll start with an overview of cloud-native design and architecture, including designing for automation. You'll also learn about cloud-native security models. Then we'll explore time to live, or TTL policies. You'll also learn about the benefits of ephemerality and immutability in cloud security. Next, we'll explore automation, specifically infrastructure automation. You'll also learn about infrastructure as code and policy as code. Then you'll learn about Terraform and cloud security automation. Next, you'll learn about containers and their critical elements. You'll also learn the differences between containers and virtual machines. Finally, we'll explore container security. You'll learn about container drift and how to prevent it, and explore orchestration. You'll also learn about serverless functions. As soon as you're ready, meet me in the next video. Let's start your journey into cloud-native design. As a cloud security professional, understanding how cloud resources are deployed is imperative to securing the network. In this video, you'll learn more about what role automation has in deploying cloud-native infrastructure and how understanding cloud-native design contributes to overall network availability. You'll also learn about managed services and examine some powerful defense strategies. Cloud-native design is the method of creating and deploying applications and services that are optimized for cloud environments, ensuring scalability, reliability, and security. This method is key to understanding how to automate resources, and most importantly, how to keep your cloud environment secure. Designing cloud infrastructure with automation is very important, and it comes with some really great benefits. Automation will provision assets with limited manual input. With just a few simple commands, you can choose the number of resources you want to deploy on demand. Imagine you're a cloud security professional working on a cloud site with millions of visitors. You need to deploy enough resources for all of them. Resources cost money, so you want to reduce those resources when you have less traffic. So how do you make sure you're deploying enough resources for the visitors while not overusing resources? Use autoscaling. Autoscaling is a process where automation sets up resources for you and reduces unused resources. Automation provides a consistent platform across all resources, so issues and misconfigurations can be fixed in a centralized location. As a cloud security professional, you'll come across automation often in your career. Sometimes you may need to use services from a third party or managed services. So, what is a managed service? A managed service is a service, application, or ecosystem managed by a third party. Managed services can reduce cost and reduce administrative tasks. Managed services can do things like monitor your network, protect against threats, and maintain compliance so that they can help you with some of your security duties. Now that you know more about automation and managed services, it's time to discuss defense. One of the ways to protect your assets is to apply authentication between each component. You can think about authentication like getting past a guard in a restricted area. Before getting access, proper identification must be shown. Authentication is one part of your protection program. You should also use rate limiting. Rate limiting is a method that prevents an operation's frequency from exceeding a set limit or value. This will help you avoid overusing services or overloading them beyond use. Consider this example of rate limiting. A user is logging into an app on their phone. They enter the wrong password, and the app gives them a warning. Only 2 more attempts. They put another password, but it's also wrong. The app gives them another warning. Only 1 attempt left. The user tries again, but it's the wrong password. Now the app blocks them from accessing their account. This is an example of rate limiting based on the number of attempts. The user was limited to 3 attempts, so the app won't allow them to continue after they exceed those attempts. Here's another example of rate limiting where a user meets a data limit. A user is streaming a video on their mobile device, which uses a lot of high-speed data. The user gets a message from their service provider warning them that they've used up 18 gigabytes of their 20 gigabyte high-speed data allotment. After a short time, the user gets another message. They've used up all of their high-speed data allotment, and their data speed has been downgraded. Along with rate limiting, time to live, or TTL, policies let you remove access from assets that don't need to be accessed anymore. Imagine you have private data that needs to be available externally for a limited time. Once the time to live expires, the data can no longer be accessed. This will help secure your cloud, leaving less data available for possible attacks. When implemented correctly, cloud-native design uses automation to provision assets and employ authentication, rate limiting, and time to live to defend data. Cloud environments contend with a unique set of threats. But the good news is there are effective ways to deal with them. In this video, you'll learn how to keep your assets safe in the cloud. With everything in a cloud environment on the internet, instead of an on-premises server, the cloud needs a specific type of security. One of the pillars of cloud security is a shared responsibility model, an agreement between the customer and the cloud service provider, also called the CSP. The shared responsibility model is the implicit and explicit agreement between the customer and the cloud service provider regarding the shared accountability for security controls. The shared responsibility model states that a cloud provider monitors and responds to security threats related to the cloud and its underlying infrastructure. Meanwhile, end users, including individuals and businesses, are responsible for protecting the data and other assets they store in any cloud environment. As a cloud security professional, it's important to consider how to maintain your end of the shared responsibility agreement. You may need to follow regulatory obligations, develop a risk management plan, apply the security standards of your organization and your customers, and follow vendor security requirements. It's important to understand the different responsibilities that you, your organization, and your CSP have in securing cloud assets. The shared security model can help you determine these responsibilities. In a cloud model, servers and hardware are typically housed in a data center outside of your control. So the provider takes care of the physical hardware. As a cloud security professional, You're responsible for setting the security controls for your organization. For example, imagine a construction company builds a brand new gate and fence. The gate is strong and no one can break it down. Sounds pretty secure, right? Well, maybe not. After the gate is built, they put an old rusty lock on it. Because the construction company used an ineffective security measure to secure the gate, a malicious actor who really wants to get in can. This is an example of misconfiguration. Misconfiguration is like using a security control on your cloud assets that can be easily compromised. That's why it's your responsibility to keep up with the changes and always configure your security controls for the latest threats. Now that you know you're responsible for setting security controls, you also need to determine who gets access to what in the cloud system. This is known as multi-level security. One aspect of multi-level security is access control. Access controls are security controls that manage access, authorization, and accountability of information. Other aspects of multi-level security include using data sensitivity and classification, together with IAM. To do this, you need to determine how sensitive your data is and assign access based on its classification. You've taken quite a journey through the security concepts in this video. Now you know how to secure data in cloud-native architecture. Nothing lasts forever, right? In this video, you'll learn about ephemerality and immutability. These are two important concepts in the cloud, especially in cloud security. You'll review ephemerality and immutability and how they keep the cloud secure. You'll also explore the distributable, immutable, and ephemeral triad, also known as the ditriad. So, what is ephemerality? Ephemerality is the concept that things only exist for a short amount of time. For example, an access token is a piece of code that contains important information, like the user's ID, their permissions, and groups they belong to. Temporary access tokens expire shortly after they're created. They give users enough time to provide the information needed to gain access, then they expire. So, when you apply the concept of ephemerality to infrastructure, it refers to resources that are created as the need arises, then made unavailable when no longer needed. Think of it this way. Ephemerality is like having a paper file of confidential data that you read and then lock in a secure vault so no one else can read the file. Similarly, in cloud security, once your task is complete, ephemeral data is locked and is no longer available. Imagine an organization has highly confidential data that will only be needed for a short time. If the organization saves the data permanently, there's still a chance the data can be breached. However, if the data is ephemeral, once it's used and the expiration time is up, the data is made unavailable. Even the most skilled attackers can access data once it becomes unavailable. Immutability is the concept of being unable to change an object after it is created and assigned a value. An object that's immutable can't be changed after it's created. So, if your infrastructure is immutable, you can't modify it. If something needs to be changed, you replace it with a different version. Immutability has benefits in cloud security. One benefit is that immutable assets can't be changed, so they can introduce new vulnerabilities. For example, a web application has code that can't be modified by users. This prevents the introduction of a malicious code in the app. Because cloud servers are in remote data centers managed by cloud service providers, they need to be configured differently. Cloud security professionals need to rely on cloud-specific solutions. The DIE triad can help you do just that. DIE stands for distributed, immutable, and ephemeral. Distributed refers to the system resources that are distributed and not dependent on a single zone. Remember, a zone is the collective number of data centers in an area. Immutable means your infrastructure can be disposed of and replaced rather than modified. This is helpful because you can more easily identify and reverse changes by reverting to a previous version that's been saved in an immutable state. Ephemeral means your resources are finite and can be disposed of when they are no longer being used. Attackers can be persistent, but they can access information that's not available. In this video, you learned how ephemerality can help keep your data protected. You also learned about immutability and how you can use it to protect your resources from being modified by keeping them in an unchangeable state. This knowledge will strengthen your effectiveness as a cloud security professional. As a cloud security professional, you can use automation to streamline tasks and responsibilities. In this video, we'll discuss some of the benefits of automation, how it applies to infrastructure, and how it can help you in your career. Before we dive into the automation of infrastructure, it's helpful to understand the overall concept of automation. Automation is the use of technology to reduce human and manual effort to perform common and repetitive tasks. Automation also reduces the likelihood of human error. Cloud architecture is pretty complex, and there's a lot you need to do to keep it secure. Automation can support you in this process. One common security task is monitoring your system for threats. You could do this yourself, but using automation to monitor the system, you can free up time to focus on other tasks. Once automation is set up, it completes tasks efficiently without deviation. For example, if you set automation to monitor your systems, it'll complete this task within the parameters you've provided. Now that you know the benefits of using automation, let's explore how it works. You can use code and automation tools to program your system to perform repetitive tasks and monitor the system for security. You can even apply and distribute patches when vulnerabilities occur. Now let's explore infrastructure as code, or IAC, which is the practice of automating and managing infrastructure using reusable scripts. To set up IAC, you'll need to use tools like Terraform to provision infrastructure. Terraform is an automation tool. It lets you build, change, and version cloud resources efficiently and safely. With Terraform, if you specify the cloud platform and the resources needed, Terraform will build the assets for you. IAC can provide you with the automation power to do fantastic things like creating cloud resources, reviewing changes, testing changes, and auditing. Now, you'll explore how to use automation to deploy containers. A container can be built in Terraform and is a software package that holds only the components necessary to execute a particular application. There are several platforms available for deploying these containers. One of the most popular is Kubernetes. Kubernetes has the ability to manipulate containers and automate the deployment of resources throughout their lifecycle. Software goes through a lifecycle, or a series of stages and automated steps in a continuous integration, continuous development, or CI/CD pipeline. Since this is a continuous and iterative process, automating this process with Kubernetes allows the system to do the work for you. Automation can also help with configuration, scanning for vulnerabilities, reporting, enforcing policy, patching software, and resolving threats by taking the proper steps to solve them. Automation is a key factor in efficient cloud security operations and a resource you can rely on. Learning how to use it efficiently will improve your competence as a cloud security professional. Infrastructure is the foundation of many services. Working with cloud infrastructure doesn't always mean working with physical hardware. You can use code to build infrastructure and to define and manage policy. Let's explore infrastructure and policy as code. Then explore how DevSecOps keeps security involved in operations throughout the coding process. Infrastructure as a service, or IaaS, and other cloud infrastructure hosting platforms have made infrastructure as code possible. So how does infrastructure as code work? Users create files with infrastructure specifications, meaning they code the infrastructure they want to use. It's like turning code into components. Infrastructure as code is made available by an application programming interface, also known as API. API is a library function or system access point with a well-defined syntax and code that communicates with other applications and third parties. Infrastructure as code is also compatible with many different coding languages. There are two approaches to infrastructure as code. First is the declarative approach, in which you use an infrastructure as code tool to configure the desired state of the system, including necessary resources and any properties those resources should have. This also makes it simpler to manage taking down the infrastructure. The declarative approach focuses on what you need done. Second is the imperative approach, which defines the specific commands you need to achieve the desired configuration. After configuration, these commands need to be executed in the correct order. The imperative approach focuses on how you need something done. As a cloud security professional, you can use tools to help automate and manage your infrastructure components, like networks, cloud-managed services, firewalls, applications, and other components. But automation can be used for so much more. Let's explore another way you can use automation to help with policy management. Policy as code is the use of code to define, manage, and automate policies, rules, and conditions using a high-level programming language. Policy refers to the rules, conditions, or instructions that govern processes or operations in IT. Cloud professionals build policy into infrastructure to help manage policy. So, how does security fit into the coding process? There's a growing movement known as DevSecOps that's working to integrate security into the coding process. Development operations, or DevOps, consist of practices designed to increase the frequency of delivery and reduce lead time. DevOps' goal is to make sure the operations team is collaborating with the development team from the very beginning of a project. When security is incorporated, it's called Development Security Operations, or DevSecOps. An effective DevSecOps model will engage security throughout the operations and development process. With the DevSecOps model, policy as code and other security measures are incorporated throughout the operations and development process. Overall, this process promotes teamwork and collaboration. The increased teamwork helps identify vulnerabilities early, providing faster delivery. DevSecOps employs automation tools to automate several security processes. Some of these processes include continuous integration and continuous deployment, or CI/CD, the version control system, continuous testing, continuous monitoring, containerization, orchestration, and configuration management and deployment. In this video, you learned about infrastructure as code, policy as code. Additionally, with DevSecOps, you learn how to save time and resources by incorporating security into infrastructure, promoting collaboration, and using automation. You'll encounter these concepts in your career as a cloud security professional. Policy is one of the most important factors of security, but maintaining policy is complex, takes time, and people make mistakes. A mistake in enforcing policy can cause major problems. What if you could save time while reducing the potential for human error? Well, you can, using policy as code. Cloud security engineers enforce policies like the creation of virtual machines, limiting access to resources, and more. While these can be done manually, there are benefits to using policy as code. These benefits include implementing updates at a large scale, providing fast feedback about compliance, preventing mistakes, and avoiding violations and penalties. Let's start with implementing updates at a large scale. Updates to policies across many resources can be automated using policy as code. Imagine security cloud engineers are setting policy for an e-commerce retailer. They need to apply the same policy changes to many resources at one time. They use policy as code to automate updates to all of their resources, reducing the manual process, which could take several hours or even days. Another benefit to using policy as code is fast feedback about compliance. Going back to the example, the retailer security team decides to automate policy enforcement for compliance purposes. Doing so provides the team faster feedback about compliance than if employed using a manual approach. Whether policies are automated or updated manually, humans make mistakes. These mistakes can cause big, expensive problems, especially when done on a large scale. Suppose the retailer's security team automates the creation of virtual machines. They accidentally provision hundreds of large-sized machines, which isn't appropriate for their use case. This costly mistake uses up a lot of resources. Thoughtful implementation of policy as code can prevent mistakes. Another benefit to consider when using policy as code is avoiding violations and penalties in order to comply with government and industry standards. Security teams can code the controls from the standards into the policy to ensure compliance. As a cloud security professional, it's important to remember that policy that works right now may not always work. Policies may need to change. Technology changes too, and sometimes policy causes new problems with new technology. It's a good idea to keep track of all the different versions of your policies. That way, you can go back to an earlier version of policy configuration if there are problems. Now you know about the benefits of policy as code. As a cloud security professional, you can use these benefits to your advantage in order to maintain security standards and compliance. In your cloud security career, implementing thoughtful infrastructure design will be critical. You can use infrastructure as code, or IAC tools, to help automate and manage your infrastructure components, like networks, cloud-managed services, firewalls, applications, and other components. IAC tools give you a way to define resources using configuration files. Within these configuration files, you can define parameters, options, settings, and preferences for these resources. Terraform is a popular IAC tool that enables users to provision cloud resources by communicating with an application programming interface, or API. Terraform creates and manages resources through that code. Some of the benefits of using Terraform include automation, reproducibility, and consistency. Terraform can automate the process of building and managing your infrastructure, which can save you a lot of time and effort. Terraform can also help you create reproducible infrastructure deployments. In other words, you can easily create the same infrastructure environments on different cloud platforms or on-premises. Additionally, Terraform ensures that your infrastructure is consistent across different environments, improving the overall reliability and security of your infrastructure. Terraform is a declarative tool, which means it defines what the desired state of the system is, including which resources you need and what properties those resources should have. There are 3 steps to the core Terraform workflow. The first step is to write the infrastructure as code. This involves defining your desired infrastructure configuration using Terraform. Consider this scenario. As a cloud security professional, a developer team asks for your help in building and deploying a virtual machine. They provide requirements, and you use Terraform to write instructions to build the virtual machine. In this case, you use a Google Compute F1 micro virtual machine. First, you designate your resource, then name your instance, then put in the machine type. So now you have an IAC that is ready to preview. The second step is to run the Terraform plan command. In this step, you preview your configuration before you apply it. The focus of this step is to ensure that the feedback loop aligns to the design of your infrastructure and is error-free. Please be aware that this step may be iterative. When building infrastructure, the development team should work together with the security team to build in policy as code using Terraform. You can use these policies to ensure the Terraform plan is compliant with past practices and security rules. For example, Terraform uses a tool called Sentinel to enforce policy on Terraform configurations. Sentinel uses a high-level purpose-built programming language to build policies. Benefits of policy as code include sandboxing, codification with comments for quick learning about policies, and version control. The Sentinel step happens between the planning and applying steps in the Terraform workflow. The third step is to run the Terraform apply command to provision the infrastructure. The focus of this step is for Terraform to communicate with the cloud provider to initiate the provisioning process. This involves the creation, modification, or deletion of resources based on the configuration in the IAC. It also determines the relationships between resources. It can use provider plugins to modify, create, and destroy resources on infrastructure providers. You can also use a single workflow to manage your infrastructure, but it will acknowledge the uniqueness of your provider. In this video, you learn that you can save yourself a lot of work by building and automating your infrastructure. So remember, tools like Terraform can help. In this video, you'll learn how virtual machines and containers use virtualization differently. As a cloud security professional, you'll need to be familiar with the security implications and best practices of these technologies. Let's get started. A virtual machine is a full operating system running on a host computer. It can run applications and use its own operating system independent of the host computer. It even includes the hardware layer, just like the hardware you'd find in a physical computer. This layer holds components like the CPU, memory, and disk drives. It also uses a hypervisor. A hypervisor is software used to create and run virtual machines. The hypervisor allows one host computer to share its memory, processing, and other resources to support multiple virtual machines. Containers let you run applications online, making them more efficient and faster. A container is a software package that holds only the components necessary to execute a particular application. When an application goes into a container, it's just like putting something into a box. And after adding an application, you can then add libraries and other dependencies to the container, just like adding more things to the box. Imagine you need to build a container for a specific Linux distribution. Instead of searching for every required component of that distribution, you can use the search term of the distribution you want. When you query a container repository, that repository will find the specific distribution and all dependencies and libraries needed for the Linux distribution to run and place them in the container. Both containers and virtual machines let you use isolated environments for running software services. But it's important to remember that there are differences between them. A virtual machine has its own guest operating system, like Linux, running on top of a host operating system. A benefit of using a virtual machine is that the hypervisor is allowed access to utilize the host hardware. Containers hold only the dependencies they need, but they don't have access to their own hardware. A benefit to containers is that they're lightweight, meaning they use a lot less memory than virtual machines. You can use a deployment platform, like Docker, to deploy your container once the image is created from building the application and all dependencies that were retrieved from the container repository. You can also use Docker to create, deploy, and manage your containers. Docker has its own command line interface and builds the containers based on your needs. You can use this interface to interact with Docker in a terminal. Your commands are sent to a program running in the background called the Docker daemon. The Docker daemon manages the containers and the images those containers are created from. When working in the cloud, you'll frequently have to use virtualization. Remember, virtual machines are complete virtual systems with hardware access. Containers hold only what you need to run your application, but they don't have hardware-level access. Knowing these differences will help you decide which technology to use depending on the situation. As a cloud security professional, it's important to know about containers. Chances are, you'll be working with them often. In this video, you'll learn about how containers can benefit you and what to be aware of when you use them. One critical element of containers is that they share the kernels of their host instead of having their own kernels. The kernel is a component of an operating system that manages processes and memory. For example, when you turn on a computer, the first component that starts is the kernel. Since they're not connected directly to kernels, containers can be moved easily between systems. They're platform independent and can be run on any systems that can support them. Remember, containers share the host's kernel, so if the host is vulnerable to an exploit, an infected container can attack the kernel's vulnerability. This means that the host kernel needs to be up to date, and all the libraries in the container need to be patched. You'll also need to be extra careful when configuring your container permissions. If you give them more privilege than they need, like having them run as root users, you can expose them to attack. Now that we've covered containers and container security, let's discuss container orchestration. Container orchestration allows you to deploy, scale, and manage your applications using automation. Kubernetes is a popular container orchestration platform that you can use in a cloud environment. Imagine Kubernetes as the conductor of a grand orchestra. Kubernetes, like a band or orchestra instructor at a school or university, directs the performance. It issues commands and ensures harmony with the ensemble of containers, just as an instructor guides students. Containers are like the musicians in an orchestra or students in a music class. Each container represents a specific instrument, each with unique roles within the performance. Kubernetes groups containers into pods, which are like the classrooms or music halls within the school where the orchestra practices. They are shared spaces that house multiple containers, similar to classrooms, accommodating students with various roles. These pods enable containers to work closely together, sharing resources like power and the local network, much like students sharing facilities within the same room. Nodes are the physical or virtual machines where the performance takes place, akin to the school buildings hosting multiple classrooms. Just as a school building may have many classrooms, a node can have many pods running within it, providing the stage for the orchestra, containers, to perform. A layered file system is another important element of containers. When you make a new container, there's one new container layer that new commands and files can be written to. So, any new commands, such as run or copy, that you give to the running container are written to the container layer. Each layer of a container is built on another layer to form an image. After the layers are put together, you get a final image. Remember, an image includes all the files and dependencies you need for your containerized app. Container runtime is software that is responsible for running and managing containers. The container runtime provides an interface that interacts with the host operating system to create, start, stop, and manage containers. Thinking back to our orchestra example, it's like a conductor cueing a musician to play their instrument at the right time. Now, let's explore how a container runtime works to put containers together. First, you'll need an image that includes all the software and dependencies you need for your container. When you use the run command, the platform puts together the container and deploys it. Because containers make up an important part of cloud computing, you'll likely use them a lot in your role as a cloud security professional. Now that you know more about the elements that set containers apart from other cloud technologies, you can use them to save time and resources. Containers are convenient and make sharing CPU, storage, memory, and network resources easy and portable. An important part of being a cloud security professional is securing containers. In this video, we'll explore ways to keep containers secure so that you're prepared for a role in cloud security. It's important to know the rules when it comes to securing containers. First, don't put anything in your container that you don't need. This can give attackers a larger surface to breach. If you find tools you don't need, remove them. If you leave them there, attackers might use them. Second, use verified or signed images. Third, scan each image you use to make sure there are no vulnerabilities or misconfigurations. Pro tip, be aware that images that may have been verified as secure originally can have new vulnerabilities later. A container deployment platform lets you build containers and deploy them. They may include command line interfaces or CLIs that allow you to input commands to deploy the containers. A container deployment platform is a software solution that allows you to manage containerized applications. It provides capabilities like automation, orchestration, governance, security, customization, and enterprise support for container architectures. Now, let's explore deployment and security with automation using a container orchestration system. There are a few container orchestration systems available to cloud security professionals. For example, Kubernetes is one of the more popular orchestration systems that you might come across in your career. Kubernetes is a platform for automating deployment, scaling, and managing containers. If a container goes down, Kubernetes will start a new one using automation. This makes the process easier because it's done for you automatically. Kubernetes also includes built-in commands to deploy applications, scale up and down for changing needs, monitor applications, and roll out changes. The Kubernetes platform handles a lot of the work that goes into application management, runs health checks against services, and replaces stalled containers when they're unhealthy. This means that containers are not updated or patched, but replaced by new versions. This allows you to roll the container back to a previous version if vulnerabilities are discovered in new code. Even after completely replacing containers, there are still vulnerabilities you need to be aware of. Let's explore some of them together. Kubernetes is a useful deployment system, but there are some vulnerabilities that can happen at different stages. When containers are being built, all the code needs to be trusted and checked. Code from any untrusted registries might contain backdoors which can allow potential attackers in. When building containers, you want to avoid too much clutter. Remember to search for any unnecessary libraries and dependencies. To keep these artifacts from being compromised, delete them as soon as you find them. There are some considerations you need to be aware of during deployment. First, never grant unnecessary privileges. Only grant what is necessary for the task to shrink the attack surface. Next, avoid problems by using namespaces to group services for your application and to isolate applications in your container clusters. Then, use policies to divide the network into segments. Finally, use role-based access controls, or RBAC, to prevent unauthorized access. Vulnerability scanning is another process that can help you find any vulnerabilities in your container images. You can manually scan your container software images, or you can use automation. When you use automation, it will automatically scan each container you deploy to make sure there are no vulnerabilities. Security threats can also happen in containers. As a cloud security professional, you'll need to be able to detect and respond to these threats. Using container runtime security can help you detect abnormal behavior and stop a threat by isolating a container on a different network. It can pause or restart a container if it finds potential problems. It can also enforce runtime policies. Now that you know more about securing containers, you can keep them safe from attackers. When your container has a container layer, it can write to that layer and make changes. This can be convenient, but it can also introduce dangerous container drift. In this video, we'll examine container drift and how to deal with it. Let's investigate. A container layer is a writable space in a container. But this space poses security risk. The more the container writes to this space, the less it has in common with the original image it was created from. When the container writes to the container layer, the container changes. That's container drift. One way to find vulnerabilities is by scanning for them. If containers can't be changed or updated, scanning images would prevent vulnerabilities from being introduced at runtime. When a container has a writable container layer that can be changed, scanning the image won't help much. So, while having a writable layer can give the container some flexibility, it can also introduce vulnerabilities. Vulnerable images don't pose an active threat by themselves, but they can introduce vulnerabilities to a live environment. Imagine the following scenario. A developer team needs to deploy a resource quickly, so they use an image from an outdated container library. The image had been previously scanned and was free from vulnerabilities and malware. So they dispatched the container with the added image. When they dispatched the image, they discovered new vulnerabilities in the image. Now, there's a vulnerability in the live environment. Even a popular, commonly used container library can contain thousands of images with malware. This malware might include cryptocurrency miners, backdoors, website redirectors, and DNS hijackers. These consume resources and increase operational costs. They also give attackers opportunities to gain information and hijack your website. Container images are layered. The container layer is a writable layer that allows changes to be made. As the container writes to this space, it becomes different from the image it originated from. To prevent the problems associated with container drift, you need to prevent the drift itself. Drift prevention stops files from running if they're not part of the original image. You can use drift prevention to keep your container immutable, meaning no new executables can be added. Code needs to be updated to keep up with changes to technology. When these changes happen, you can build a new image and deploy it, but make sure you keep the old image available in case you need to go back, so you can redeploy it. When you're building containers, you should also keep a list of their components. These components include the software built into the container. A software bill of materials, or SBOM, is a machine-readable list of each piece of software and its components involved in the supply chain. An SBOM will provide information on applications and components running in your container and software information for all third-party libraries you're using. An SBOM can also track software and its components. It can track where they came from and what security vulnerabilities they contain. And it enables protectors to stop vulnerabilities from being exploited. SBOMs usually follow the Software Package Data Exchange, or SPDX standard. SBOM documents may contain package information, file information, snippet information, any other licensing information detected, information on the relationships between SPDX elements, annotation information, and review information. Container drift can compromise your container security, but you can prevent it. You can use the knowledge you learned in this video to keep containers secure throughout your cloud security career. There are many tasks cloud security professionals need to perform on a regular basis. That's a big responsibility. So, how do they manage them all? Well, orchestration can help. Orchestration is useful because it manages a full set of automated tasks for you. For example, it manages deployment, scaling, load balancing, networking, provisioning, lifecycle management, and container availability. And orchestration itself can also be automated. To use orchestration, use declarative programming. With declarative programming, you can write a configuration file focused on the desired outcome of an automation instead of detailing the steps needed to complete a task. Then, you can choose a platform or tool to find the appropriate host for your containers. Orchestration tools choose a host based on the requirements or predetermined constraints in the configuration files. These tools also schedule container deployments. Container orchestration tools help automate a variety of operational tasks. For example, these tools scale containers and load balance and allocate resources between containers. Additionally, orchestration tools monitor the health and performance of the application. There are several orchestration platforms available. For example, the Kubernetes engine is a popular platform that enables you to configure infrastructure to run your containerized apps. This infrastructure includes networking, hardware, scaling, and security. It also manages underlying components like nodes, pods, and container clusters for you. Nodes are machines that can be either physical or virtual and include one or more containerized applications, which are known as pods. A pod uses shared resources and a specification on how to run containers. Pods are grouped by container clusters. Container clusters are dynamic systems that manage and place containers grouped in pods. Container clusters run on nodes, along with all the interconnections and communication channels. Once an image is deployed to the Kubernetes engine, it goes into the cluster through a load balancer and into several nodes containing pods. Clusters can be set up for a single zone or for a region. If the clusters are set up for a region, they're replicated across multiple zones. Setting up a regional cluster can help minimize disruptions, but it can also help use a lot of resources. So, it's important to use horizontal autoscaling. You can use horizontal autoscaling to increase or decrease the number of pods based on utilization. And you can use virtual autoscaling to scale your clusters for both pods and nodes. Orchestration can automate policies and keep errors from happening. Imagine a container is about to be deployed, but it has vulnerabilities that violate a policy. If a violation of the policy is found during orchestration, deployment will be stopped. This can help you avoid human error and ensure the container is safely deployed. Role-based access control, or RBAC, is a type of identity and access management, or IAM, that is central to Kubernetes operations. It involves a template or permission set that determines who can execute what and where it can be executed. With RBAC, you can create and grant roles for any object or object type within a cluster. A role defines access to only resources within a single namespace, while a cluster role defines access to the entire cluster's resources. RBAC can help keep your cluster safe, but there are some things to avoid. Because the cluster admin role grants unlimited access, never grant cluster admin access to any users or teams that don't need high-level access. Also, avoid aggregating or combining privileges. Combining them may change the access they grant. It's also important to avoid creating roles that are not used. Orchestration does a lot for you. To be safe, always be sure to carefully assign roles and only give access to those who need it. Now that you know how orchestration can help you with cloud security, you can use it to manage your automated tasks. Orchestration can also help you prevent security risks. Congratulations! You've arrived at the end of this section on cloud security risk. You've learned a lot about cloud-native concepts and security along the way. Well done! On your journey, you learned about cloud-native design considerations. We started you off with an overview of cloud-native design and architecture. Then introduced you to cloud-native security models. Next, you explored time to live, or TTL policies. Then you learned about the concepts and benefits of ephemerality and immutability in cloud security. Next, we discussed infrastructure automation, infrastructure as code, and policy as code. Then you explore Terraform and cloud security automation. After that, we introduced you to containers and their critical elements, and discussed the difference between containers and virtual machines. Finally, we explored container security. You learned a lot about container drift and how to prevent it, and explored orchestration. Congratulations on finishing this section of the course. You're doing an amazing job. Meet you again soon. Hey there. Are you ready to learn about the fascinating world of data protection and privacy? Let's get started. We'll start by exploring the 3 states of data and how to use encryption for each state. Next, you'll learn about data classification, data governance, and sovereignty. Then we'll discuss data discovery, retention policy, and business continuity planning. First, we'll provide you with an introduction to the 3 states of data. You'll also learn about data encryption at rest, in transit, and in use. Then you'll learn about data classification and tagging. Next, you'll learn about data governance, data sovereignty, data discovery, and data retention. Then we'll discuss business continuity planning. You'll learn about the process of creating a business continuity plan that's best for your organization. Plus, we'll go through a possible scenario for using a business continuity plan. There are lots of cool things for you to explore. As soon as you're ready, let's meet in the next video. Companies collect large amounts of highly confidential data, like customer data, financial data, and business data. As a cloud security professional, you'll work to ensure data is secure. In this video, you'll learn about the 3 states of data. Let's get started. The first state of data is data at rest. This is data that is not being accessed or actively moving from device to device or network to network. Data at rest is stored on servers, databases, mobile devices, physical drives, or in the cloud. At-rest data includes intellectual property, employee and customer personal information, financial documents, contracts, and any other types of data, like healthcare data. The next state of data is data in transit. This is data that is moving between 2 places, like between a cloud provider and your site, or between 2 services. For example, using a mobile device to access a banking app moves data between 2 places, your mobile device and the host of the banking app. The third state of data is data in use. Data in use is data that's been accessed by 1 or more users. Data in use includes, but is not limited to, data that is being processed, erased, read, or accessed. For example, after you've accessed the banking app, accessing your transaction history on a banking website or app is an example of data in use. If you then decide to transfer money between accounts, the data then returns to an in-transit state while it moves between your device and the banking app's host. The data returns to being in use as you review additional account details. Now that you know about the 3 states of data protection, you'll be better prepared for your career as a cloud security professional. Data encryption protects your data at rest, in use, and in transit. But how does at-rest encryption work? In this video, we'll explore encryption techniques for the 3 states of data. Remember, data at rest is any data that is not currently being accessed. Data at rest needs to be encrypted to be secure. Data encryption is the process of converting data from a readable format to an encoded format. For example, a readable format might be a plain text email, and an encoded format might be scrambled text and symbols that don't make any logical sense to a reader. The Advanced Encryption Standard, or AES, is the world standard encryption tool that helps protect data at rest. AES is a tool that converts data to unintelligible ciphertext and back into its original form with the proper key. This means that AES encrypts information while at rest, and this information can only be unencrypted with a key. Encryption helps keep data protected with data encryption keys, or DEKs. Even if an attacker gets access to the data storage, they won't be able to read any of it without the appropriate keys. Another way to protect data at rest is to break it into chunks for storage. Each of these chunks get their own DEKs. Each time a chunk is updated, it gets a new encryption key. Because there are a variety of keys that can change regularly, the risk of encryption key compromise is reduced or eliminated. It's not just data at rest that needs to be protected. Data in transit also needs to be protected by encryption. You can use transport layer security, or TLS, to encrypt data in transit to keep it secure. TLS is a security protocol that encrypts data transmitted between two communicating applications. TLS is often used to encrypt data sent over the internet to ensure that unauthorized users are unable to read what has been transmitted. This is critical when transmitting private and sensitive information, such as passwords, credit card numbers, and personal correspondence. For example, say you're using a mobile banking app. If you transfer money to another account or pay a bill with the banking app, TLS will help to ensure that your sensitive information, like your account number, is transmitted securely over the internet when you make the transfer. Encrypted data is useless to any attackers because they're not able to read it. Lastly, you will need to encrypt data in use. Confidential computing is one way to do this. Confidential computing is the protection of data in use with hardware-based trusted execution environment, or TEE. To encrypt data, a TEE offers a secure and isolated environment that prevents unauthorized access or modification of applications and data while they're in use. A TEE is secured through embedded encryption keys, and only authorized code can utilize these keys. Now that you know how different types of data encryption protect data at rest, in transit, and in use, you'll be able to help secure different states of data as a cloud security professional. The last thing anybody wants to learn is that their personal information has been leaked or stolen. In your cloud security career, you or your team will be responsible for keeping sensitive personal information away from attackers. In this video, you'll learn about data classification, tags, and how categorizing data helps keep assets secure. Data classification is the process of analyzing data to determine its sensitivity and value. Data classification enables organizations to categorize their data, which helps security analysts efficiently find and secure assets. Organizations use sensitivity levels, data type, and value as metrics to organize the data. Let's explore the different sensitivity levels of data: low, medium, and high. Lower sensitivity levels represents less of a risk for organizations. This makes low sensitivity data less valuable. For example, imagine you create an open access public blog that has lots of readers. Publishing a blog for the public to read is an example of sharing public information, and public information is the least sensitive type of data you can have. Medium sensitivity level data is more sensitive and should be inaccessible to the public. Here's an example. At a marketing company, an associate sends an internal memo with little information about the company, along with meeting notes on an advertising plan outline. There's no personal information, like social security numbers or medical documentation, and there are no company secrets. But the information is still sensitive and should not be shared with the public. High sensitivity data includes information like personal financial data, legal documentation, and company secrets. High sensitivity data is very valuable to organizations. For example, a database with all employees' personal and employment data is highly sensitive. If an attacker gets that information, the employees' identities will be in danger. Stolen or leaked sensitive data can lead to major consequences, like fines for violating privacy laws, or damage to the organization's reputation. Cloud security professionals use tags as a consistent way to document and classify data. Tags are custom metadata fields you can attach to a data entry to provide context to people authorized to access the data. Metadata can include information like who's responsible for the data entry and whether it contains highly sensitive data, like personally identifiable information or PII. Keep in mind, tags or labels are essential for data protection. They help your security controls find the data that needs to be protected. So, to protect your data, you need both the tags and the security controls. Let's review an example of a customized PII tag. The information in this tag is presented as a label, followed by two metadata pairs. The first line of code is the next label for the tag, and it has the letters PII. The next line of code is the first metadata pair. It verifies that the value is true. This means there is personally identifiable information in this asset. The last line of code has a second metadata pair, and it identifies the type of PII as a social security number, or SSN. Both of these pairs together create a field in the tag. This PII tag example has a Boolean field, abbreviated bool. That means there can only be two possible results. In this case, true or false. The asset with this tag has highly sensitive information, and the tag indicates what type of data it is. The tag classifies this information as high sensitivity, making it easier for security controls to locate. When you make your tags, you can use tag templates or reusable structures to rapidly create new tags. You can make a template by putting together metadata values in fields. You can then grant or deny access to a template with Identity Access Management roles, or IAM roles. Now that you know about data classification and tagging assets to classify and protect them, you can use them to protect data so you can keep the data from being leaked or stolen. Data governance enables cloud security teams to ensure data is private, accurate, secure, available, and usable. In this video, we'll explore how you can use data governance to maintain data quality and keep data secure. Data governance is a set of processes that ensures that data assets are managed throughout an organization. These processes are everything an organization does to ensure data is private, accurate, secure, available, and usable. The processes people follow, the actions they must take, and the technology supporting them throughout the data lifecycle are all included in data governance. Data stewards are an important part of data governance. Data stewards are subject matter experts who are responsible for collecting and managing data and preserving the quality of the data. Data governance can be used to help maintain data quality. Usually, data quality is judged on 6 dimensions: accuracy, completeness, consistency, timeliness, validity, and uniqueness. Let's examine each of these dimensions. Data is accurate when it can be confirmed with a verifiable source. For example, an accurate email address for a team member ensures they can be reached. Data is complete when there is enough data to deliver meaningful decisions and inferences. For instance, when completing an online form, some fields may be required while others are not. The data is complete when all the required fields have information. Data is consistent when data stored and used at multiple instances match the values across various records. Suppose a business has more than one customer database. If a specific customer's name is spelled differently in each database, the data is not consistent. If the same name is spelled the same way in each database, the data is consistent. Data timeliness means that the data is available when the user needs it. For example, if an auditor is conducting a review, the audit report data must be ready when the auditor needs to access it. Data is valid when value attributes are aligned with specific requirements. For instance, if a person is purchasing a product online, they need to input their credit card number. The number is valid if the correct number of characters of a verified credit card number are in the credit card number field in the payment form. And data is unique when there are minimal overlaps or duplicates. Consider a salon customer who uses an online form to make 2 appointments for the same service at the same time, on the same day. If that customer record is duplicated in the system, then the record is not unique. Data quality means your data is complete, accurate, available when you need it, and fits with the organization's requirements. Having formal governance processes in place to maintain the quality of data will help to ensure that your organization's data maintains a high quality. For example, say you're working on a data governance framework. You'll want to make sure to create processes that address the accuracy of data and ensure that your data is available when you need it. Establishing clear policies and procedures for data governance helps to protect and secure data. The policies and procedures in your governance plan or framework should cover data access, use, storage, and disposal, and should align with industry standards and regulatory requirements. For example, policies and procedures should prevent threat actors and other unauthorized users from accessing certain confidential data. There must also be policies and procedures in place so that authorized users are able to gain access to the data. When you collect, keep, and use data in secure and effective ways, you're practicing data governance. Data governance can help you and your organization maintain high-quality, secure data that meets regulatory and policy requirements. Now that you know more about how you can use data governance, you can apply those skills to maintain high-quality standards and keep your data secure. Cloud data can be stored in different physical locations around the world. As a cloud security professional, you'll need to know where the data is stored to ensure that it complies with required regulations and policies. In this video, you'll learn about data sovereignty, data residency, and data localization. You'll also explore some ways that data governance can help to ensure data sovereignty. Physical servers that store cloud data are kept in buildings called data centers. Data centers are located in many different countries. These countries have their own laws and regulations for data storage. This is where data sovereignty applies. Data sovereignty means data stored in a physical location has to follow the regulations of that geographic location. A country enforces its laws on the data systems, controllers, and processors by exercising data sovereignty. Data sovereignty also extends across borders and even has international implications. A country may refuse another country to exert control over its sovereign data. To comply with data sovereignty, data professionals need to know what data they have and where their data resides. Data residency refers to the physical or geographic location of an organization's data or information. Once data is moved, stored, or processed within a particular geographic location, it is subject to laws, customs, and expectations of that specific location. Sometimes there's a need to keep sensitive data within the borders of a particular country to enhance data security. This is called data localization. Data localization is the requirement that all data generated within a country's border remains within those borders. Consider how this impacts the way an organization conducts business. An organization must research and comply with the data sovereignty laws of all geographic locations where they intend to operate. This ensures that the organization is in compliance. This is so important because data localization helps countries safeguard the data of their citizens and organizations in their territory. Data governance helps organizations comply with and reinforces data sovereignty. These work in tandem. Remember, data governance is a set of processes that ensures that data assets are managed throughout an organization. Having data governance processes and procedures that address sovereignty risk, such as data that's subject to the regulations of multiple governments, will help organizations remain compliant with relevant laws and regulations. An organization can take several actions to facilitate data governance. For example, an organization might conduct a data audit as part of their data governance. In the audit, they can identify where the data is stored, processed, and transmitted, and also the relevant data protection laws and regulations for those locations. This will help identify any potential data sovereignty risk and ensure that the organization is in compliance. The organization could also research and select cloud providers with data residency options that align with the organization's data sovereignty requirements. They might also map out the regulations from each country that stores or might store data to find similarities and differences between the sovereignty requirements for each country. The organization could even create an organizational policy to use as a preventative guardrail. As a reminder, guardrails are the policies, procedures, and processes to manage and monitor an organization's regulatory, legal, risk, environmental, and operational requirements. It's often helpful for organizations to check with their cloud provider to figure out if there's a policy the organization can use. For example, the cloud service can help the organization identify a resource's location property and also where it's maintained and deployed. When an organization uses location constraints in their policy, they can limit where the resources are deployed and maintained to make sure that they meet sovereignty requirements. As a cloud security professional, you'll need to work with data sovereignty, data localization, and data residency to keep your organization compliant with data regulations. Having strong data governance will help you to meet your sovereignty requirements. In this video, we'll explore data discovery. We'll consider how data discovery relates to data governance and data sovereignty, and how data discovery works to keep sensitive data from being moved out of protective spaces. Let's get started. Data discovery is the process of searching, identifying, and analyzing large amounts of data within an organization to uncover hidden patterns, relationships, and insights. Data discovery can identify risk and inform better decision-making. For organizations, data discovery supports both data governance and data sovereignty. During data discovery, organizations can flag data that is subject to governmental sovereignty laws and regulations. Then, they can use data governance to ensure they're in compliance with those regulations. Data transparency enables organizations to remain in compliance with data sovereignty laws and regulations. Organizations use data discovery to check for the dimensions of data quality, including the accuracy, completeness, consistency, timeliness, validity, and uniqueness of data. Each of these dimensions factor into how organizations use data for different purposes. But completeness, timeliness, and accuracy especially affect the ways organizations ensure transparency. Transparency is one benefit of data discovery. In data discovery, an organization's data may come from many different data sources and be stored by cloud service providers. The organization needs to keep track of this data and know how the data is collected, where it is collected from, and where it's stored. Data transparency ensures that data is available and searchable. For security, discovery of sensitive data is particularly important. Sensitive data discovery is finding and identifying all confidential and regulated information kept by an organization. This includes any data that's regulated by law, like confidential payment data and PHI. It also includes finding data related to intellectual property. For sensitive data, it's important to know what kind of data it is and where it's located to ensure that it's properly protected. As a cloud security professional, there are tools that you can use to find and protect sensitive data. One tool that we'll explore is a data loss prevention engine. At various stages of the data lifecycle, you can use a data loss prevention engine, also known as a DLP engine, to filter and search for sensitive data. You can use DLP to inspect, mask, or remove sensitive data once it's discovered. Doing so may lower the risk inherent to certain data types. The DLP can also be utilized to complement encryption for data at rest, manage access controls, and other security measures. You can also examine data closely with DLP. After, you might decide to apply security controls based on the data sensitivity or move the data to a less restricted area. If you move data during a cloud migration, for example, you can use data discovery to validate whether the data is being moved into places that are properly secured. Data discovery also checks to make sure that there are no mistakes in data classification and placement. This prevents regulated data from being moved into an environment without proper controls in place. Now that you know about data discovery and how data discovery supports data governance and data sovereignty, you have the info you need to identify and protect sensitive data wherever it is. Everything needs somewhere to go, whether it's forks and spoons in a kitchen drawer or data in the cloud. And to find a spoon, you know which drawer it's stored in. Similarly, security professionals need access to well-organized data, and they need to know where to find it. That's where storage becomes useful. In this video, you'll learn how data is stored and how a data retention policy can help you manage your data and follow regulations. Let's get started. Data retention is the process of storing data, including how long it needs to be stored. In cloud storage, the length of time that data is stored is determined by an organization's needs. The time period for stored data is called a retention period. A data retention period is the length of time an organization keeps information. It's also a key element of an organization's data retention policy. A data retention policy helps determine what data needs to be stored and where the data should be stored. Because it includes an expiration period, a retention policy can also help decide how long the data can be stored. These considerations need to follow compliance regulations, which are often outlined in an organization's compliance policy. And having a data retention policy will help ensure that data is compliant and safe. As a security professional, you may be responsible for working on data retention policies. As part of this process, you'll need to conduct research before you start creating the policy. While conducting research, you'll need to make compliance considerations like, industry or regional compliance standards for data, and regulations for the location of the data. Take notes while you research. Then, consult the legal staff members on your team for insights on your research findings. While you're preparing for building your data retention policy, consider the following questions. What are your organization's needs for specific data? What are your organization's policies for data retention periods? Do organizational needs change over time? Do different data types need different policies? A data retention policy should be flexible and be based on an organization's needs. Keep your organization's compliance policy in mind as you build your data retention policy. Try to ensure that both policies work together, that they're not contradictory, and that they're clear to members of the organization. For example, if your organization has a compliance policy that states user data is only retained for a short time, make sure your retention policy reflects that. As you create policy, here's a pro tip. Policy creation is also affected by what type of resources you use to store data and the applications you allow to access that data. You're responsible for keeping your applications and hardware secure. Vendors may not provide regular security updates, so it's important to understand the limitations and capabilities of applications and hardware when creating your policies. Organizations also need to consider risk when creating data retention policies. When data is available, there's a potential risk for a data breach. This means attackers can steal your data while it's available, including sensitive data. To defend against this risk, it's useful to delete or replace data over time. Let's review how risk consideration works. Retention policy is defined by time. First, you add a retention policy to a bucket. In cloud storage, a bucket is a virtual container that holds objects. Then, you can define the age of the objects that can be deleted or replaced by specifying the retention period. It's important to know that you can only delete or replace those objects once they reach the age you define. If you try to delete the objects before that time, you'll get an error. You can set your retention policy in units of days. You can also permanently set a retention policy by locking it. This means that the policy is locked in and stays for the life of the bucket. To delete the bucket, you'll need to wait until every object has completed its retention period, since the object's age must be greater than the retention period duration. Understanding how a data retention policy keeps data compliant and safe allows you to create and implement a plan for your organization. Imagine a software company is using cloud resources to host your applications when a large storm strikes a data center, taking the company's resources offline. It's important for the business and its customers to get the cloud environment back up and running quickly. That's where a business continuity plan comes in. A business continuity plan, also called a BCP, is a document that outlines the procedures to sustain business operations during and after a significant disruption. BCPs can minimize damage from disruptions like natural disasters or cyber attacks. A disaster recovery plan, or DRP, is an important part of each business's continuity plan. A DRP is a plan that allows an organization's security team to outline the steps needed to minimize the impact of a security incident. While BCPs focus on keeping a business going during a disruption, DRPs focus on recovering assets and data after the disruption. Let's explore some impacts that business continuity planning can help prevent or mitigate. Business continuity planning can decrease the financial impact of a disruption since it helps an organization get back to normal quickly. It can also mitigate brand impact and reputation loss. The sooner an organization recovers from a disruption, the less it affects their customers. And that keeps customers happy with the organization and likely to keep using its services. Let's explore the steps to develop a business continuity plan. Departments throughout an organization usually collaborate to create a BCP, with each department planning for their own operations. Leadership helps to keep the plan in line with the company's goals. The first step in building a business continuity plan is to determine the most critical apps and data for business function. You can organize these resources into tiers based on importance. For example, let's say you're helping create the BCP for your employer, a financial institution. If your online banking app goes down, your customers won't be able to access their accounts from their phones. This means the banking app is a high priority. By contrast, Let's say the financial institution stores archived employee newsletters in a cloud storage bucket. If the storage bucket goes offline, your company can still continue its operations and your customers won't be affected. It's a lower priority. After ranking the most important apps and data, the second step is to identify acceptable amounts of downtime for each one. You can do this by assigning recovery time objectives. A recovery time objective, or RTO, is the target time allowed for the recovery of a service in the event of a disaster. The services most critical to your organization's operations should have the shortest RTOs. You should also assign recovery point objectives to your applications. A recovery point objective, or RPO, is the maximum acceptable length of time during which data might be lost from an application due to a major incident. The longer an application is offline, the more data will be lost, so you should assign the shortest RPOs to the most critical data. The third step in developing a business continuity plan is to conduct a risk assessment to identify what risk can affect your resources. Next up, the fourth step is to document your disaster recovery plan. This plan should include solutions to recover your operations as soon as possible, including steps to restore backup data. It should clearly define each team member's roles in the event of a disruption. You should include contact information for your cloud service provider, backup providers, and key personnel who will be involved in restoring operations. After developing a BCP, the fifth step is to communicate the plan with others on the security team and throughout the organization, so everyone is familiar with how their role fits within the overall strategy. Finally, the sixth step is to regularly test and update both your BCP and your DRP. Testing should include simulation drills of different scenarios with the security team and throughout the organization. You'll want your plan to cover any type of event, from small malfunctions to complete shutdowns. Business continuity planning is an ongoing job. It's important to update business continuity plans regularly to make sure that they keep up with any changes to the business or its IT infrastructure. I hope you had fun learning to create an effective business continuity plan. You're ready to help your organization keep operations going no matter what. Imagine you're attempting to access your organization's cloud data storage. Suddenly, a message appears telling you that sensitive customer data has been encrypted and you need to pay a large sum of money to unlock it. You realize the data storage has been infected with ransomware. This ransomware attack could cause a major disruption for your organization if you don't handle it properly. Fortunately, you have a business continuity plan. Let's explore how business continuity planning can help the company solve this problem. After you alert colleagues to the ransomware attack, your team can begin carrying out the business continuity plan. Your plan identifies the most important data and services to your organization's operations. Your business plan also lists acceptable amounts of downtime for each of those resources. Because the ransomware attack affected sensitive customer data, your plan only allows for 1 hour of downtime. Your risk assessment identified that a ransomware attack could affect your data storage, so you have a disaster recovery plan in place. The disaster recovery plan portion of your BCP contains information about each team member's role. According to your plan, your colleague is responsible for communicating with other departments to make sure everyone knows what's going on. Another colleague is responsible for shutting down cloud resources affected by the ransomware. Meanwhile, you're responsible for getting the data back online. Your disaster recovery plan also includes recovery solutions for restoring apps and data. Because the data affected by the ransomware has a short acceptable downtime, your team has worked with your cloud service provider to back it up to another site. Your plan contains cloud service provider contact information, or CSP contact information. You're able to reach out to your CSP and access the backed up data which hasn't been affected by the ransomware. Since your team has been regularly updating your BCP and training for all types of disruptions, including a ransomware attack, everything goes smoothly and the data is only unavailable for a few minutes. Disruptions happen, and they can require significant effort from you and your team. But with a proper business continuity plan in place, you and your team can minimize disruptions efficiently, effectively, and with confidence. Congratulations! You've completed your journey through data protection and privacy. Well done. You learned about encryption, data classification, and data governance. And you explored the steps to building a business continuity plan. You started with the basics of data protection and privacy. Then you learned about data encryption at rest, in transit, and in use. Next, you learned the importance of data classification and tagging to data security. You also explored data discovery and how it supports both data governance and data sovereignty. You learned how to keep data storage compliant and secure by creating a retention policy. Then, you learned about business continuity planning, including disaster recovery planning. And finally, you explored how using a business continuity plan can help your organization deal with an emergency. Congratulations on getting here. You're doing a phenomenal job. Keep going. You got this.
Confidence is very important, and something that one of my first managers ever told me is it's not what you know, it's how you say it, and it's something that I continue to tell myself day after day. My name is Lauren, and I'm a cloud sourcing lead. What that means is my team is responsible for reaching out to candidates for our open roles within the cloud organization. The 3 top things that a candidate should do when updating or creating their resume is first, tailor your resume to the job description. You want to make sure you're pulling out keywords and key indicators that match your experience to ensure that the recruiters can see pretty quickly the experience that you have that's relevant to the job description. Secondly, do not exaggerate or do not lie on your resume. That probably goes without saying, but anything on your resume is technically fair game. It can be asked in an interview, so you want to make sure that you're being as accurate as possible. My third tip would be keep it concise, keep it short. We definitely want to make sure that we can get all of your experience, but you can cut things out. That's okay too if it's not relevant to the job. What makes a resume stand out for a recruiter or a hiring manager is an organized resume. You want to make sure you have clear headers, it's in chronological order, and you have short and concise bullet points. Some ways that candidates can demonstrate their technical skills in interviews is to talk out their thought process and the answer to the questions they are asked. The process of how you get there is just as important as getting to the correct answer. Some common interview question types are problem-solving based questions, experience-based questions, and also leadership-based questions. The best way to answer a hypothetical question is really just talking through your thought process. You're going to get a scenario, something that you may or may not have experienced before, and your interviewer just wants to see your thought process, how you're connecting the dots as you're talking through your answer. The best way to answer a behavioral-based interview question is really leading on your own personal experience. This could be a personal experience from a previous job, from school, from a class, and talking through that experience and that thought process. It's very important to ask follow-up questions throughout the interview. First and foremost, you want to make sure you're understanding the question that's being asked. You have a very limited amount of time with your interviewer, and you want to make sure that you're spending it as productively as possible. I think some candidates worry that it's bad to ask questions. I love when candidates ask me questions. I want to make sure that my candidate knows what I'm asking so we can get to the best solution. Workplace skills are absolutely important during the interview process. These are skills that can't be taught. Are you kind? Are you empathetic? How are you showing up? Do you have that eagerness to learn or to thrive in ambiguity? We really want to see candidates that have that self-drive and that self-determination. A candidate can best position those workplace skills just on how they're simply answering their questions, especially in those behavioral questions. Like lean on those examples that show your grit, that show maybe a struggle that you had and how you overcame it. I'm not looking specifically for something that happened perfectly the right way. I'm looking for someone that maybe had to overcome some obstacles to get to the right solution. Candidates hold a lot of power in the interview process. We want you to be successful. We want reasons to say yes. So please show up, be your authentic self, be confident, and show us all the amazing skills that you could bring to the company.
Hi, I'm Patrick.
Hi, I'm Brenda.
Let's step into an interview in progress. In this interview, questions will focus on cloud cybersecurity topics relating to identifying and detecting threats.
We hope this will give you some tips for your next interview.
Hi, Brenda. What interests you about roles in cloud cybersecurity?
I would say what interests me the most about jobs in cloud cybersecurity is the fact that you're continuously learning. As a whole, with security and with cloud specifically, there's always new features, new services that you have to learn. And as security practitioners, you always want to essentially learn and know how to protect them. And so as a whole, I'm attracted to the fact that you're continuously learning.
Let's say you're working on a project to help a new company implement access control processes. What are some cloud access control processes you might recommend?
So some of the cloud access processes that I would recommend in this instance are, for example, perimeter protection and also trust boundaries. And so with the first, with perimeter protection, this is essentially your security measures that you want to take into place or you want to put in place to essentially prevent unauthorized access. And so some of these might be like firewalls, virtual private network, intrusion detection systems, or intrusion prevention systems. With the second, with trust boundaries, that's essentially trying to separate your trusted and untrusted environments. And so this can be done with something like firewalls or routers to essentially set that logical and also physical separation.
What are some examples of trust boundaries that you could delineate and kind of isolate based on?
So essentially, a very simple example would be trying to separate the public internet from your corporate intranet. And that can be one instance where, again, you would have more of a physical and also logical separation.
What impact did you have on the project, and what impact did that project have on the company?
The impact that I had on the project was essentially to act as one of the security gates to make sure that there were proper security requirements put in place and practices before we actually went through with full migration. As far as impact for the overall organization and company, this was a big move for us, and the fact that we had to have so many teams coordinate together was essentially all for the goal of getting to a more modern kind of cloud architecture.
Imagine you're asked to explain the key components of a threat and vulnerability management strategy to a business leader with not a lot of technical experience. What components would you choose and what would you say about each one?
So there are 4 components that I would highlight to explain a effective threat vulnerability management strategy. The first being prevention, the second being detection, the third being response, and the fourth being recovery. So with the first component, this is the part where you essentially want to prevent any kind of unauthorized access to begin with. You want to prevent that cyber attack. And so here you want to make use of endpoint protection, software, virtual private networks, etc. Then we move on to the second component, where this is all about detection. And this is going to be monitoring efforts, where you essentially want to set up things like event management systems, and you want to make sure you have proper log analysis. And so here is where we want to detect the malicious activity and also alert on it. Once we alert on that, then we move on to the third component, which is going to be response. And so with response, this is where we want to not only identify the threat, but also contain it. And so we'll make use of incident response teams and plans, as well as other emergency response teams. Moving on to the fourth and final component, this is going to be recovery. And so here we'll want to make use of any kind of disaster recovery plans or teams and get back to a state before the attack. And that will be not only for your systems, but also potentially for data.
Could you give me an example of the impact that each of those components has?
With the first one, where we essentially want to prevent, the impact as a whole here is to reduce your attack surface. And so as a whole, you want to have security measures so that attackers just have less avenues to actually get into your environments. For the second component, for the overall detection, again, here the goal is to monitor. And so the benefit and the overall impact is that you actually have the proper logging to actually detect whatever malicious activity comes your way to your environment. For the third component, that's going to be, again, the response part. And so you want to make sure you have the proper teams and plans set in place so that the overall company will benefit by having actions readily available. For the fourth and final component of recovery, again, this goes back to what plans do you have already in place, because a company can't really have too much downtime. You need to make sure you have essentially steps in order to get back to the pre-attack state. And again, get your shop up and running.
Thanks, Brenda. Do you have any questions for me?
Yes, I do. So what would you say are some of the toughest challenges that you see in environments relating to access control?
When we think about access control, there's a really big difference between what is mandatory and what is discretionary. And so being able to assert that a control is actually mandatory and that there aren't ways to bypass it or backdoors or ways that, teams, customers, or malicious actors can route around those controls is probably the biggest challenge at scale.
That makes sense. I can see how something like Terraform would help enforce this. Thank you so much.
Thanks for watching. In this scenario, Brenda demonstrated how to explain impact when answering questions. In interviews, be sure to share the beneficial effects of any process, concept, or tool that you discuss. Whether it's deploying a concept to identify a particular threat or deploying a tool to protect against a particular threat. Explaining the potential impact will help you stand out to an interviewer. Keep watching for more interview tips.
Great work on finishing this course. I love being in a field where I can use my skills to protect users, data, and systems daily. I work behind the scenes to identify and mitigate threats, and I'm always learning about the new and novel tools and techniques that attackers use to gain access to information. If you're interested in a career in cybersecurity, I encourage you to pursue it. It's a challenging and rewarding field, and we need more talented people like you to help make the world a safer place. Together, we can make a difference. Let's go through all the things you learned in this course. You started by learning about identity management principles and the implementation of effective access controls in cloud environments. You also examined the concept of trust boundaries in cloud security. Then, you compared two widely used security models, traditional perimeter security and zero trust. Next, you explored best practices for managing threats and vulnerabilities in the cloud, including asset management, vulnerability remediation, and posture management. And you learned about the cloud-native concepts of rehydration and reinstantiation. You also explored the key cloud concepts of ephemerality and immutability. You learned how infrastructure as code, IAC, and policy as code, PAC, let you build security into your cloud environment. You learned all about containers, including container orchestration and security. Then, you learned about data protection and privacy, including data sovereignty and data governance. Finally, you learned how business continuity planning can prepare you to deal with disruptions to your organization's cloud resources. You now know all about the essential aspects of securing digital assets in the cloud. And you have a well-rounded understanding of the tools and techniques needed to protect your organization's data and infrastructure. Great work throughout this course. Congratulations on the milestone.
Hey there! You're well on your way to becoming a cloud security wizard. Ready to explore the magic of cloud security? Me too. First, let me tell you a little bit about myself and how I stumbled into the captivating field of cloud security. I'm Celine, and I'm a security engineer. Just like many of you, I didn't start my career in cloud security. In college, I studied computer science, where I focused on becoming a software engineer. It wasn't until I completed an internship doing penetration testing that my plans changed. I discovered that cybersecurity was the career path I wanted to follow. I continued to grow my skill set by learning on my own, doing trainings and getting certifications, just like you're doing now. Moving forward, after different experiences and learnings, today I proudly wear the hat of a security engineer on Google's Red Team, where our main role is to make hacking Google harder by hacking Google. Through simulating adversaries, we can identify and help fix security issues that attackers could exploit to achieve their goals. These exercises help test Google's detection and response capabilities, improving our resilience against real-world attacks. Cloud cybersecurity is like solving exciting puzzles, but with real-world impact. It's a field where you can truly make a difference. Stick with me, and together we'll explore the fascinating world of cloud cybersecurity. To help prepare you for a role as a cloud security professional, you'll start with discussing the foundations of incident detection. Here, you'll learn about security operations teams and how they use logging, monitoring, and detection tools to manage security incidents and secure cloud environments. Next, you'll explore applied detection, where you'll go in depth about how security teams use detection tools and techniques to promptly detect security attacks in the cloud. Here, you'll explore Lockheed Martin's cyber kill chain monitoring tools, indicators of compromise, and threat hunting. Then, you'll explore incident response, where you'll learn about the various processes and security tools involved in incident response. This includes how to preserve and document evidence, analyze alerts, and utilize automation. Finally, you'll end off by discussing incident recovery, where you'll learn about how security teams recover after a security incident. Here, you'll focus on how organizations create business continuity and disaster recovery plans using considerations like recovery metrics. You'll also learn about the role of stakeholders in disaster recovery. When you're ready to get started, join me in the next video. Hi, I'm Celine. I'm a security engineer on Google's Red Team. My team simulates real-world attacks on Alphabet, Google's parent company, to make the company and its users safe. After earning a bachelor's degree in computer science, I completed multiple cybersecurity-focused internships. I didn't stop learning there. Over time, I sought certifications and took online security courses to continue my educational journey. My first job was as an entry-level security consultant. I was exposed to customers in many different industries, operating in varying system environments. After gaining several years of experience learning both on and off the job, I joined Google's vendor security team. I then transferred to my current role on the Red Team, where I perform threat simulations to help make Alphabet and its users safe. When not at work, I also like to apply my cloud security skills outside of my day-to-day responsibilities. I really enjoy mentoring, tutoring, and volunteering my technical skills through nonprofit organizations. There are so many opportunities to make an impact in the cloud security space, and we need people like you to help make a difference. Are you ready to learn about detection, response, and recovery from cyber attacks? You'll start by discussing logging, then explore detection, response, and monitoring. Next, you'll learn about incident management and how to handle an incident if it happens. Let's review what we'll cover in more detail. First, you'll be introduced to logging fundamentals. Then, you'll discuss the role of logs in maintaining a secure environment. You'll also learn how log retention policies can help you detect and remediate potential cyber breaches. Next, you'll discuss different types of intrusion detection and response, and how they can be used to safeguard your cloud resources. You'll also learn about different monitoring methods and how to set up alerts to help you identify and handle potential security threats. Finally, you'll discuss how to handle security incidents and examine the incident management process. You'll also learn how to report, investigate, and resolve security breaches. That way, you'll be able to act quickly and efficiently to minimize damage if an incident happens and prevent similar breaches in the future. As soon as you're ready, let's meet in the next video. Operations make up the core structure of many different businesses and industries. For example, making sure a zoo runs smoothly requires an effective operations infrastructure. This includes everything from well-trained employees to fences, paths, and restrooms. All of this ensures that visitors have a positive experience. Similarly, cloud security often uses operations to make sure assets are protected. In this video, you'll explore security operations and discuss how professionals leverage different tools to enhance their security operations. Security operations, or SecOps, is the practice of combining people, processes, and technology to effectively protect an organization's data and infrastructure. High-level goals of SecOps includes detecting, preventing, and mitigating threats in real time. In cloud security, SecOps consists of several key components, including logging and monitoring, incident detection, incident response, and incident recovery. Let's review each of these components. Logging and monitoring are essential for maintaining visibility in your cloud environment. A log is a record of events that occur within an organization's systems. By collecting, analyzing, and storing logs, security professionals can identify potential security threats, track changes, and monitor user activities. This information will enable you to detect anomalies and take appropriate action to prevent security breaches. Incident detection is the process of identifying and addressing security threats in the cloud environment. This process includes analyzing log data, correlating events, and prioritizing incidents based on severity and potential impact. By detecting incidents promptly, security professionals can minimize the damage and prevent further escalation. Incident response is the process of identifying, investigating, and mitigating security incidents promptly and effectively. This includes assembling a response team, containing the threat, investigating the root cause, and communicating with stakeholders. A well-executed incident response plan can help mitigate the impact of a security breach and prevent future occurrences. Incident recovery is the process of restoring affected systems and data to their normal state. This is the final component of the SecOps process and may involve patching vulnerabilities, repairing damage, and implementing new security measures to prevent future incidents. Google Cloud offers a range of tools and services that can enhance your SecOps capabilities. Some of these tools include Google Cloud Security Command Center, or SCC, Chronicle SIM, Chronicle SOAR, VirusTotal, and Mandiant Threat Intelligence. Let's first discuss Google Cloud Security Command Center, or SCC. This tool is an on-guard security specialist for all things Google Cloud. It monitors data security risks and potential threats using its dashboard and data analytics. SCC also identifies security findings, keeps an inventory of cloud assets, and even scans web applications for security threats. Next is Chronicle's Security Information and Event Management, or SIEM. This tool provides actionable security insights in real time. Chronicle's SIEM tool takes massive amounts of machine data and translates it into helpful security information. Chronicle also offers security orchestration, automation, and response solution, or SOAR. This tool gives teams the power to fight common threats by using automated response workflows. From managing alerts and cases to deploying incident response playbooks, SOAR ensures security teams are able to shift from detection to response quickly. Now, let's discuss VirusTotal. This service is an online detector used to identify malicious content. Just submit files or URLs to VirusTotal, and it will analyze them using various tools like antivirus engines and website scanners. VirusTotal also uses analysis tools to detect viruses, worms, or Trojans. Last is Mandiant's Threat Intelligence. This service offers more than just security updates. Mandiant's Threat Intelligence helps security professionals understand the tactics, techniques, and procedures used by global threats before they happen. Actively applying this knowledge is beneficial to establishing defensive strategies and maintaining strong SecOps. In this video, we explored the world of SecOps, its key components, and how teams leverage Google Cloud tools to enhance their security operations. By understanding and implementing these concepts, security professionals are on their way to strengthening an organization's cloud infrastructure. Good management is the key to successful operations. In this video, you'll explore security operations management. You'll also learn key concepts like vulnerability management, red team, blue team, penetration testing, and tabletop exercises. Vulnerability management is the process of finding and patching vulnerabilities. Monitoring and managing vulnerabilities can minimize the risk of cyber attacks and protect valuable assets. Here's an example. A software company ensures the security of its cloud infrastructure by using advanced automated tools to regularly scan for vulnerabilities. When discovering high-risk vulnerabilities, the company prioritizes patching to prevent potential attacks, demonstrating its commitment to safeguarding its infrastructure and protecting users' data. In vulnerability management, the red team and blue team play crucial roles. A red team is a group of ethical hackers who mimic potential adversaries in order to examine the security defenses of an organization. As a cloud security professional, the red team can be part of your organization, or they can be part of an outside group hired to test your security. By simulating real-world cyber attacks, the red team helps your organization understand its weaknesses and improve its security posture. The blue team is a group responsible for defending the organization's systems and networks from simulated attacks. They work closely with the red team to identify vulnerabilities and implement security measures to protect your systems. The blue team focuses on monitoring, detection, incident response, and recovery to ensure your organization's security remains robust. Here's an example. A financial institution hires a red team to simulate a cyber attack on their online banking platform. The red team identifies a vulnerability that allows them to access sensitive user data, highlighting the need for improved security measures. In response to the red team's findings, the financial institution's blue team implements additional security controls like multi-factor authentication and encryption to protect user data from potential attacks. Organizations can also use penetration testing to manage vulnerabilities. Penetration testing, or pen testing, is a simulated attack that helps identify vulnerabilities in systems, networks, websites, applications, and processes. Penetration tests can include exploiting weaknesses in various parts of an organization's security, like networks, applications, and even physical security measures. By conducting pen testing, organizations can better understand their risk level and prioritize remediation efforts to strengthen their overall security posture. Imagine this scenario. A healthcare organization initiates a penetration test on their patient portal. The objective is to assess the security of patient data. The penetration test found a vulnerability that allowed unauthorized access to an insecure application programming interface, or API, linked to the patient portal. Despite the organization having detection protocols in place, the unauthorized access to the API went undetected. The organization realizes they've missed an opportunity to identify a security incident. As a result, the organization adds additional security measures, including encryption, adjusted access controls, and more robust authentication. They also initiate a reassessment of their security event log coverage, monitoring for better incident detection and response. Finally, the organization commits to conducting frequent security audits for real-time evaluations. This case highlights the need for a robust SecOps approach to minimize potential vulnerabilities, retain data security, and repair technical loopholes. Finally, let's discuss tabletop exercises. Tabletop exercises are scenario-based exercises that involve an organization's security team and other stakeholders. During tabletop exercises, participants take part in a guided conversation centered around a scenario in a relaxed and informal setting. These exercises aim to replicate emergency security situations and are grounded in the organization's current policies, plans, and procedures. As the exercise unfolds, team members examine their roles and responses to the simulated crisis. They put their incident response plan to the test, assessing the organization's readiness. The main objectives of tabletop exercises include fostering a deeper understanding of concepts, pinpointing strengths and weaknesses, and driving changes in policies and procedures. For example, imagine a retail company conducts a tabletop exercise simulating a ransomware attack on their point of sale or POS systems. This exercise includes participants from various departments like security, store management, and IT support. The exercise uncovers gaps in the company's incident response plan, including insufficient data backup procedures, unclear roles and responsibilities, and inadequate employee training. It also highlights the need for improved communication between security teams and store management. Based on these insights, the company can proactively address these gaps by updating their incident response plan, conducting regular employee training sessions, and implementing robust data backup solutions. These changes enhance the company's overall security posture. Security operations management is an essential part of maintaining a strong cloud security posture. By understanding the roles of the red and blue teams, conducting penetration testing, and participating in tabletop exercises, organizations can effectively manage vulnerabilities and protect their assets in the cloud. As a cloud security analyst, you're the first line of defense when a system has been compromised. That's a very important role. In this video, we'll explore the significance of incident detection in maintaining a secure cloud environment. Incident detection is the process of identifying and addressing security threats in the cloud environment. By detecting these threats early on, you can take quick action to minimize risks and protect valuable digital assets. Within the Google Cloud ecosystem, there are powerful threat detection tools specifically designed to assist with incident detection. One of these tools is the Google Cloud Security Command Center, or SCC. SCC, which can help you gain visibility into your cloud resources and detect potential security threats. It provides insights, alerts, and recommendations to enhance incident detection and response. Another tool is Google Cloud Logging and Monitoring. This tool enables you to collect, analyze, and visualize logs and metrics from your cloud infrastructure, allowing you to identify suspicious activities and potential security incidents. Last are the tools included in the Google Chronicle Security Operations Suite. Chronicle SIEM, SOAR, and Threat Intelligence provide security professionals with the ability to detect, respond, and analyze incidents from several different sources. Now that we've discussed threat detection tools, let's explore incident detection. The focus of incident detection is to spot anything out of the ordinary, like strange patterns or abnormal events. For example, this could include a user login from a new physical location. The faster you can detect these types of occurrences, the more effectively you can respond to any issues and keep your cloud systems secure. To be successful in incident detection, cloud security professionals should consider the following common questions. What are the indicators of compromise associated with this incident? What is the potential impact? What critical systems or resources are affected? Has the incident spread to other systems? Are there any indicators that an attack is still in progress? And what evidence should be collected to help my team? By asking these questions, you'll be able to quickly assess and triage a security incident. And your answers to these questions can strengthen your team's ability to respond effectively to these types of incidents. So whether you're starting your career in security operations or looking to specialize, mastering incident detection will improve your ability to identify, evaluate, and respond to unforeseen security events. In cloud security operations, incident management plays an important role in ensuring swift response to potential threats. How can you, as a cloud security professional, handle these incidents when they arise? Well, with a plan. In this video, you'll learn about the phases of the NIST incident response lifecycle, which provide a structured approach to managing security incidents in a cloud environment. The manner in which cloud security professionals manage incidents is an important part of cloud security operations. Effective incident management helps minimize the impact of security incidents, enables you to quickly identify and repair vulnerabilities, and also ensures that your organization remains compliant with regulations and industry standards. Now let's discuss the NIST Incident Response Lifecycle. This framework was developed by the National Institute of Standards and Technology. It provides guidelines and best practices for a structured approach to handling security incidents. You can use this framework to guide your response to security incidents. It consists of 4 phases: preparation, detection and analysis, containment, eradication and recovery, and finally, post-incident activity. Now, you'll learn about how to apply the NIST Incident Response Lifecycle to incident management. You can also follow along with a practical example within Google Cloud. The first phase of incident management is preparation. This includes everything an organization needs to do before a security incident occurs. During this initial phase, an organization develops an incident response plan, defines policies, assigns roles and responsibilities, and identifies critical assets. The second phase is detection and analysis. The goal of this phase is to identify security incidents early on by collecting and analyzing data using monitoring and logging. Detection can happen in many ways. For example, a user might report an issue, or a security monitoring solution might generate an alert. In Google Cloud, you can use tools like Security Command Center, Cloud Logging, Cloud Monitoring, Chronicle SIM, Error Reporting, and Stackdriver Trace to detect anomalies, trigger alerts, and analyze logs. With detection tools, you can configure alerting policies to notify you when a specific event happens, like an admin login from an unusual location. With analysis tools, you can also examine and analyze incidents. An important part of this detection process is examining events surrounding the alert. For example, examining any logins before the alert and monitoring any changes, like role assignments or unusual configuration changes after the alert. During the investigation, it's also helpful to ask questions that can triage the incident. Some types of questions include how the alert was initially detected, the timing of detection, what logs are accessible, and if there are signs of ongoing unauthorized access. The third phase is containment, eradication, and recovery. After the incident has been correctly identified, any compromised systems need to be contained to limit impact. The attacker's system's access must be removed, and any damage they caused must be completely eradicated from the system. Recovery actions are then performed to return operations to normal, ensuring that all systems are functioning as expected. This gives the organization the opportunity to implement more precautionary measures moving forward. There are several cloud tools that you can use to enable containment, eradication, and recovery actions. This includes preventing the spread of malicious activity and minimizing data loss. By leveraging Google Cloud's capabilities, you can isolate the resources that have been affected using Virtual Private Cloud, or VPC firewalls, with the Cloud Security Scanner. Also, Identity and Access Management, or IAM, plays a key role in the containment and removal of an attacker in cloud environments. By leveraging IAM features, you can address the security concerns identified during the detection and analysis phase. This includes actions like disabling compromised accounts, revoking suspicious OAuth tokens, and blocking untrustworthy IP addresses. In Google Cloud, Many services work collectively to safeguard data, automate infrastructure, and ensure consistent deployments for reliable operation. These services can be used as tools to assist you in your containment, eradication, and recovery efforts. Google Cloud SQL's automated backups consistently preserve important data, and its point-in-time recovery feature allows restoration of the database to an earlier state in case of accidental modifications. Alongside this, Deployment Manager automates the process of deploying and managing your services and resources for consistent handling of configurations, enabling automatic scaling and balancing of applications. Google Cloud Backup and DR Service is a complete disaster recovery solution safeguarding data, applications, and digital assets. It ensures system restoration post-disaster, verifies backups for readiness, and offers configurable on-demand and scheduled backups. It also includes testing and planning for quick recovery in case of system failure. It's important to remove an attacker and isolate and restore any critical services after an attack. You also need to be careful while restoring systems to avoid accidental reintroduction of malicious elements like backdoors, compromised accounts, or command and control or C2 elements. These can potentially offer the attacker a chance to reestablish a presence in your system, especially if you restore the vulnerabilities that were present in the system before the initial attack. The final phase in the incident management process is post-incident activity. This phase is where you learn from the incident and identify areas of improvement. Once the threat has been successfully contained, you can perform post-incident activities, such as conducting a post-mortem analysis, documenting the incident, and implementing changes to prevent similar incidents in the future. Cloud tools can be used to facilitate post-incident activity. Google Cloud's Cloud Audit Logs and Cloud Security Command Center's continuous monitoring and recommendations are valuable resources in understanding the actions leading to the incident and identifying improvements. Google Cloud's Cloud Audit Logs can help you understand the actions that led to the incident and identify areas for improvement. You can also use Cloud Security Command Center's continuous monitoring and recommendations to proactively improve your security posture and prevent future incidents. It's also recommended that your organization adds more security measures, like implementing IAM organizational policies to enforce settings and restrictions, and strengthening network security with VPC firewall rules. By following these phases to guide your incident response, you can effectively detect, analyze, and resolve security incidents. This minimizes their impact on your organization's infrastructure and data. With Google Cloud's comprehensive suite of security tools, you'll be well equipped to handle any security incident that comes your way. Knowing how to respond to an incident can boost your confidence and make you a valuable asset to your security team. If you've ever planned a dinner party, you know there are a lot of steps involved. You have to invite guests, shop for ingredients, clean your home, prepare food in a timely manner, and create a welcoming environment. Having a plan in place reduces the likelihood that something can go wrong. Incident management works similarly in cloud security. In this video, we'll discuss the importance of incident management. We'll also dive into ways to build an effective incident management plan. Let's get started. Incident management is an important part of cloud security. It helps organizations identify, analyze, and respond to security incidents in a timely and efficient way. By having an incident management plan in place, you can minimize the impact of security breaches and maintain the continuity of operations. Let's briefly re-examine the NIST incident response lifecycle. The key phases of the lifecycle are preparation, detection and analysis, containment, eradication, and recovery, and post-incident activity. When forming an incident management plan, it's important to be thoughtful while applying each step. You should also be aware of the typical responsibilities associated with incident management. This will help ensure a comprehensive and effective approach. The first phase of an incident management plan is preparation. One way to begin preparation is to assign roles and responsibilities associated with incident management to all relevant stakeholders. Roles may include incident reporters, who are responsible for identifying and reporting incidents to the appropriate teams, incident responders, who are responsible for analyzing and prioritizing incidents, coordinating response efforts, and implementing containment, eradication, and recovery measures. Stakeholder communication executives, who are focused on ensuring transparent communication about the incident status and associated actions to all relevant parties. Incident review and improvement analysts, who concentrate on conducting post-mortem analyses, pinpointing areas of improvement, and refining the incident response plan post-resolution. Clear, designated roles and responsibilities ensure that there's open communication channels, improving communication between relevant points of contact. The second phase of an incident management plan is detection and analysis. A comprehensive and effective system for incident detection and analysis should include a combination of several components aimed at identifying, detecting, and managing potential security threats. Through the use of monitoring and alerting tools, security professionals detect threats to a system. They also use security tool integration to respond to threats and report their findings. Let's examine these components more closely. First, monitoring and alerting tools like Google Cloud Monitoring and Grafana can help identify potential threats in real time. Next, advanced detection measures work alongside monitoring tools to recognize and validate threats. You can use this component to differentiate between normal operations and possible security threats or breaches. Next, security tool integration can help facilitate efficient, real-time threat detection and response. For example, an organization's SIEM platform can be integrated with tools like Elastic Stack or Alien Vault OSIM. Finally, it's important to establish well-structured incident reporting and escalation protocols. Tools like Sentry or Google Issue Tracker can be used to help ensure that incidents are reported and escalated to the corresponding personnel or teams. Some examples include the Security Operations Center, or SOC, and the Incident Response Team. When combined, these components help create a robust and comprehensive system, ensuring optimal incident detection and reporting. Once an incident has been detected and reported, it must be analyzed. The Incident Response Team should gather all relevant information and determine the severity, scope, and potential impact of the incident during this step. The analysis process can be broken down into steps. First, review logs and data sources to grasp the incident's nature. Then, analyze network traffic to find patterns and vulnerabilities. Next, examine affected systems to assess damage and pinpoint exploited weaknesses. Then, collaborate with the IT and security teams to gather more information and insights. After that, be sure to preserve evidence properly. It's crucial when involving law enforcement. Finally, consider engaging professional incident responders who have expertise in chain of custody and evidence collection. The third phase of an incident management plan is containment, eradication, and recovery. After an incident has been analyzed, security professionals need to contain the attack, eradicate any malicious elements, and recover the affected systems. Containment involves stopping the attack from causing further damage, while eradication focuses on removing any malicious elements from the affected systems. During the containment and eradication portion of this phase, security professionals will implement network segmentation or isolation to prevent the attack from spreading. Remove and rehydrate any affected system where there is no concern for data loss. And eradicate malware from systems that contain critical, useful, or important data. Once the issue is contained and eradicated, the recovery process starts. During the recovery process, security professionals will patch vulnerabilities and update software to prevent future exploitation, restore data and applications from backups, ensuring that they're free from any malicious elements, and monitor the environment to ensure the incident has been fully resolved and that no additional threats are present. Security professionals should also consider managing identity and access management, or IAM, which includes disabling and expiring tokens, resetting passwords, and deprivileging accounts. Also, it's important that they revoke access or disable service accounts to minimize potential risks and maintain security. After a security professional has remediated an incident, they'll move on to the fourth phase of an incident management plan, the post-incident activity. In this phase, the security professional and their team will examine how the problem was handled to identify ways to improve their response in the future. This may involve enabling additional tools for monitoring blind spots discovered through lessons learned, conducting a post-mortem analysis to determine the root cause of the incident, and identifying any gaps in the incident response plan, updating policies, procedures, and technical controls to prevent similar incidents in the future, and providing training and awareness programs to educate employees on the latest threats and best practices for maintaining security in the cloud environment. Following our continuous learning approach, we also focus on regularly reviewing and updating the incident response plan to ensure it remains effective and aligned with the organization's needs and objectives, completing regular incident response exercises for preparedness against potential threats, and testing offline backups and restoring processes to ensure data integrity. In this video, we covered the essential steps in building an effective incident response plan. By following the steps in the phases of the NIST incident response lifecycle and continuously improving your plan, you'll be better equipped to detect, respond to, and recover from security incidents in your cloud environment. Planning ahead and preparing effectively will make you better equipped to respond to a multitude of security situations. Hi there! In this video, we'll focus on the fundamentals of intrusion detection systems. We'll also discuss their relevance to Google Cloud and explain how these systems can strengthen your cloud infrastructure's defense against digital threats. When working as a cloud security professional, your system may not display flashing red lights or exclaim "intruder alert," but using intrusion detection systems, you can detect when unauthorized access is taking place. Intrusion detection system, or IDS platforms, are crucial because they actively monitor and analyze your networks for any malicious activities or policy violations. An IDS works much like a security camera system in a bank. The security cameras monitor the physical environment for any suspicious activity. In the same way, an IDS monitors a cloud environment for any malicious activity. Without an IDS, your organization could be left vulnerable to attacks, potentially damaging your data integrity and compromising your cloud security. Cloud IDS actively uses IDS principles to enhance security by detecting network threats, managing in the cloud, having thorough security, keeping full traffic visibility, meeting customer compliance, focusing on main threats, finding disguised apps, and providing efficient performance. Let's briefly review each one. Cloud IDS actively provides a strong defensive mechanism against a variety of exploit attempts, protecting the network from threats. By detecting network threats, Cloud IDS identifies intrusive and obstructive behavior throughout both network and application layers. Additionally, Cloud IDS identifies concealed malware hidden in various file formats and web content. By managing in the cloud, Cloud IDS allows you to manage your systems in a way that best suits your needs. For example, the user interface, or UI, offers a user-friendly and intuitive visual dashboard, enabling those with minimal technical skills the ability to manage systems easily. For those who have expertise in command line operations, the command line interface, or CLI, is an efficient option. CLI allows the user more control and precision. Application programming interfaces, or APIs, are another way to manage Cloud IDS. These are ideal for users who need their systems to interact with other software or need to perform operations at scale. These different management options, including UIs, CLIs, and APIs, offer flexibility to users, from those who prefer simplicity to those who want more complex, integrated operations. Having thorough security can be achieved by maintaining threat detection capabilities. Cloud IDS integrates with Palo Alto Network's threat detection capabilities to provide a broad security range. The built-in catalog of attack signatures updates continuously, allowing systems to keep up to date with emerging threats. Next, keeping full traffic visibility is vital for detecting intrusions. Cloud IDS, equipped with Google Cloud's packet mirroring, actively expands its reach beyond standard internet traffic. It includes communication within and between virtual private clouds, or VPCs. This enhancement allows for efficient detection of suspicious lateral movements that could suggest the presence of potential intruders, significantly strengthening cloud security. Meeting compliance standards is a critical goal for many organizations. Cloud IDS actively helps customers meet compliance standards by providing strong network threat detection. Using advanced algorithms, it identifies risks in real time and supports businesses in adhering to required standards. With customizable options, Cloud IDS adjusts to unique risk levels and ensures constant network security, maximizing threat detection while minimizing false alerts. Focusing on main threats is important for security teams because they need a way to properly classify threats. With Cloud IDS, the system actively goes beyond identifying threats. It also categorizes them into distinct severity levels. This intelligent classification enables you to prioritize your security responses and focus on the most critical issues first. By streamlining your security measures, you can effectively protect your infrastructure and respond to potential risks more efficiently. Cloud IDS closely integrates with Palo Alto Network's App ID technology to support finding disguised apps impersonating legitimate ones. It helps deliver an effective barrier against potentially harmful incursions. This combined capability also strengthens cloud security and contributes to improved safeguarding of digital resources. Providing efficient performance is at the core of Cloud IDS capabilities. Depending on your organization's unique requirements, it can efficiently scale up or down to examine all incoming and outgoing traffic. This flexibility ensures that there are no compromises in performance levels. By adapting to various traffic volumes, Cloud IDS consistently delivers reliable security measures while maintaining optimal network efficiency for your organization. The foundational IDS principles are critical tools in your cybersecurity toolbox. When implemented within Google Cloud, these techniques can strengthen your defenses. Having a full toolbox means you can respond to a variety of problems with ease. Now, let's explore signatures. A signature is a pattern that can be associated with malicious activity. A signature actively checks packet patterns for any malicious activity using factors like IP addresses, used ports, types of protocol, and payload details. In network security, a signature database should be regularly maintained and updated. The signatures in this database are designed to identify specific patterns in network traffic that may indicate malicious activity or potential threats. Just like a security camera can be set up to monitor specific objects or activities. When network traffic is analyzed, it's compared to these signatures. If there's a match, it could indicate a potential threat. As new threats and attack techniques emerge, the signature database must be updated regularly to remain effective. Here's an example of a signature. This Python dictionary is evaluating network traffic from a specific source IP address, utilizing the TCP protocol to make requests at the destination port 80, and carrying a payload labeled as exploit_payload. Now, let's discuss anomaly-based detection. Anomaly-based detection is an alternative to signature-based detection that involves creating a normal baseline for network activity. This baseline is then used as a standard for comparison to identify activities that aren't part of normal network operations. This security system is like a tireless guard. It keeps a constant watch on all the network traffic, comparing it against a baseline of regular or average network activity. Now, if there's any traffic that significantly changes or moves away from the baseline, the system sends an alert. These differences can often signal an unwelcome intrusion or an irregularity in progress. So while you're busy with other tasks, your system remains watchful, prepared to notify you of any harmful intrusions. Here's an example of how you can detect anomalies with SQL Query. SQL Query is designed to model the regular behavior of a network by retrieving historical data on network traffic over a specific time period. It also groups activities based on source IP, destination port, and protocol. This query has several effects. It provides insights into the network's normal behavior, establishes a baseline for comparison, and enables the comparison of current traffic to the established norm. Running this query provides a comprehensive understanding of which source IP addresses, destination ports, and protocols are commonly used within the network, allowing better detection of any deviations or anomalies. Anomaly-based detection is an effective strategy when dealing with new or unidentified threats that may not have an identifiable signature. They say that knowledge is power. In this video, you'll learn about logs in Google Cloud. You'll understand the different types of logs available and find out why log retention is important. You'll also discover how logs can be used for analysis and monitoring, and how to manage retention policies using these logs effectively. Let's get started. To get started with logs, you need to know the 4 foundational terms associated with logging. First, a log is a record of events that occur within an organization's systems. Second, log analysis is the process of examining logs to identify events of interest. Third, logging is the recording of events occurring on computer systems and networks. And fourth, log management is the process of collecting, storing, analyzing, and disposing of log data. There are several ways logs can be used. For example, log analysis analyzes logs for patterns and trends to identify potential security issues. Setting up monitoring alerts based on specific log events notifies security teams of potential incidents. It's also important for teams to regularly test the monitoring to ensure its effectiveness. Maintaining retention policies ensures logs are retained for the required duration to meet compliance and security needs. And threat detection proactively detects and mitigates security threats based on log data and analytics. Logging contributes to security monitoring and incident detection by providing valuable information about activities within systems. By analyzing logs, security teams can identify suspicious patterns, detect potential security breaches, and investigate incidents. In Google Cloud, a variety of log types are generated, each serving a unique purpose. Types of logs include admin activity audit logs, data access audit logs, system event audit logs, and policy denied audit logs. Let's explore each of these log types in detail to help you better understand their functions and use cases. Admin activity audit logs provide a view into the activities of administrators and other authorized individuals. These logs track who did what, when, and where. Actions like creating databases, deleting instances, or changing permissions would be found here. Here's an example of an admin activity log. Admin@example.com created a new table in Google Cloud Bigtable. The log entry shows the user performed a create table operation in Bigtable service. Now let's explore data access audit logs. Data access audit logs record API calls that create, modify, or read user-provided data. In other words, these logs tell when data is created, modified, and read, and by whom. Examples of these activities include Google Cloud Storage object accesses and data store database reads and writes. Here's an example of a data access audit log, which records a specific event. The code is a JSON representation of a data access audit log entry from Google Cloud. In this case, the event is a read rows operation in Google Cloud Bigtable. Next are system event audit logs. System event audit logs report changes to your system's configurations and settings. Some examples of changes to a system include alterations to the settings of a cloud service. These logs provide invaluable information that can be used to detect anomaly behaviors in systems. Here's an example of a system event audit log. This is a JSON snippet from a Google Cloud audit log, which records system events for Google Cloud resources. Simply put, this log shows that a migration of a compute engine instance took place because of host maintenance. And finally, there are policy-denied audit logs. Policy-denied audit logs capture instances where requests were denied because of existing IAM policies. Unauthorized access attempts and modification requests by users without the required permissions can be found here. These logs provide a strong audit trail of any failed access requests. Here's an example of a policy-denied audit log in Google Cloud. This log documents a denied attempt to start a compute instance using the im.serviceaccounts.actAs permission on my project. It effectively tracks unauthorized actions for security and compliance purposes. Understanding the 4 crucial types of logs in Google Cloud can help manage systems and improve cloud cybersecurity. Now, let's dive into the log lifecycle and retention. Logs follow a lifecycle that includes generation, storage, analysis, and eventual expiration. Log retention is an important part of the log lifecycle, as it's used to preserve logs for a specific period to meet regulatory requirements and facilitate historical research. Retained logs can be used to investigate past incidents, identify trends, and improve security posture. With Google Cloud, users can decide how long to store their logs. Based on the needs of their organization, users can balance the cost of storage and the need for past data. Users also might choose to save their logs to cold storage or store them offline. With these options, if a security breach lasts longer than an organization's usual log storage period, it won't lose access to vital log information. So where are logs located in Google Cloud? Logs in Google Cloud can be found in various locations. These locations include the logging section of the Google Cloud Console, Cloud Operations, and BigQuery. Security information and event management, or SIM systems, like Chronicle, can aggregate logs from different sources, providing a centralized platform for log analysis and security monitoring. In this video, you learned about logging and log retention, the different types of logs in Google Cloud, and how logs can be used for analysis, monitoring, and maintaining retention policies. With this knowledge, you can effectively manage and secure your cloud environment. There's often a lot of discussion about technical skills, but what about human skills? Businesses are as interested in skills that allow a person to fulfill their responsibilities effectively as they are interested in technical knowledge. And chances are, you already have a lot of awesome human skills that you've learned throughout your life. In this video, you'll learn about some essential workplace skills that will improve your effectiveness as a cloud security professional. By closely examining each of these skills, you'll better understand how they can help you maintain a secure cloud environment. Some core workplace skills include high attention to detail, critical thinking skills, effective time management skills, solid communication skills, and adaptability and curiosity. These skills can be applied to many different aspects of cloud security. Let's examine how these skills apply to logs and log management in particular. First, you'll need to be able to focus on a specific task with high attention to detail. Log management requires the ability to examine log files closely and identify potential issues or anomalies. This includes recognizing patterns and trends, identifying errors and security threats, and ensuring data accuracy and integrity. Strengthening your focus on details will help you effectively analyze and interpret log data, leading to better decision-making and problem-solving. Next, you'll need critical thinking skills. This involves analyzing information objectively, evaluating the relevance and importance of data, and identifying potential solutions and mitigations. By applying your critical thinking skills to log management, you can identify the root cause of issues, prioritize tasks, and make well-informed decisions to enhance the security of your cloud environment. The process of log management can often be complex and time-consuming, requiring a significant investment of time and energy. active and successful time management is a skill that allows you to stay organized, maintain focus, and operate efficiently. Key aspects of this skill involve prioritizing tasks based on urgency and importance, allocating appropriate time for analysis and problem solving, and balancing multiple tasks and responsibilities. Log management can be very time-consuming. Having effective time management allows you to stay organized, focused, and efficient so that you can prioritize your log management tasks. In the ever-evolving world of logs and log management, it is crucial to develop and maintain exceptional communication skills. This skill empowers professionals to contribute to a more secure and efficient work environment. Communication skills include clearly articulating findings and insights, collaborating with team members and stakeholders, and writing comprehensive reports and documentation. Strong communication skills enable you to share valuable information with others, ensuring that everyone stays informed about potential risks and security measures. Log management is an evolving field, with new technologies and threats emerging regularly. That's why adaptability and curiosity are essential for log management success. This involves staying up to date on new tools, technologies, and best practices, embracing change and adapting to new challenges, and continuously learning and seeking ways to improve. Can you think of a time when you used any of these skills, either in a work environment or in your everyday life? Chances are you use them more often than you think. But did you know that tools can also help you improve these skills? Chronicle, SIM, and SOAR are two tools that can enhance your essential skills. These tools collect and correlate data, organizing it in a way that makes it easier to decipher. This frees up your attention, allowing you to focus on the details and improving your ability to conduct effective analysis. The data collected by SIM and SOAR can also contribute to your ability to think critically. Functions like intelligent threat detection, customizable alerts, and visualization give you new insights into security operations. And, as a result, new solutions can emerge. SIM and SOAR support effective time management using automation, prioritization of incidents, and centralized monitoring. There are several features within SIM and SOAR that support communication. These include collaboration features, incident tracking, and comprehensive reporting tools. Using these can improve the efficiency and effectiveness of your security operations. Now, let's explore an example scenario demonstrating the importance of the workplace skills we discussed for log management success. Imagine you're a cloud security analyst responsible for monitoring log files from various cloud services. One day, you notice a pattern of failed login attempts from an unfamiliar IP address. This situation requires the application of the skills we discussed earlier. Your attention to detail enables you to spot an unusual pattern of failed login attempts among a vast amount of log data. This observation raises concern, prompting further investigation. Using your critical thinking skills, you analyze the log data and determine that the failed login attempts could indicate a potential brute force attack. You decide to monitor the situation closely and take action if necessary. As you continue to monitor the log files, you must also manage your other responsibilities. Your effective time management skills allow you to prioritize tasks and allocate enough time to address this potential security threat without neglecting other essential duties. You communicate your findings to your team, explaining the potential brute force attack and its implications. Your clear and concise communication ensures that everyone understands the situation and can work together to address the issue. As the situation unfolds, you research the latest brute force attack prevention techniques and apply them to your organization's cloud security measures. Your adaptability and curiosity help you to stay up to date with new developments and continuously improve your log management skills. In this video, you learned how a combination of attention to detail, critical thinking, time management, communication, adaptability, and curiosity makes it easier to address potential security threats. By mastering these workplace skills, you can become proficient not only in log management, but cloud security as a whole, and contribute to the success of your organization's cloud security efforts. Have you ever written a note on a piece of paper to remind yourself of an upcoming responsibility? Cloud security professionals do something similar by setting alerts and notifications within their cloud environments. In this video, we'll go through an overview of alerts and notifications. You'll also learn about false positives and effective management strategies to efficiently handle alert systems. With these insights and strategies, you'll be prepared to start implementing alert management systems in your security operations, or SecOps. Let's get started. In cloud security, protection is the primary defense method. Alerts play an important supporting role in this process. Reliable alerts actively warn of potential issues or threats, helping security professionals identify and address problems quickly. Keep in mind that while some alerts come from security detections, others might not. But focusing on the actual detection is more crucial than the alert itself, because it directly impacts safety. There are some common alert types to consider for a cloud environment. Let's examine 3 types. First is unusual network traffic. Cloud security professionals set alerts to monitor for unexpected spikes in traffic or unauthorized access. Second is suspicious login activity. It's helpful for cloud security professionals to configure alerts for failed login attempts or logins from unfamiliar locations. Third is policy violations. Cloud security professionals create alerts to detect when users attempt actions prohibited by their organization's security policies. It's important to note that not every alert signals an actual threat. Some alerts are just false positives. A false positive is an alert that incorrectly detects the presence of a threat. False positives flag normal activity as potentially harmful or suspicious. False positives increase the workload of the SecOps team, which can lead to lower performance and productivity. The team may experience alert fatigue while handling an overwhelming volume of these alerts, potentially causing genuine threats to slip through unnoticed. Managing false positives effectively involves a methodical and focused approach. Here are the essential steps for managing false positives more efficiently. First, refine alert parameters by adjusting them to align with your organization's specific risk tolerance and security posture. This will enhance the overall accuracy of the system. Next, audit regularly. The task of managing false positives is an ongoing one. Regularly auditing alerts ensures system accuracy. It's also important to collaborate across teams, including all teams in refining, reviewing, and providing feedback. That way, each team can contribute uniquely to more effective identification and management of false positives. Also, apply feedback and utilize it as a powerful tool for continuous improvement. When used effectively, it can improve alert systems' precision and prevent alert fatigue. Next, use automation like AI and machine learning to spot false positives. This will free up your team for more challenging work. Also, make sure you prioritize training and education. Train your staff to manage false positives effectively and keep learning so you can be aware of new threats. It's also important to customize strategies. Given the quick evolution of threats, a fixed strategy is not enough. So it's crucial to tailor false positive management strategies based on shifting needs and situations. And finally, to improve your organization's overall security operations, it's essential to integrate a strategic process for mitigating false positives. By strategically thinking, integrating, and adapting this approach not only reduces alert fatigue, but also strengthens the organization's security posture and risk resilience. Google Cloud offers a comprehensive set of tools designed to assist in creating meaningful alerts. These tools allow users to define alert conditions and parameters, assign appropriate alert policies, and specify preferred notification methods. It's important to adapt this process to your system's unique needs and vulnerabilities, ensuring optimal protection and monitoring. As you manage your alert system, keep the following best practices in mind. Prioritize alerts based on risk level and potential impact. Make use of machine learning to identify patterns and reduce false positives. And regularly audit your alert system to ensure it remains effective. By understanding the role of alerts and notifications in cloud cybersecurity, mitigating false positives, and using Google Cloud tools to set up effective alerts, you'll be better prepared to protect your organization's cloud environment. Cloud security professionals use alerts to manage their cloud environments. In this video, you'll explore how effectively querying alerts can handle cybersecurity threats. Ready? Let's dive into the world of alert search techniques. Querying alerts is the act of scanning through numerous security alerts from your cloud infrastructure to identify possible threats. As a cloud security professional, these alerts provide essential information on potential weaknesses and incidents that need attention. Effective querying, or the use of precise data requests, has become a crucial part of how security issues are handled. This powerful tool reduces risk, forming a strong base for several aspects of active security management. Effective querying allows you to identify important alerts in real time, prioritize high-impact issues, streamline response to incidents, and enhance proactive security posture. Alert filters are instrumental in refining your search results. Chronicle Security Information and Event Management, or SIEM tool, improves search efficiency and threat analysis by enhancing alert filters. These filters focus on specific details, like event categories, severity levels, or timeframes, to narrow down search results. By using Chronicle SIEM, you can streamline your security operations. Chronicle SIEM also offers refined features, like customized filtering criteria, adaptable event correlation, and machine learning-based insights to simplify data management. These functions help manage the flood of data, removing unnecessary information and highlighting the most important alerts. Chronicle SIEM provides better alert filter performance and stronger threat detection and analysis. Let's examine some of the most common filters that can be used in Chronicle to query alerts. The most common filters include alert title, source, destination, severity, and time. They can be combined in different ways to create highly targeted queries. When creating queries, it's important to be specific and thorough. But being too specific may cause some results to be overlooked if they don't match your criteria. So, let's go over some tips for querying alerts. Here are some best practices for querying alerts. Make searches specific to lessen distractions. Save your frequently used searches for future use. Familiarize yourself with the frequency and timing of alerts. And always reassess and change filters as needed. Now, let's review each of these practices. It's important to make your searches specific to lessen distractions. By focusing on key details that directly relate to the issue you're trying to identify, you can find relevant information and insights faster. This targeted approach removes unnecessary data, increases the relevance of your search results, saves time, and reduces frustration. To achieve a more efficient workflow and maintain the same standards in data analysis, make sure to save your frequently used searches for future use. This will not only give you faster access to information, but also significantly reduce the amount of time it takes to accomplish search-related tasks. Familiarizing yourself with the frequency and timing of alerts helps you effectively use your time and resources. By understanding past patterns and changes in the amount of alerts, you can better prioritize your responsibilities. Proper prioritization helps you manage time more effectively and identify alerts that are no longer relevant. Focusing on the most significant alerts makes your work process more efficient and increases your overall productivity. And remember to always reassess and change your filters as needed. It's important to consistently update your filters to stay aware of new risks and technological updates. Paying close attention to alerts can also help you quickly handle any unexpected issues, ensuring potential dangers are handled swiftly and successfully. So remember, implementing strong alert search techniques can speed up a cloud security team's response time, accelerate incident resolution, and improve resilience against cyber threats. Congratulations! You've arrived at the end of this section on detection foundations. On your journey, you explored lots of important topics related to maintaining security and effective incident response of cloud systems. You started by learning the basics of logging and the role of logs in maintaining a secure environment. You also learned about log retention policies. Next, you explored intrusion detection and response, and learned how they can be efficiently utilized to safeguard your cloud resources. You also learned about monitoring methods and setting up alerts. Finally, you learned about the incident management process and how to accurately report, investigate, and resolve security breaches. You also gained strong foundational knowledge of how to act swiftly and efficiently when an incident occurs. You're doing great. Keep up the excellent work. It's great to have you here. I'm so excited to share my cloud security knowledge with you. Coming up, we'll focus on how cloud security professionals can use detection tools and techniques to detect and respond to potential threats. Then, we'll analyze the stages of an attack and discuss false positives. You'll use Lockheed Martin's cyber kill chain to learn about the anatomy of an attack so that you can better defend against one. You'll also learn about the impact false positive alerts can have and how to manage them. Next, you'll learn how cloud security professionals can gain visibility into a cloud environment through security monitoring. And finally, you'll explore indicators of compromise and threat hunting. Are you ready to develop your detection skills? Let's get started. Sometimes, examining things from a different perspective can give you insights into things you might not have noticed otherwise. In this video, we'll examine Lockheed Martin's cyber kill chain framework. This framework will help you understand the anatomy of an attack so that you can better defend against it. Ready to get started? Lockheed Martin's cyber kill chain framework defines the steps of a successful cybersecurity attack. Each attack provides an opportunity for defenders to understand an attacker's mindset, strategy, and goals. Before we discuss the cyber kill chain, it's important that you're aware of Advanced Persistent Threats, or APT. An advanced persistent threat is an adversary that possesses sophisticated levels of expertise, significant resources, and achieves its objectives through multiple attack vectors. APTs are a serious threat to cloud environments. The good news is, the cyber kill chain can be used to identify APT activity and mitigate it. There are 7 steps in Lockheed Martin's cyber kill chain that need to be completed in order for an attacker to successfully complete an attack. As a defender, if you're able to stop an attacker during any step of the chain, you can break it and stop attackers in their tracks. The 7 steps of the cyber kill chain are reconnaissance, weaponization, delivery, exploitation, installation, command and control, and actions on objectives. Let's explore each step in detail. In step 1, reconnaissance, the attacker focuses on gathering information. Before attackers can attack, they need to identify their targets. To do this, they collect as much information about the target as possible. Malicious actors aren't that different from criminals operating in the physical world. Each step of Lockheed Martin's cyber kill chain can be compared to a scenario involving a zoo heist. In this example, the members of the zoo heist team have to take certain steps in order to successfully take rare animals from the zoo. Similarly to how a heist team member would identify the best zoo to target, malicious actors plan their attack by performing reconnaissance. This includes gathering information like employee names and job titles, email addresses, and information about the target's infrastructure, like the services or operating systems being used. After successfully performing reconnaissance, the attacker moves to step 2, weaponization. Similarly, in the zoo heist example, after the heist team members pick their target zoo, they must prepare for the heist by gathering the tools they need, like gloves and bolt cutters. After an attacker successfully creates their exploits, their next step is delivery. In this step, the attacker officially launches their attack. This might be done by sending a malicious email to the target or by performing social engineering. For a heist team member, this step is like arriving at the zoo with their tools in hand, ready to break into the zoo's locked doors. After the attacker has delivered their malicious payload, they move on to the next step, exploitation. The goal of this step is for the attacker to gain access to the target. They can do this by exploiting a software vulnerability. For members of the heist group, this step includes successfully breaking the locks of the zoo to gain access. After the attacker has successfully gained access into the target system, the next step is installation. The goal of this step is for the attacker to maintain access to the target system without the target knowing. They can do this by installing backdoors into the system. Backdoors allow an attacker to bypass security measures and conceal their access. For the heist team, this step includes creating a secret underground tunnel entrance connecting to the zoo, so they can continue to have access to the zoo and easily transport the stolen animals. After an attacker has successfully ensured persistent access to the target system, they begin the command and control step. The goal of this step is for the attacker to be able to remotely control the target system. Common command and control channels an attacker might use include web, DNS, or email protocols. The final step is actions on objectives. This is when attackers achieve their end goal. During this step, they can collect and exfiltrate data, destroy systems, or worse. In the final step of the zoo heist operation, the heist members successfully steal animals from the zoo. In both scenarios, the attacker and the heist team are able to get what they want using the cyber kill chain framework. Now you can use Lockheed Martin's cyber kill chain to anticipate an attack and defend against it. Staying ready means taking as many precautions and steps to prepare as possible. It's not negative, it's false positive. In this video, you'll learn about false positives and false positive analysis. You'll examine their impact, some common causes, and some best practices for managing them. A false positive is an alert that incorrectly detects the presence of a threat. There are many systems and tools designed to notify you of potential dangers. These types of alerting devices appear in our everyday lives and may include fire alarms or heart rate monitors. Consider this example. You're a cloud security professional. You've configured your intrusion detection system to create an alert if it identifies a threat. One day, the alert goes off. After investigating the alert, you determine that it was generated by normal behavior, so there was no harmful impact. That's a false positive. As a cloud security professional, it's important to recognize false positives because they have a big impact on security operations. Specifically, incident management and attack mitigation. False positives can also negatively impact a team's confidence, effectiveness, speed, and resources. It's important that security professionals are confident when dealing with an incident, so they can quickly respond to it while also applying the appropriate resources. Security professionals can't do their job effectively if their efforts are spent on a harmless event. False positives also impact security professionals by creating a phenomenon called alert fatigue. Alert fatigue is the result of all noise and no signal in security environments. Alert fatigue happens when there are so many alerts that need to be addressed, it overwhelms a security team. Over time, too many alerts can lead a team to lower the importance of alerts in day-to-day operations, leading to actual threats being ignored or overlooked. False positive alerts can have significant consequences like wasted time, loss of resources, and increased stress levels. They can also increase exposure to attacks because real threats are being misjudged. These misjudged threats are called false negatives. Let's explore some of the common causes of false positives in regular security operations. False positives can be created from a range of situations, like misconfigurations in tools and systems, over-engineered detection strategies, or even unaccounted changes within the cloud environment. So, what can be done to reduce false positives? False positive reduction strategies include continuously testing and fine-tuning security systems, consistently monitoring logs and alerts, communicating any configuration changes, and contributing to a culture of continuous learning and improvement. By reducing false positives, you can increase the chances that your team can quickly and confidently identify genuine threats. As you dig deeper into cloud security operations, remember that effectively managing false positives is one of the keys to maintaining a strong security posture. Security professionals are at the forefront of securing cloud operations for their organizations. In this video, we'll explore security monitoring to support you in your role in the cloud cybersecurity field. Let's start with an overview of security monitoring. Security monitoring is a systematic process of surveilling systems to detect and handle potential security breaches or incidents. For example, security monitoring is useful for online services that people depend on and use every single day, like banking apps. A single security breach on a banking app could lead to a serious security incident, like customer data theft. And a breach doesn't just leave customer data at risk. It can also cause the organization to suffer financial losses and reputational damage. Security monitoring can help mitigate security incidents. By proactively monitoring all the systems in an environment, cloud security professionals can quickly address threats before they turn into serious issues. To do this, they rely on security tools, resources from the cybersecurity community, and knowledge from the professionals on their team. Making the effort analyze, learn, and adapt is important because security monitoring is a never-ending task, which demands constant attention. New vulnerabilities and attack strategies are being identified every day, making the continuous monitoring of security systems a necessity. Alert systems and tools serve as early warning systems by delivering timely notifications about suspicious activities. This can lead to faster security response times. These notifications can also help cloud security professionals gain insight into security events so they can act and respond efficiently. So what tools do professionals use for security monitoring? Let's explore some of the Google Cloud tools that can help with this. To start, Google Cloud Security Command Center provides a centralized view of all the assets in your Google Cloud environment, helping you identify and address potential security issues. Google Cloud's Cloud Logging is a fully managed service that allows security professionals to store, search, analyze, monitor, and alert on logging data and events. They can leverage cloud logging to track activities and uncover evidence of potential issues. Cloud monitoring is a service that collects metrics, events, and other data from Google Cloud and other applications and systems. As a security monitoring tool, it creates insights about the environment so that cloud security professionals can detect security threats early on. Chronicle is a tool that's designed to retain, analyze, and search data. Chronicle combines the features of security information and event management, or SIEM, and security orchestration, automation, and response, or SOAR. This makes it a powerful security monitoring tool that can be used to quickly detect and investigate security threats. As a SIEM tool, Chronicle collects and analyzes data to detect security threats like malware. As a SOAR tool, Chronicle can be used to automate incident response actions using playbooks. And finally, VirusTotal is a service that analyzes suspicious files, domains, URLs, and IP addresses for malicious content. VirusTotal integrates with Chronicle to support security professionals in their investigations by providing threat context and reputation data relating to suspicious artifacts. These security monitoring tools can provide cloud security professionals with a robust framework to monitor their security systems, set up alerts, and streamline their incident response processes. Cloud security professionals make important contributions to the security monitoring and operation processes. By learning more about these processes, you can support your organization's development of a more secure digital environment.
Hi, my name is Tim. I work on the detection and response team at Google. Our responsibility here is to defend Alphabet from being hacked. Google is a target for literally every attacker out there, from the most sophisticated nation-state attackers to criminals that would look to steal money and steal information and other resources, and also kind of your run-of-the-mill vandals and run-of-the-mill folks that would just look to cause chaos and do harm. The job is very hard, but it's also very rewarding. I mean, being able to protect the information and protect all of the data that users entrust with us, billions of users entrust with us, is at the end of the day extremely rewarding. I studied political science and history in college, but during that time, I did work at the IT department at my university. And the reason I was able to do that was because I tinkered with computers throughout my childhood, right? So, getting my first kind of XT computer, breaking it a bunch of times, having to learn to fix it, learning MS-DOS, etc. Unbeknownst to me, set me up to be able to work in the IT department as a help desk operator, and then growing from there into this field now. Cloud is the present and cloud is the future. If you look in the next 10, even 15 years, everything is moving to the cloud. And I'm not just talking about infrastructure as service, but I'm talking about the pillars that run the cloud and understanding the identity pillar, understanding virtualization, understanding software-defined networking. All of those pillars, those are not going away. They're only increasing in stature, increasing in complexity, and increasing in importance. Cloud is a field that I would highly encourage not just people to join, but people to learn that come from a quote-unquote traditional technical background. I think for people with a non-traditional background, when you build on your communication, when you build on your analytical thinking, those will serve you in any field that you apply yourself to. Everybody who has, had to figure out how to run a schedule in their own life, or who's had to figure out, how to juggle school and work and two jobs and whatnot, those are all skills that, once you kind of zone in and name them, you've had them your whole life. All of this is achievable. For example, I'm a college dropout. I never finished college. It's not about the amount of education that you have. It's not about what you've been through in your past. It's really about the ability to learn new skills and putting yourself out there and applying yourself into this world. The world of technology is so vast and it's growing so fast. It may seem overwhelming, but really, zoom in on the one or two skills you want to build at a time. Make one step forward after the next step forward, and anybody can do this.
Cloud security tools can help identify and address threats. In this video, you'll explore how to use Google Cloud's monitoring tools to proactively monitor your security. Let's start our investigation by examining cloud logging. Cloud logging is a powerful tool that you, as a cloud security professional, can use to store, search, analyze, monitor, and alert on log data and events. Cloud logging is a key component for lots of cloud security activities. You can use cloud logging to search for log entries while investigating potential threats. For example, imagine you're investigating a potential breach where an unauthorized individual has accessed a cloud application. You want to identify whether there are any log entries that indicate that the individual accessed any sensitive data. In this scenario, you could use cloud logging to query for log entries from the cloud application that the individual accessed. Along with cloud logging, you can use Security Command Center, or SCC, for proactive security monitoring. Let's explore these in more detail. SCC is a security solution that helps organizations improve their security posture by detecting threats and managing risk. Cloud provides instant scalability and elasticity, which allows you to quickly expand cloud infrastructure. But this makes keeping track of each cloud asset very challenging. From a security perspective, you can't protect what you don't know. So keeping track of your cloud assets is essential to managing risk, maintaining your cloud security posture, and most importantly, detecting and responding to threats. SCC provides a centralized view of all your cloud assets. They're displayed in a full inventory, providing comprehensive visibility into your environment. This overview also provides you with a way to evaluate each asset for vulnerabilities, misconfigurations, or errors so that you can address them. One of the most common cloud security issues is caused by misconfigurations. SCC can detect whether cloud assets are misconfigured and vulnerable to attack, helping you mitigate security issues. For example, Imagine a media organization provides cloud-based streaming services to its users. But the organization accidentally adds a new critical server to their cloud environment that contains unreleased video content. SCC immediately alerts the security team that there's a misconfiguration in the newly created server. The alert indicates that the server has an open firewall, allowing traffic from the internet to reach the server, which can unnecessarily expose resources to attacks from unintended sources. The organization's security team quickly remediates the issue by adding firewall rules to the server and disabling all traffic coming from the internet. Next, let's examine a component of the Security Command Center, Event Threat Detection. Event Threat Detection is a built-in service for the Security Command Center platform. It provides continuous monitoring of a cloud environment to identify and alert you to any potential threats. Event Threat Detection works by analyzing logs from the cloud logging platform. It analyzes log entries using built-in detection rules. These detection rules then provide security systems with instructions on identifying malicious activity. You can choose which type of detection rules you want to use based on your organization's security needs. An example of a built-in detection rule is a rule that's used to identify and block suspicious account logins. To wrap up, monitoring tools provide cloud security professionals with actionable insights about their cloud environments. So, with these tools, organizations can proactively identify and mitigate threats. How do you know if something in your system has been compromised? Turns out, there are methods to identify potential incidents. In this video, we'll explore a fundamental component of every incident: indicators of compromise. Indicators of compromise, or IOCs, are observable evidence that suggests signs of a potential security incident. IOCs appear as events or signs that suggest a potential security breach has occurred in a network or system. IOCs are a lot like smoke. Smoke warns you that there might be a fire, and fire can mean danger. A potential security breach in a network or system could be a serious issue. So, early detection of IOCs is critical in mitigating threats and keeping cloud environments secure. IOCs link specific data to known malicious activities, processes, or tools. Artifacts like hash values, IP addresses, domain names, or tools can be associated with malicious activity. This is similar to how fingerprints are used to link a known criminal to criminal activity. Here's an example of an IOC. A security analyst receives an alert that a new file was created on a system. The file's hash matches a file hash of known malware. The source IP address also matches a known malicious IP address. In this example, both the file hash and the source IP address are examples of indicators of compromise. It's important to know that IOCs can appear in multiple ways and don't always guarantee the presence of a potential threat. As a cloud security professional, you'll likely engage with IOCs, so it's important you know the best practices for managing them. Let's discuss the 5 general best practices on how to manage indicators of compromise. Proactive monitoring, thorough investigations, risk assessment, timely response, and documentation. Let's start with proactive monitoring. Consistent system and network monitoring helps with the early detection of IOCs. This could include configuring and fine-tuning detection rules to identify anomalies and actively monitor the activity in a cloud environment. Next is thorough investigation. As a cloud security professional, you'll likely investigate IOCs. During an investigation, it's important that you gather all related information to an IOC. That way, you can apply context to its surrounding events to determine if it's benign or malicious. Make sure to be thorough, methodical, and avoid reaching quick conclusions during your investigation. Next is risk assessment. With risk assessment, it's important to identify the systems and data that could be affected by the detected IOC. Make sure you understand the potential impact on your organization and prioritize your response efforts accordingly. Next is timely response. Once you've assessed the potential threat, respond quickly. Your response might include anything from patching a vulnerability to initiating an incident response process. Last is documentation. Make sure to document what IOCs you discover, along with their risk, impact, and anything else that will help you and your team. Clear documentation helps security teams share and access knowledge. It's also a crucial practice that can help improve both future investigations and the overall incident response processes. Now that you know about best practices, let's discuss some helpful tools you can use to manage IOCs. Google Cloud's Chronicle SIEM and VirusTotal are two solutions that can be combined to help identify and respond to IOCs. Here's how they work. Chronicle SIEM collects and analyzes event data from sources that can be used to identify IOCs. Chronicle's integration with VirusTotal then lets you investigate IOCs in more detail by providing threat context, reputation data, and information about the relationship between files, URLs, and domains. Along with Chronicle and VirusTotal, Security Command Center offers key features like security services and integrated partner tools that can help you identify and manage threats. It also provides data on potential attack vectors and vulnerabilities, allowing you to respond quickly to potential IOCs. There are a wide variety of tools in Google Cloud, as well as services from multiple providers that are designed to enhance your ability to identify, investigate, and respond to IOCs. Now that you know more about indicators of compromise, you can be prepared to identify and respond to them. This enhances your ability to protect your cloud environment from potential threats. It's often better to take action before an incident occurs rather than responding to one after it happens. In this video, we'll explore the critical role of threat hunting in security operations. We'll also discuss the benefits of threat hunting and the tools that support it, with emphasis on the cloud. Let's get started. Threat hunting is a proactive method of identifying previously unknown threats within a network. Malicious actors often find entryways and pivot points in a cloud environment so they can remain undetected. Threat hunting can help you, as a cloud security professional, actively search for these types of threats in your environment. It's like being a detective in the cyber world, searching for clues and hints to identify a potential breach or attack. While there are lots of benefits of threat hunting, we'll focus on 3 specific benefits. First, threat hunting helps mitigate security threats. Second, threat hunting helps teams respond faster to potential threats. And third, threat hunting helps inform business objectives. Let's explore each of these benefits in more detail. Threat hunting helps mitigate security threats by identifying issues in your organization's systems and networks so that you can take action to prevent them from causing more damage. Threat hunting helps security teams respond faster to potential threats and make better assessments by actively analyzing network traffic for malicious content and gathering data to investigate incidents and improve defenses. Lastly, threat hunting helps inform business objectives. This not only helps intercept possible threats, it also provides insights into the current state of an organization's security. Organizations can utilize this knowledge to align with their business objectives, priorities, and requirements. Next, let's examine one of the most widely used threat hunting frameworks, MITRE ATT&CK. MITRE ATT&CK is a framework used to understand and approach threats. It provides security professionals with a common language to outline and understand attacks. This is done through its knowledge base of attackers' tactics, techniques, and procedures, also known as TTPs. TTPs are based on actual observed security incidents from known threat actor groups. This makes MITRE ATT&CK a very valuable security tool that can be leveraged in threat hunting. Now, let's explore each aspect of TTPs in more detail. Tactics describe a malicious actor's reason for performing an action or technique. In threat hunting, tactics can be used to identify the different phases of an attack. For example, Initial access is a tactic that malicious actors often use. The goal of initial access is gaining access into a system or network. This is similar to a heist operation, where the heist team's goal is to find a way into their target. In this example, they do this by discovering an underground access tunnel with a padlocked door they can use to access the zoo. Techniques build on top of tactics by describing the specific actions a malicious actor used to accomplish their goal. For example, malicious actors can exploit unknown weaknesses in public-facing applications to gain initial access into a cloud environment. Weaknesses could be anything that is overlooked or undetected in an organization, like a zero-day vulnerability or a misconfiguration. This is like a heist team planning to use the underground tunnel to access the zoo, and finding a tool that provides initial access through the padlocked door. Finally, procedures are the specific implementation of a technique. For example, a procedure can be the specific system or application vulnerability an attacker uses to gain access to a network, like a SQL injection. This is like a heist team using a bolt cutter to open the lock in the underground access tunnel, which allows them access to the zoo. Understanding the different TTPs that malicious actors use in their attacks can help you map a threat hunting campaign. One approach to threat hunting is to take the perspective of an adversary. You can do this by identifying potential attack paths and focusing on specific indicators of compromise associated with the attack path. MITRE ATT&CK is one of the many tools that can be used in threat hunting. Threat hunting can use a combination of different tools to search for threats in an organization. Let's explore some other tools you can use. Tools like Chronicle SIM can be used to hunt for threats and automatically add more context to alerts so that you can better understand and respond to them. For example, MITRE ATT&CK is one of the frameworks you can apply to threat hunting along with Chronicle. Chronicle's MITRE ATT&CK mapping capability helps you understand, prioritize, and improve defensive capabilities. This can be achieved by mapping your organization's security controls against MITRE attack tactics and techniques to uncover potential gaps in your defenses. There are many threat hunting tools available for security teams to use. Threat hunting tools offer benefits in many ways, such as through automated detection, which leverages machine learning and artificial intelligence to detect malicious activities, reducing the time and effort spent on manual investigation. Threat hunting tools also use alert prioritization to prioritize alerts based on severity, enabling you to deal with critical threats quickly. Pattern recognition is used to analyze patterns in data that may indicate a cyber attack, even if that pattern is subtle or complex. With historical analysis, threat hunting tools analyze past activity, which can reveal threats that have been latent or overlooked. That's a wrap on the basics of threat hunting. Remember, in cybersecurity, staying proactive is key, and threat hunting is an important part of that proactive approach. To stay ahead of potential threats and quickly respond to security incidents, organizations need a way to collect vast amounts of data from their infrastructure. In this video, you'll learn about the power of aggregation and correlation. These concepts can help organizations monitor activities, identify patterns, and detect potential threats. Let's dive in. An organization can have many data points in their cloud environments, leading to lots of log data generated by user activities, authentication attempts, firewalls, and intrusion detection and prevention systems. All of this data is important to analyze when detecting and managing incidents. So, the data needs to be properly gathered and consolidated. That's where aggregation comes in. Aggregation is the process of collecting and consolidating diverse forms of data. Aggregation is kind of like farming vegetables. Farmers go through several stages to produce their crops, including plowing land, planting seeds, and watering crops. Farmers plant many different types of vegetables, like tomatoes, corn, or lettuce, on different sections of their land. Once the vegetables are full grown, it's time to harvest them. During a harvest, all of the different vegetables are gathered or aggregated to a central location. Then, they're sent to a processing facility to be sorted. During processing, any damaged or rotten vegetables are removed. After they've been sorted, the vegetables are thoroughly washed to remove soil or bugs. The harvested vegetables are then distributed to grocery stores and purchased by consumers. Just like farmers harvest and process different types of vegetables, in cybersecurity, organizations aggregate data from multiple sources in an environment. By aggregating data like logs and alerts, cloud security professionals can access relevant security data, identify patterns, and gain a comprehensive view of an environment. You might remember that a security event and information management, or SIM tool, collects and analyzes log data to monitor critical activities in an organization. Google Cloud's Chronicle is an example of a SIM tool that aggregates data from a variety of sources, like logs from firewalls and data loss prevention tools. Aggregation collects massive volumes of data. So, how do organizations make sense of it all? This can be done through correlation. Correlation is the relationship between two or more security events. It involves comparing security events, adding context, and making connections between the events. Normalization involves the processing of raw data for consistent formatting. Normalized events improve the performance of correlation. Remember the farming example? Imagine the farmer has plowed the land, planted the fields, and watered the crops. But when it comes time to harvest, the land is very dry, and the farmer finds that the harvest has produced significantly less vegetables compared to previous years. The farmer makes the connection that an extreme drought must have affected the crops, resulting in fewer vegetables. Just like the farmer correlated low harvest yields with drought, in cybersecurity, correlation is used to draw connections between security events. Correlation can be used to address suspicious login attempts. For example, imagine a user logs into an account using a new device, triggering a security alert. The alert then flags the login as suspicious because the user has never logged into their account on this device before. Correlation can be used to cross-reference other relevant data points related to the alert, like the user's commonly used IP address, the date and time of the login, and the user's past login behavior. If the IP address used to log into the device matches the user's IP address, the login was made during regular business hours, and is consistent with the user's login behavior, then the login can be categorized as legitimate instead of a possible breach. Now that you know how to use aggregation and correlation to access data and identify patterns in security events, you can detect and respond to threats more effectively. Being able to sort through large amounts of information is a highly useful skill in cybersecurity. In this video, you'll learn how to sift through aggregated data to find important information. That way, you can support data analysis during the investigation of a potential security threat. Let's begin by learning how to query effectively. When working with logging systems in a cloud environment, you'll likely encounter large amounts of log data from multiple sources. Knowing how to effectively query log data can help you filter, sort, and manipulate log data to find specific information. There are lots of powerful query tools that can be used to do this. One common method is regular expression, or regex, which is a sequence of characters that forms a pattern. Regular expressions use these characters to search text and match specific patterns. Patterns define the parameters of a search. If a piece of text matches a given pattern, regex retrieves it for you. When analyzing logs in cloud environments, you can use regex to search through log data and extract any relevant information you need. For example, imagine you're given an authentication log with thousands of lines of events and need to find out if there's any failed SSH login attempts. You can use regex to specifically search for entries containing the SSH protocol and port number, along with any failed login attempts. Let's check out an example from a Google Cloud Logs Explorer search. Here's a regular expression query that matches SSH log entries. Let's examine each element. The first field, log name, identifies the log file the log entry belongs to. The equal sign and tilde is an operator that tells the application to query using regular expressions. For this example, it's Logs Explorer. Here's where the regex begins. The quotations are used in regex syntax to match a specific string. In this example, the quotations enclose the string SSH. The caret symbol is used in regex to match the beginning of a string. This means it will only find log entries that start with the string SSH. There are lots of different implementations of regex available in programming languages, applications, and tools. For example, with Google Cloud's Logs Explorer, you can use regular expressions to build queries to search through log entries. Searching with regular expressions has lots of advantages, like increased search performance compared to a regular text query. Because of its wide usage across different applications and programming languages, regex syntax can vary depending on the implementation. But what's important to know is the core set of features used to match patterns in text. Let's examine some regex fundamentals. Square brackets are used to match a range of characters. For example, the brackets here enclose the characters A, B, C. This means regex will match any of the characters defined in the brackets. Similar to a wildcard, periods are used to match any single character. In this example, D period G will substitute the period for any other character. It will return match results for texts like dig, dog, and Doug. \S matches any whitespace character like a space or tab. In this example, \S is between small and coffee. This means regex will only match for text that has a space or tab between the words small and coffee. \D matches any digit from 0 to 9. This example begins with a caret symbol, then \D. This will match a string that starts with a digit. The curly brackets contain the number of digits you want to match, which in this case is 5 digits. As you learn more about regular expressions, you'll be able to use these fundamentals in more complex ways to help you find the information you need. The first field rule provides the rule name, different city login. The meta section provides additional information about the rule. Under the meta section, there's events, which specify the UDM events that the rule needs to match on. In this case, the rule is looking for 3 things: user logins, users, and cities. The next section, match, specifies what must be met for the rule to match. In this case, it's user over 5M, which means the rule tries to identify a user who has been logged in within a 5-minute period and ignores all login events that exceed 5 minutes. Finally, the condition specifies the conditions that must be met for the rule to generate an alert. In this case, the rule is looking for UDM events that match what's defined in the match section and that have more than 1 city value. So, this rule will match if a user logs in from more than 1 city in a 5-minute period. If all conditions defined in this YARA-L rule are met, an alert will be generated. In the YARA-L rule you just examined, you might remember the use of UDM event types. Chronicle formats aggregated data using Unified Data Model, or UDM. UDM is a data model used to process and store data. UDM is kind of like a filing cabinet that's used to organize files, or in this case, aggregated log data. Just like a filing cabinet uses clear labeling to identify the contents of a file, UDM organizes data and attaches UDM fields to it to represent important data points. This makes data easier to search through and helps security professionals identify potential threats. With Chronicle, you can perform a UDM search. Through a UDM search, Chronicle searches security data that's been ingested and formatted in UDM. With time and practice, you can learn how to effectively use these querying tools throughout your career. And as an added bonus, you'll be able to save lots of time in log analysis by crafting effective queries. Fantastic work! You've completed your journey through detecting, responding, and recovering from cybersecurity attacks. Let's review what you learned. First, we explored the stages of an attack and discussed false positives. We explored Lockheed Martin's cyber kill chain and navigated each stage of an attack to better understand how advanced persistent threats work. We also reviewed false positives, including their causes and impact on security operations, and how to manage them. Then, we examined how cloud security professionals use security monitoring to monitor their environments. We also covered monitoring tools that are used to configure alerts and detect and respond to potential threats. Finally, we explored common examples of indicators of compromise found in cloud environments. We also discussed how threat hunting is used to uncover threats that evade detection tools. You're doing incredible work. When you're ready, join me in the next video. Hello, and welcome back. You're doing a great job so far. Remember, each new concept, process, and tool you learn helps you become a skilled cloud security professional and a contributor to your team. Previously, you learned about the details of incident detection. Now, let's shift our focus to incident response. In this section, we'll dive into the details of incident response process. We'll discuss the importance of preserving and handling evidence, documenting information, and how automation plays a crucial role in cloud security. And here's a few key topics we'll discuss. You'll go through the steps of the incident response process, including best practices with evidence handling. Then, you'll revisit incident management, where you'll learn more about the response process, including incident identification and team coordination. You'll also have the opportunity to explore how to use a cloud platform when responding to incidents. Then, you'll focus on documentation. You'll learn about alert response, including how to identify actionable alerts. Finally, you'll explore the power of automation, including how security platforms leverage automation in incident response processes. I'm here to help you along the way, and remember, you set the pace. Feel free to watch the videos as many times as you like, and review topics that are new to you. Let's begin our journey exploring how to respond to security incidents. I'll meet you in the next video. In this video, you'll learn the importance of preserving evidence in cybersecurity investigations. You'll also learn about evidence preservation, the types of digital evidence you may encounter, the chain of custody, best practices, and how Google Cloud tools can support you. You can think of yourself a bit like a detective on an investigation. Let's explore these exciting concepts together. Imagine the frustration of finding critical evidence of threat actor activity that is unusable due to improper handling or corruption. Evidence preservation is crucial. It allows cybersecurity professionals to ensure that impacted systems have integrity and that evidence is available for a follow-up investigation or to analyze how the incident occurred. That's why it's so important to preserve critical evidence in your work as a cybersecurity professional. You may encounter several types of digital evidence in cybersecurity incidents. Some examples include IP addresses, malware, logs, file hashes, and bad behavior. This type of evidence is also known as an indicator of compromise, or IOC for short. As the term suggests, this type of information indicates or provides clues that a system has been compromised. Each evidence type can provide valuable insights into the incident. As a cybersecurity professional, this digital evidence helps you understand what happened, how it happened, and who might be responsible. It's like piecing together a digital puzzle. Now that you know more about evidence, start to think about what to do with it. How do teams keep their systems from being compromised further while maintaining integrity of the evidence along the way? How do teams work to preserve evidence during an incident investigation lifecycle? As an incident investigation progresses and more people get involved in the process, it's important that everyone maintains the same level of care and integrity so the team can preserve the evidence. During an incident, it's important that everyone follows the same rules in the chain of custody. The chain of custody refers to the process of documenting and preserving evidence in a way that maintains its integrity and establishes a clear timeline for handling. An accurate chain of custody ensures your evidence is reliable and useful in any current or future investigation. To maintain the chain of custody, you should carefully and intentionally document each step of evidence handling, from collection to storage. And you should keep all documentation and evidence in a secure location. What should you think about when preserving evidence? There are 3 important things to consider. You need to capture and store data securely, aim to analyze evidence without altering it, and collaborate to maintain best practices. And the good news is that there are tools that can help. Google Cloud offers several tools and services to support your evidence preservation efforts. Some of these tools include cloud storage, which you can use for secure and resilient data storage, Google Backup and Disaster Recovery, which is helpful for storage and recovery, and Google Workspace, which supports documentation, collaboration, and secure file sharing. These tools can help you maintain the integrity of your digital evidence and streamline your investigation process. As a cybersecurity professional, incident investigations are a key part of the job. Preserving the integrity of evidence for cybersecurity incident investigations is a critical area of focus for you, your team, and your organization. You can use Google Cloud tools to support this process and help you successfully undertake your cybersecurity investigations. An IP address here, authentication attempts there, packets everywhere. It's all evidence in an incident investigation, and all that evidence needs to be preserved. In this video, you'll learn how to preserve evidence and what to consider during the process. Security teams must preserve evidence for accurate investigations and legal compliance. Preserved evidence must be undamaged, unaltered, and documented. Preserving evidence is a team effort. For it to be successful, all team members must recognize the value of evidence preservation and follow the chain of custody. The chain of custody is the process of keeping track of evidence as it progresses through an investigation. As part of the chain of custody, there are mandatory rules and processes. These rules and processes address issues such as unauthorized access and evidence tampering. When following the chain of custody, records and documentation are essential. Clear, accurate, and complete records of an incident investigation helps maintain the integrity of the evidence, ensuring that evidence is admissible and reliable. Organizations can then use that evidence to meet legal, insurance, or regulatory requirements. Proper documentation and collection of evidence helps organizations limit damage, prevent further losses, and comply with regulations. Now that you understand the importance of evidence preservation and how the chain of custody supports it, let's discuss some of the legal and ethical aspects to consider when handling evidence. As a cybersecurity professional, there are 4 key legal and ethical best practices. First, be aware of legal and ethical requirements. Second, balance the need for evidence with privacy rights. Third, collect only what's necessary. And fourth, destroy evidence when no longer needed. So far, we've covered 2 topics that are important throughout the incident investigation lifecycle: evidence preservation and legal and ethical considerations. Now, let's discuss the incident lifecycle and how evidence preservation fits in. Investigating incidents involves 3 phases: identification, incident control, and iterate improvement. In each of these phases, preserving evidence is one of the most important principles to focus on. The first phase, identification, is the phase that new cybersecurity professionals interact with the most. The goal of identification is to provide a foundation of evidence that the team can build from and not have to go back and repair. When identifying and defining the incident in the identification phase, you'll address questions like, what logs, alerts, or events have I observed that make up this incident? What detection rules were triggered? And how can I be sure this is a true incident and not a false positive? Now, let's discuss the unique challenges for evidence preservation when working in the cloud. Cloud resources, like virtual machines or containers, can be short-lived and automatically scaled. Because of this, you need to collect evidence promptly and create snapshots before any changes occur. Examples of this evidence include virtual machine logs or container operating system logs. When preserving evidence, it's crucial to enforce strict access control management and encryption policies for data at rest and in transit. Logs from any system or device in the cloud are critical. Logs help you preserve integrity and restrict access to collected evidence. Finally, let's discuss a couple tools and services in Google Cloud that you can use for evidence preservation. Cloud logging and cloud monitoring are often used for evidence collection and analysis. These tools help collect, store, and analyze log data from a wide range of sources, allowing you to identify and investigate security incidents. Cloud storage also supports evidence preservation. In cloud storage, identity access management provides appropriate access controls to secure evidence storage. Once evidence is stored, cloud cybersecurity professionals can use features like object versioning and storage bucket policies to ensure data integrity and secure access. Google Backup and Disaster Recovery are designed to create regular, incremental, and secure backups for everything you need in an investigation. The opportunity for evidence preservation is built right into the design of the tool. In this video, you learn the steps involved in preserving and documenting evidence and the legal and ethical considerations to be aware of. You also learned about the incident investigation lifecycle and the tools you can use along the way. Now you know how to handle evidence like a pro. How you respond to an incident will depend significantly on your preparedness. And along with good preparation, using security tools helps you respond to incidents quickly and effectively. In this video, we'll explore how to apply an incident response process. We'll also discuss incident cases and their lifecycle using Google Cloud for context. We'll focus on SOAR and SIM tools to streamline the incident response workflow. Let's start with some definitions. Security Orchestration Automation and Response, or SOAR, is a collection of applications, tools, and workflows that use automation to respond to security events. Security Information and Event Management, or SIM, is an application that collects and analyzes log data to monitor critical activities in an organization. Now that you know what the SOAR and SIM tools are, let's discuss how they're used and what a typical incident response process looks like. The incident response process has 3 phases. The first phase is identification. In this phase, you start an incident report because potential vulnerabilities and incidents have been identified. The SIM and SOAR tools are very helpful in this phase. They provide valuable information about alerts and events that have already happened, highlighting indicators that the asset may have been compromised. For example, SIM tools collect information from sources in your network. Then, the tools use a set of rules to detect and understand the information so it can be presented to security analysts. Now that the incident has been identified, it's time to move on to the second phase, incident control. There's a lot that happens in the second phase. The main idea is to control the incident's impact. First, you should coordinate with your team and then resolve the issue. While the incident is being controlled, you coordinate and communicate with the rest of the security operations team. You want to make sure that everyone understands what's been discovered and its impact. Next, you work to resolve the incident, limit ongoing damage, fix the underlying issues, and restore normal operations. Additionally, in the identification and incident control phases, the SOAR tools are useful for other aspects of incident response. SOAR programs coordinate communication between team members, assigns tasks, and tracks progress as teams communicate and work to resolve the incident. Now that the incident has been identified and controlled, it's time to iterate improvement. This is the phase in which you improve your security practices by learning from what caused this incident to occur. This enables your organization to improve processes, make plans for continuous improvement, and prevent a similar incident in the future. These steps are critical for security operation teams to evolve and adapt to the changing security landscape. Let's discuss some specific examples to learn more about the incident response process. It's not uncommon for an organization to receive numerous security alerts every day. If cloud cybersecurity teams were to investigate these alerts manually, it would take a lot of time and effort to connect information and determine if the team should act or not. When using a SOAR program like Google's Chronicle SOAR, workflows are automated and alerts are automatically analyzed, so there can be an appropriate response. For example, a SOAR program notifies your team about events connected to a phishing campaign. Your team now has the opportunity to get insight into the attack, learn from it, and mitigate similar attacks in the future. A second example is a distributed denial of service, or DDoS, attack. In a DDoS attack, your team uses SOAR to collaborate in real time to share information about impacted systems, attack patterns, and mitigation strategies. You use that information to coordinate with your team, assign tasks, and enable the team to quickly contain and mitigate the DDoS attack. In this video, you learned the processes and tools involved in responding to incidents. You also learned how a SOAR solution can be used during the response process. With these processes and tools at the ready, you'll be able to respond to events and help your team manage incident response. Imagine there's a security breach at your organization, and you're working on the incident response process. It's your responsibility to help your team better understand the severity, impact, and scope of the breach. How do you accomplish that task? In this video, we'll dive into incident identification, a critical part of any incident response process. You'll learn how to triage and prioritize alerts, collect information, assess potential impact, and learn the difference between true incidents and false positives. To start, let's consider incident identification. Incident identification involves recognizing potential security threats based on alerts, log data, and other indicators. The key to successful incident identification is to efficiently triage, prioritize, and assess alerts. That way, you can make sure you're addressing the most important incidents first. The initial steps in incident identification are to triage and prioritize alerts. Triaging alerts means categorizing and filtering the alerts based on specific criteria. Prioritizing alerts means you address the most critical issues first, ensuring a timely response to potential threats. When you prioritize alerts, you need to consider questions that help you focus on severity, potential impact, and urgency. For example, a question to help you consider severity might be, how serious is the potential security threat? Next, to consider potential impact, you might ask, what are potential consequences of the incident? And finally, to consider urgency, you might ask, how quickly does the incident need to be addressed? Once you've triaged and prioritized alerts, you get ready to assess the alert by gathering information and evidence related to the potential incident. This might include reviewing logs, analyzing network traffic, or examining user activity. Once you collect this information, you can assess the potential impact and scope of the incident. The assess step in incident identification will help you determine the right course of action for addressing the incident. It's important to keep in mind that not all alerts indicate a real security issue. Sometimes, harmless events like network disruptions or misconfigurations can trigger false alarms. You need to be aware of the difference between true incidents and false positives. To differentiate true incidents from false positives, you need to examine the data and confirm the type of event. Let's discuss how to tell the difference. When distinguishing between the two, you can address the information available with analysis and verification. First is analysis. During analysis, you'll examine the available evidence and context, review for patterns and relationships between data points, and assess whether the alert represents a real security threat. If you discover multiple related alerts and indicators of compromise, your analysis most likely indicates a true incident. Second is verification. During verification, you'll double-check the affected systems for signs of compromise, like unauthorized access or changes to files. If you find evidence of intrusion, the verification likely indicates a true incident. If you don't find evidence of intrusion, the alert might be a false positive. Here's a pro tip about analysis and verification in relation to false positives. Sometimes an incident might be flagged as a false positive and discarded based on the team's current understanding, only to be revealed as a true positive once more information is available. You and your team will always be learning, even in an active investigation. Now you can go into an investigation with confidence. You know how to identify and prioritize alerts to help define the impact and scope of the incident. You also know how to differentiate between a true incident and a false positive to help guide your team down the right path. Ready to explore some key concepts that will help you in your journey as a cloud security professional? In this video, you'll learn more about effective coordination and communication in incident response, and how these practices will help you keep cloud data safe. What exactly is an incident response process? It's a series of events in cloud security operations in which everyone knows their role and responsibilities and does their part to make the response process a success. An effective incident response process is essential because it helps organizations reduce potential harm and keep their operations running smoothly. In incident response, you prepare for potential incidents, detect and analyze them when they occur, and take appropriate actions to minimize the damage. During an incident response process, effective coordination often determines if the response is successful or not. When you've got effective coordination, you and your team work towards the following goals. You manage resources so that all systems and people are communicating effectively. You streamline communication so that everyone knows where they are in the incident response process and what they are responsible for. And you ensure a timely response to security incidents so that everyone knows what's happening now and what to do next. Effective coordination is all about bringing everyone together to work in harmony. That means everyone knows what to do and how to do it. So, what are the must-have tasks for incident coordination? First, you need to set clear goals and objectives. Next, you need to define roles and responsibilities, ensuring everyone knows what to do. After that, you establish communication channels, ensuring everyone can stay connected and share information when needed. Then, you track progress to ensure the team is moving forward. And last but not least, it's important to keep stakeholders informed. This is vital for maintaining trust and transparency throughout the process. When all these tasks come together, you'll have a high-performance team that's working together and ready to tackle security incidents. To effectively address security incidents, you also need the right team members on your security operations teams. Let's discuss some of those roles. The incident manager oversees the entire process. The lead investigator implements response measures and analyzes incident documentation and evidence to determine what caused the incident. The communication lead clearly communicates the progress and resolution of security incidents externally and internally. And finally, the technical specialists are experts in network security, malware analysis, or cloud infrastructure. These team members make sure the incident is understood and resolved. All of these roles on the security operations team work together to protect your organization's data and ensure that security incidents are handled effectively and efficiently. And to get that done, communication is key. Clear, effective, and concise communication is essential to incident coordination. High-quality communication ensures everyone understands their roles and responsibilities and keeps stakeholders informed. In incident coordination, high-quality communication uses standardized terminology, provides regular updates, and leverages secure communication channels. These practices help avoid misunderstandings, keep everyone focused on the incident, and lead to more successful incident responses. You successfully explored coordination and communication in cloud security incident identification. By implementing an effective incident response process and focusing on strong coordination and communication, you can help keep your organization's data on Google Cloud safe and secure. So go out there and use the power of coordination and communication to solve the security incidents that come your way. Documentation is critical to the quality of cloud security for any organization. In a security context, key documentation includes precise and accurate incident reports, evidence logs, and action plans. These documents are foundational to the cybersecurity integrity of organizations across all industries. In this video, you'll learn the fundamentals of documentation so you can be prepared for your role as a security professional. Documentation provides insight into what has happened in the past, direction on what to do now, and what should be done in the future. Well-documented incidents serve as teaching tools for future events that enable you and your team to improve processes, playbooks, and security posture to adapt to increasing threats. There are a few types of security documentation you'll learn more about shortly. These include incident reports, evidence logs, action plans, playbooks, and logbooks. Security operations teams commonly record evidence in these documents. As a security professional, you'll find common types of information in the documents you encounter. Similar types of information might include system events, timestamps, conversations, and changes observed during the incident investigation. And in high-quality documentation, the information is accurate, clear, consistent, and timely. Documentation is also essential for preserving evidence for the purposes of legal investigation. Information like file access and integrity, chain of custody, and actions taken are all critical to maintaining the integrity of the evidence. In the example of digital forensics, files are very easy to change. To maintain the integrity of files so they can be used in legal proceedings, evidence handlers must carefully document the details of the file, including how it was created, how it was secured, when it was transferred to law enforcement, and more. Preservation of evidence is also critical when incident documentation includes sensitive information like system vulnerabilities, recent security breaches, and users with elevated privileges. All of your documented evidence needs to be preserved. The quality and integrity of your documentation will determine whether or not it can be used in the incident investigation. As a security professional, Google Cloud is a useful tool for preserving evidence. Google Cloud provides secure evidence storage solutions that depend on proper authorization and access privileges. BigQuery and Chronicle SIEM use secure identity and access management to ensure evidence preservation. Whether they're large datasets that need to be analyzed or logs that need to be aggregated and correlated, that evidence is preserved within those platforms. In addition to preserving documentation, teams use documentation to help guide their operations. A playbook is a manual that provides details about any operational action. By using secured services and tools that work alongside the well-defined procedures and processes in playbooks, security teams improve the likelihood for success when responding to incidents. Now, let's explore those tools in an example. Imagine you're investigating unauthorized access to a Google Cloud storage bucket. First, you create an incident report with the initial events, their timestamps, and all impacted systems. Next, you document the evidence, including logs from cloud logging, and store them securely. Finally, you put a plan into action to mitigate the incident's impact, ensuring that your team has access to your findings. Throughout the investigation, you communicate with your team along the way. By applying this best practice, you ensure that everyone is aware of what's happening and can act quickly. By understanding and applying the fundamentals of documentation in an incident investigation and using tools to help secure and preserve your documentation, you will set your team up for success. In cloud security, recording your findings is just as important as actually responding to an issue or incident. When you document and communicate your findings, you help others understand the security situation. In this video, you'll learn more about documentation fundamentals, the important elements of documents, and useful information to include. You'll also consider a few tips to help you write clear and impactful documents. Impactful documentation plays a huge role in incident management and investigation. Documentation helps to improve communication with your team, encourages accurate decision-making, and supports the continuous improvement of your organization. To have impact, documentation must be accurate, clear, consistent, and timely. Documentation with these qualities is foundational to the incident management process. Although documentation can take many forms, there are specific elements that help security operation teams to respond to incidents. Those elements are incident summaries, timelines, technical findings, actions taken, lessons learned, and recommendations for improvement. Not every document has all of these elements, but security operations teams do consider all of these elements during the incident response and management process. Now, let's review each element and uncover why they're a part of the incident response process. The incident summary is where you include a quick overview of the incident, including information about how the incident occurred, its severity, and any other relevant context. The incident summary exists so a security operations professional can quickly learn the highlights of an incident and focus on what's important. After the summary in a document, there's typically a section with details about the evidence that prompted the incident response process. This detailed information provides context and understanding of why the incident occurred. This information includes a timeline of events and any technical findings. Examples of technical findings include information such as misconfigurations of cloud settings, evidence of impact, like security logs, system logs, or artifacts, and evidence of a security breach, also known as indicators of compromise. After the timeline and technical findings have been presented, the next documentation element typically describes the team's actions. This is an opportunity for the team to document what they did to mitigate the damage caused by the incident and provide lessons learned for the future. When describing the team's actions, predefined processes or automated responses, also known as playbooks, are included in the document. Incident documentation typically ends with lessons learned from the security incident and what should be done so it doesn't happen again. To document lessons learned, the team would have reviewed the incident to understand and record what went well and what caused the incident. Then, based on their review, the team suggests actions to take that will lead to future improvements. Now that you understand documentation elements, here are some tips to keep in mind when you work on incident response documentation. You should provide actionable information. To do that, use clear, concise, and objective language. By writing objectively and using unbiased information, you can ensure the documentation is an accurate resource for the team. Another tip is to maintain a consistent format and structure across all documents. This ensures the documents are easier for all team members to understand. When working through an incident, it's important to encourage collaboration and communication with your team. You should use consistent language, set clear expectations, and communicate in secure collaboration spaces. And finally, you need to store information in a secure location. This ensures the integrity of your documentation. With these documentation elements and best practices, you'll be well on your way to creating comprehensive and impactful documentation for your security operations incident investigations. How do you know when you need to respond to a potential security incident? In this video, we'll explore how cloud security professionals identify actionable alerts. The incident response process has 3 steps. Actionable alerts start this process in the identification step. In this step, you begin to understand what event has occurred. Keep in mind that events happen whenever there's an observed change in normal operations. Alerts are notifications of the change. Actionable alerts can turn into incidents based on what happens in the event. As a refresher, an incident is a violation or imminent threat of violation of computer security policies, acceptable use policies, or standard security practices. As a cybersecurity professional, it's important to be aware that an incident is something that negatively impacts an organization's normal operations and requires a response. Consider this scenario. Failed login events in cloud identity software happen frequently and are a normal occurrence, so they may not trigger alerts. There are also abnormal failed login events that do trigger alerts because someone tries logging in multiple times. For example, this may happen after returning from a vacation. This is an alert that you note, but it requires no action. One day, you're alerted that a user has a large number of failed login attempts in a short amount of time during their workday from an unfamiliar IP address. This has become an actionable alert that requires you to respond by initiating the incident response process. To help with incident response, security tools provide quick insight into actionable alerts. These tools scan for vulnerabilities and emerging threats and alert accordingly. For example, say you're alerted when there's a high volume of traffic on the network. It becomes an actionable alert or incident when the traffic is coming from protected data storage from an unauthorized user. You know this is an incident because there is a trigger for the protected data storage and another trigger for unauthorized users. Metrics offer great insight into the happenings of a cloud environment. They can be used to measure the what and how of an event related to an alert, enabling you to quickly identify the issue. For example, say you need to know if there is a high CPU usage outside of regular business hours. You can use metrics to identify the what of the alert, which is the CPU usage, and the how of the alert, which is high activity outside of business hours. Let's introduce 3 Google Cloud tools and services to help with managing events, threat detection, and alerts. First, the Security Command Center. The Security Command Center is a security posture and risk management platform that gives insight into configuration vulnerabilities and incoming threats. Second, Cloud Logging. Cloud Logging is a Google Cloud managed platform that allows you to store, search, analyze, monitor, and alert on logging data and events. Alerts can be ingested from many cloud platform vendors and also from on-premises resources. Third, Chronicle SIEM. Chronicle SIEM is a part of the bigger Chronicle security operations. Chronicle SIEM collects security data and helps you identify the highest priority threats. While security tools, including Google Cloud tools, are essential to any successful security operation, incident response is still a process that's initiated by security professionals. When starting an incident response process, it's important to first capture the event or alert. This requires you to think about the information, its impact, where it came from, and how it affects normal operations. You must document and investigate events early, even if you're not sure they're actionable. This will help you communicate clearly with your team and start an incident response process if needed. This video covered events and alerts, their place in incident response, and how security professionals assess and document findings. To be a thoughtful, action-oriented professional, you need to understand the tools and the information they provide, and how to interpret events and alerts. And by considering each alert's origin, purpose, and impact, you'll have the information you need to decide what actions to take. Addressing security incidents can be complex and challenging in cloud environments. In addition, attacks can happen quickly, while incident investigation takes time. This is where security orchestration, automation, response platforms, and playbooks can help. Let's dive into these concepts. For example, say you're working with a group of expert musicians, and you want to create a beautiful symphony. you need to coordinate the musicians playing each instrument to ensure everyone is playing in harmony. Security orchestration is similar because your security team members are like musicians. And instead of creating a symphony, you're managing an incident response. Orchestration helps you to streamline incident response efforts by coordinating specialized security tools, tasks, and processes. This coordination helps you save time, improve efficiency, and reduce the chances of human error. To help with orchestration, you can use Chronicle's SOAR, or SOAR for short. Chronicle SOAR is Google Cloud's security orchestration, automation, and response platform. Similar to other SOAR platforms, Chronicle SOAR is a collection of applications, tools, and workflows that use automation to respond to security events. To harness the power of these tools, SOAR platforms work with a playbook, which is a manual that provides details about any operational action. Think of playbooks like a musical score that everyone follows to play in harmony. In incident response, playbooks provide predefined procedures that guide security teams through investigating and resolving incidents. Playbooks have defined triggers, which cause security teams to take specific actions and make decisions. This enables fast incident response, helping free up time for security teams. So why should you use playbooks as a security professional? Playbooks have several benefits. They help you automate repetitive tasks to save time and improve efficiency, and ensure consistency by requiring that teams consistently take all necessary steps. Playbooks also help to improve collaboration between security teams. They provide a common framework for communication and action. Playbooks also help security teams reduce risk by automating tasks prone to human error. Finally, playbooks improve compliance by ensuring that security teams follow all necessary procedures. Even better, you can build playbooks into your SOAR tool. In Chronicle SOAR, playbooks can be created, customized, and deployed to automate incident response workflows. Implementing a playbook helps security professionals effectively manage incidents. Chronicle playbooks begin with a trigger. The trigger is what initializes the playbook. It can be based on an alert from a security solution like an endpoint detection and response platform. Then there's the action. The action conducts an operation. For example, for a phishing incident, you might want to define an action like blocking the suspicious IP address that sent the phishing email. Lastly, there's the flow. The flow determines the progress of the playbook. It defines decision-making substeps in the form of conditional statements. For example, imagine your organization receives an alert about a possible phishing email. You can use a playbook in Chronicle SOAR that automates each manual step involved in the incident response process of a phishing alert. This response process includes identifying and blocking malicious IP addresses, alerting the affected users, and resetting compromised passwords. Instead of having to toggle between different security platforms to perform an action, you simply let the playbook do its work. Here is an example of a phishing playbook in Chronicle's Playbook Designer. It's a simple flowchart with steps. Each step defines the triggers, actions, and the flow of the playbook. All these components work together to integrate and orchestrate tools used by the security operations teams. Platforms like Chronicle SOAR and their playbooks can help you automate and coordinate systems during an incident response process, improving efficiency, aligning goals, and reducing the likelihood of human error. Keep in mind that SOAR playbooks for incident response are not 100% automated. Security analysts still need to customize and monitor playbooks to ensure they follow the correct process and that they're effective in incident response. In addition, security analysts may need to take manual actions that are not automated, such as investigating alerts or communicating with stakeholders. When making a SOAR playbook, keep in mind a few best practices. First, make a plan. Prioritize tasks and processes in playbooks that are prone to human error, take a long time to accomplish, and have high impact. Second, build with strategy. Make sure playbooks follow processes that align with your organization's goals and industry best standards. And third, iterate. Learn from past incidents and continuously refine and adapt playbooks to ensure that they stay effective. As a security analyst, you can use automation and playbooks to simplify tasks and improve workflows to help you and your team. Platforms like Chronicle SOAR are a big help in incident response, so consider SOAR when you need to improve response efficiency and avoid errors.
My name is Fatima, and I'm a tech lead manager on Google's detection and response team. My role at Google requires me to stay up to date with the cybersecurity threat landscape and make decisions about what we need to build so we're in a good position to detect any cyber attacks against Google or Alphabet. It took me a while actually to get to cybersecurity and to understand that was the place I wanted to go. When I was in high school, I got the opportunity to work in a law firm, really making copies. Like my job was, I was called a copy kid because I was a kid who made copies. And at one point, I just started working with their IT systems and just trying to fix things here and there when things would break. We would have people who would lose important work documents or really cherish family photos. So I was exposed to that part of cybersecurity, the very human part, right? That it's not just a nuisance that somebody experiences on their computer, but it can really affect them in a different way. At that point in my life, I decided that cybersecurity was something that I wanted to pursue professionally. I wanted to fight the bad guys on the internet. Cybersecurity is like a performance. It's something that you prepare for a long time. And then one day it's time to put on the show. You have to be ready. You have to be ready to perform, and you have to be ready to perform at your best. For somebody who's just starting a career in cybersecurity, I would say learn how to code. Coding is extremely important. And learn the basics. Learn about networks. Learn about operating systems. Learn about web vulnerabilities. So learn all the fundamentals really well. And then after that, decide really what you want to focus on. What I've learned in my career is that nobody has a magic recipe for success. Everybody's just trying their best, and they're trying to figure it out in the moment. You might think that this other person just knows better and they have some magical skill that makes them more fit to do this type of work. I'm going to tell you that doesn't exist. The only thing that exists is really hard work and learning and developing your skill sets, and eventually you get better and you kind of move on to that next phase of your career or your life. But nobody has that kind of magical recipe and knows all the answers. Everybody's really just trying their best.
Congratulations! You've completed this section. You now have the foundation you need to successfully respond to a security incident. You'll also be able to share your newfound understanding with future employers and other security operations professionals. You've learned a lot. Let's do a quick review. First, you learned about the incident response process and about preserving and handling evidence like a pro. Next, you learned about the Chronicle SOAR and Chronicle SIM platforms that security teams use during incident response process and how they provide oversight and access to multiple tools and information at the same time. Next, you learned about attributes of high-quality documentation, what great documentation should look like, and how to address documentation during an incident. After all, an incident investigation is only as good as its documentation. Finally, you learned about the tools of the trade and how to leverage automation to work smarter, not harder. You also learned about playbooks and how they enable you to focus on the important aspects of incident response process. Continue moving forward on your learning journey and keep building your foundational understanding of the incident response process. Great work! Hi, and welcome back. Coming up, you'll learn all about the importance of recovery after a security incident. Then, you'll be introduced to critical aspects of business continuity and disaster recovery, or BCDR, including cloud BCDR tools used to maintain business continuity. Next, you'll learn how to measure recovery plans for success using key recovery metrics. Finally, you'll examine the relationship between disaster recovery and business continuity, best practices to apply, responsibilities of security professionals working on recovery, and stakeholders involved in recovery efforts. As a security professional, learning the fundamentals of recovering from a security disaster will help you effectively communicate with other professionals and support your team. So, are you ready to get started? Meet you in the next video. How do you ensure that business operations continue to run when disaster happens? In this video, we'll explore a critical skill for any cloud security professional, executing a recovery plan. We'll also provide you with practical examples, so you know what to expect when a plan is implemented. Let's get started. A recovery plan is like a roadmap. It's a detailed guide that steers you on the path to restore operations in case of a disaster. This roadmap isn't just about returning to where you were before the disaster. It's about leveraging the experience to learn, grow, and improve. A recovery plan isn't a static document. Instead, it evolves over time as you learn from past incidents and adapt to new threats. As a security professional, you'll contribute to this growth and help your organization become more resilient with each challenge. As a security professional, you'll likely be involved in recovery efforts. But it won't just be you. Every person in an organization plays a role in the recovery process. Responsibilities during the execution of a recovery plan include assessing the situation, supporting the decision-making processes, communicating with stakeholders, and running specific recovery procedures. Now, let's apply these concepts to some scenarios. Imagine ransomware gains access to your network. Operations come to a standstill, and critical data is lost. This is a difficult situation, but with a well-executed recovery plan, you and your team have options on how to respond. The recovery plan becomes your roadmap. It guides you to quarantine parts of the system that have been infected, eliminate the ransomware, restore the data for backups, get the system back online, and prevent significant downtime while resolving the issue that allowed it to happen. And remember, the recovery process isn't over when the system is back up. You need to learn from what happened. Take the opportunity to analyze what went wrong, why it went wrong, and how you can prevent it in the future. In the event of an active cyber attack, the recovery plan can be your defense playbook. The recovery plan, serving as a playbook, can help you isolate affected systems, remove the threat, and then restore the systems to their previous state. In this video, we explored the crucial role of recovery plans and their impact on systems, teams, and organizations. Every plan, when put into action, is a chance to respond to an incident, learn from what happened, and help prevent a disaster. Not everything goes according to plan, but that's okay. With each challenge, there are opportunities to learn and improve. In this video, we'll discuss a critical area that affects all of us working in Google Cloud environments, the recovery process. To keep systems running smoothly, you need to be prepared for the unexpected. Whether it's a cyber attack, natural disaster, or internal error, you'll need to be able to recover quickly and efficiently. How well security operations teams can recover from a security incident can mean the difference between a minor inconvenience and a major catastrophe. So, how do you restore systems to their normal operations? If you need to get your systems back up and running on Google Cloud, there are a range of helpful tools available. With services like Google Cloud Backup and Google Cloud Disaster Recovery, you can quickly restore your data and applications. Plus, Google Cloud Storage and Persistent Disk keep your data safe and secure, so you won't have to worry about losing any of your data. After restoring your system, it's important to ensure that all components are functioning properly. Platforms like Google Cloud Operations Suite can help. The suite allows you to keep track of system performance, set up alerts, and prevent future issues. It's an excellent tool for maintaining your system's functionality and for confirming functionality after restoring your system. As a security professional, knowing how to manage recovery effectively in Google Cloud will help you in your professional development. As you develop skills in disaster recovery, you can help build trust with your team and the broader organization by ensuring business continuity in the face of disruption. Business continuity, or BC, is an organization's ability to maintain their everyday productivity by establishing a risk disaster recovery plan. When you support business continuity in the context of cloud security, keep in mind that the cloud environment is dynamic and continuously evolving. So over time, you'll find new tools and services to help enhance your recovery processes. Your knowledge of the latest tools and desire to continuously learn is a big advantage in the recovery process for your organization. So stay curious. As a cloud security professional, you need to understand the importance of the recovery process, the tools you can use, and how to best support your organization when restoring systems. Yet, in the fast-paced world of cloud operations, your duties may extend beyond just restoring services. You also need to guarantee data integrity, preserve users' trust, and face any obstacles with confidence. By consistently exploring, learning, and retaining knowledge, you can become more valuable in this ever-changing field. And your company and coworkers will certainly appreciate your contributions. Knowing how to respond in a crisis is a valuable skill in cloud security. In this video, we'll explore an area that is critically important for any cloud-based operation: business continuity and disaster recovery, or BCDR tools. Let's get started. So, what's BCDR all about? Simply put, business continuity and disaster recovery are like a safety net. They're critical in security operations because they ensure that when disaster strikes, business operations are active and data remains safe and accessible. There's a variety of BCDR tools available to security operations teams, each with its unique purpose. These tools can range from BCDR plan builders and backup and restore utilities to sophisticated software that handles data center failovers. And all these BCDR tools all share a common goal: to protect your business from the negative effects of a disaster. These tools can also help you make and execute a plan to restore your systems and get data back online. They ensure you can continue normal operations and continue serving your users without any interruption. So, no matter the size or scope of the problem, there's a BCDR tool available to help. Now, let's explore BCDR in Google Cloud. Google Cloud offers BCDR tools designed specifically for its cloud environment to assist with regular backup and recovery operations. As a security professional, Google Cloud BCDR tools help with key aspects of business continuity and disaster recovery. For example, you can test and establish backup and recovery processes, test data management, and verify a documented backup plan. Here's an example. Imagine your team can't mitigate a ransomware attack in time. Multiple systems are affected, so you need to utilize backup and disaster recovery tools to restore normal operations. Before you begin the process of restoring the affected systems, you need to prioritize the restoration of critical business systems. First, you isolate the affected system, like a server or virtual machine, and terminate the ransomware task. Then, you restore the system to the most recent recovery point from the last unaffected backup. By using cloud-based BCDR tools, your security operations team can be confident that completely different infrastructure is in use, rather than a compromised network. Once the new system is running, the security team connects the recovered system to the network so that end users can return to work and operations can continue. So remember, these BCDR tools are not just pieces of software. They're what you can use to ensure your business continues to run smoothly and efficiently during disaster recovery. Hello, and welcome to the next step in your cloud security journey. In this video, we'll explore the critical world of business continuity and disaster recovery, or BCDR for short, within Google Cloud. BCDR ensures your operations continue despite unexpected disasters or threats. Google Cloud provides lots of tools that integrate seamlessly with BCDR planning and execution, making protecting your organization's data easier. That way, you can keep your services running after a disaster. Let's examine a BCDR tool in Google Cloud. Google Cloud Backup and DR is a backup and disaster recovery solution that enables organizations to quickly recover data so that they can continue running critical business operations. To get started with Google Cloud Backup and DR, you'll need to first create a backup plan. You can use the backup plan to define the parameters of your backup. For example, how often to back up your data, how long to retain the backups, and where and how to replicate the backups. Once you've created your backup plan, you can restore your data whenever you need to with just a couple clicks. For example, if your organization is targeted by ransomware, employees might not be able to access files encrypted by the ransomware. Business operations will be negatively affected, and employees won't be able to do work until they can access the data. After the security team successfully contains the ransomware, you use the backup plan to quickly find and deploy a backup that has not been infected with ransomware. This allows you to quickly recover your data and get operations back to normal. We've reviewed backup plans, but what about disaster recovery plans? Let's examine what you should consider when creating a disaster recovery plan, or DRP, within Google Cloud. For example, it's important to consider how backups will be set up through replication, what your measures of success during a recovery are, and what happens if there's a failover. You'll also need to test the plan and have maintenance strategies. And lastly, you should consider the cost implications of a disaster. This includes the cost of downtime if your organization is unable to operate, and the cost of restoring data. Let's discuss these considerations in more detail. First is replication, or the process of continuously creating copies of data to multiple locations to support availability. Replication is vital to any disaster recovery plan because it helps ensure that data can be quickly restored. While working in the cloud, it's important to consider replication options that utilize storage in different regions of the world. For example, OnVault can be used to safely store backup data from virtual machines. Another option is StreamSnap, which is used for data mirroring. Data mirroring creates exact copies of data in remote locations. This provides opportunities for replication across multiple regions to improve data availability during a disaster. Now that you've learned how data is backed up, let's discuss measures of success. These include how often data backups happen and how quickly you'll need to get business operations back to normal when carrying out a disaster recovery plan. In a disaster recovery plan, you need to decide how much data can be lost and how long systems can be down. Both are critical measurements of success for a disaster recovery plan. Google Cloud's compute, storage, networking, and software services can support your team in making these objectives possible. Next, let's examine failover, which helps protect systems from failure. For failover scenarios, deploying Compute Engine and managed instance groups can provide automatic failover in the event of an instance or zone failure. For example, imagine your organization uses Google Cloud to run a critical application on Compute Engine. The application is deployed in a single zone. Keep in mind that a failure in one zone affects all the resources in that zone. So, if the organization wants to improve the critical application's availability, they need to add failover. The organization can achieve improved application availability by creating a managed instance group with 2 instances located in different zones. The application can then be configured to run on both instances. If one instance fails, the other instance will continue to run the application. As always, testing your disaster recovery plan is crucial. In the previous example, the organization can also set up regular disaster recovery testing to verify if the failover works as intended. As a security professional, you can test your plan periodically and conduct tests to simulate a computer instance failure. If the testing fails, you are alerted and can investigate and address the issue. Conducting regular disaster recovery testing will ensure your plan is effective and can help you identify improvement areas. Finally, here's a pro tip. Maintaining your disaster recovery plan is key. Your company's cloud presence will change over time, and your disaster plan needs to change accordingly. Your plan needs regular maintenance to stay current. Now that you know more about setting up and maintaining a backup and disaster recovery plan in the cloud, you're well prepared to help your organization navigate security disasters with confidence. In this video, we'll explore one of the most critical aspects of a security professional's role: disaster recovery. Recovery is more than just a backup plan. It works alongside prevention efforts. But when prevention doesn't work and disaster occurs, a speedy and efficient recovery is essential to keep business operations running smoothly. Recovery is a team effort. All members of a security team must know how they contribute to recovery processes. They also must maintain awareness of business continuity standards and timelines. Business continuity ensures that your company's operations are uninterrupted at all times. And when a disaster strikes, recovery is a corrective measure that can get your company back on track. There are several recovery options to use in the event of a disaster, but the recovery option you choose will depend on the type of security disaster you encounter. To help you make the right call, let's review the different types of recovery options. Backup restoration is a common practice and recovery option security professionals use to recreate a system from its most recent stable backup. Another recovery option is redundancy, which is the practice of having multiple copies of data in different locations to avoid a single point of failure. Copying data across multiple zones has a lot of benefits. It improves the availability of cloud resources and prevents potential disruptions in the event of a failure or disaster. For example, if System A fails, a redundancy mechanism can automatically start, allowing System A1 to take over to minimize downtime and maintain availability. Cloud providers like Google Cloud provide backup and restore recovery options and replication for databases, giving security professionals a quick way to recover lost data. To support backup and restore efforts, cloud providers offer failover and redundancy services. These services manage heavy traffic loads using load balancers. Load balancers improve the performance of services or applications by distributing network traffic across resources. In the context of recovery, if a server fails or suddenly becomes unavailable, load balancers identify this change in server performance. Then, load balancers work to provide availability by evenly distributing traffic across the other servers. Another recovery option is warm standby. With this strategy, a duplicate system is always running in the cloud, but on a much smaller scale. The duplication is fully configured and operational, so in case of a disaster, security professionals can scale up the system to run quickly. Now that you're familiar with a few recovery options, let's discuss how security professionals use these recovery options on the job. Disaster recovery strategies are included in a disaster recovery plan, or DRP for short. A DRP is like a to-do list that includes the details you need when a security disaster occurs. A DRP also includes measures of success. The success of a recovery effort is not only when a business returns to normal operations, but how quickly the recovery happens, and what data is lost when the system is down. These measures of success are known as Recovery Point Objectives, or RPOs, and Recovery Time Objectives, or RTOs. A Recovery Point Objective, RPO, is the maximum acceptable length of time during which data might be lost from an application due to a major incident. A Recovery Point Objective defines how much data you can afford to lose if a system goes down. As a security professional, an RPO informs how often you back up your systems and how you use redundancy. RPO also typically involves a data backup policy. For example, during the event of a failure, a financial organization like a bank needs a low RPO. In this context, a low RPO ensures that the bank can restore its data as close as possible to the point of failure. Not only does this minimize potential data loss, it provides the bank's customers with access to their information. However, a small local bookstore that uses manual data entry might not need a low RPO, because losing a few hours of their data during a failure might not significantly affect their business operations. Recovery Time Objective, RTO, is the target time allowed for the recovery of a service in the event of a disaster. An organization's RTO is how long they can afford to wait until data is restored from a backup, or how long a system can be down before it's back up and running after a failure. For example, if an organization specifies their RTO as 1 to 2 business days, this means they can accept 1 to 2 business days of downtime in the event of a disaster. In this video, we explored recovery and discussed how recovery strategies like backups and redundancy can be applied and measured using RPO and RTO. Keep in mind that when prevention isn't enough, recovery steps can help you get your organization up and running, even after a security disaster. Organizations often create disaster preparedness plans. By planning in advance, organizations can better navigate challenges and unexpected events. Security professionals also plan for unexpected events. In this video, we'll explore disaster recovery planning, also known as DRP. When all else fails, a well-constructed DRP ensures that business operations can continue. It's the survival kit that keeps an organization going during unexpected disruptions. Let's unpack the kit and explore each of the 4 key components of a disaster recovery plan. The first component of a DRP is roles and responsibilities. Having an established list of roles and responsibilities ensures your team knows how to communicate and collaborate with other employees, vendors, and customers. The second component of a disaster recovery plan is critical systems, applications, data, and resources. The DRP should include documentation of which systems, applications, data, and other resources are most critical for business continuity, and how to bring them back online when they're down. The third DRP component is to make plans for testing and optimization. It's important that your team continues to test and update its strategy to address ever-evolving threats and business needs. The fourth DRP component is a risk assessment. A risk assessment considers strategies for potential hazards and the necessary resources to resume business operations. The assessment should include clearly defined recovery point objectives and recovery time objectives. Remember, a recovery point objective, or RPO, is the point in time to which data must be recovered after a disruption occurs. For example, imagine you're working on a crucial project that depends on a constant stream of live data. Suddenly, without warning, your system crashes. The clock is ticking, and each passing second means more data is lost. How much data can be lost before it starts to impact the company? 30 seconds worth of data, 30 minutes, or 3 hours? These are questions RPOs are meant to answer. A recovery time objective, or RTO, is the maximum acceptable amount of time allowed for the recovery of a service in the event of a disaster. When setting an RTO, security professionals need to know the maximum amount of time a system can be offline. To figure out the answer, they'll ask questions like, how long can business operations dependent on a specific system be down? And how quickly does the system need to be operational before the impact becomes severe? For example, imagine you work for a global financial technology company that provides financial services through a cloud-based app. Their services are accessible to millions of customers around the world at any time of day. One day, the company is targeted for a distributed denial of service attack. The attack overwhelms the company's servers and systems, causing the app to go offline. The outage causes severe service disruptions, impacting customers all over the world in an instant. Unfortunately, your team's efforts to mitigate and resolve the attack are not successful. Your defenses are overwhelmed, the system stays down, and the app remains unreachable. Your last line of defense is the disaster recovery plan. So the team activates the cloud-hosted DRP, which outlines the steps the team needs to follow to recover critical cloud resources. Your team's designated personnel, including security engineers and stakeholders, access the DRP. Now, everyone on the team knows their roles and responsibilities and collaborates effectively to get servers and systems back online. By leveraging the scalability and distribution of the cloud, your team is able to redirect and recreate network traffic, computing, and data from failovers and backups. All of the redirection and restoration efforts are then guided by predefined RTOs and RPOs, ensuring that downtime and data loss are within acceptable limits. Critical systems then come back online, and the bank's customers are able to access the app once again. As you might imagine, this recovery process is not an everyday action. It's the safety net when everything else fails. Now that you've explored the components of a disaster recovery plan and worked through a security scenario, you understand the process to support recovery when the unexpected happens. Ready to learn more about a vital part of cloud security? In this video, we'll discuss the differences between business continuity and disaster recovery, also known as BCDR. We'll also discuss how to build BCDR plans and examine how they're used in Google Cloud. Business continuity, or BC, is an organization's ability to maintain their everyday productivity by establishing a risk disaster recovery plan. Disaster recovery, or DR, is a strategic and systematic approach to recovering essential infrastructure and systems when a disaster happens. Business continuity and disaster recovery work towards the same goal: ensuring your organization is impacted as little as possible during a disaster or event. Security professionals often refer to these two concepts together as BCDR. Let's explore disaster recovery and business continuity plans in more detail. When building either of these plans, there are 3 considerations to keep in mind. First, both plans start with a risk assessment. A risk assessment helps you and your team identify threats and evaluate their impact. This can also help you thoroughly document and set up a priority list. Next, a business impact analysis is necessary for you and your team to identify which critical operations need to be prioritized when a disaster happens. And finally, organizations use strategic planning to outline various disaster scenarios so they can focus their efforts on minimizing disruption, recovering lost information, and restoring regular business operations as soon as possible. All 3 of these considerations are necessary for teams to create business continuity and disaster recovery plans that help ensure successful outcomes. Both plans consider what systems need to be prioritized and how to address prioritized systems during a disaster. But each plan considers these factors differently. Every organization is unique, so each organization's goals and plans for disaster recovery and business continuity must be tailored to their needs. Let's explore some of the tools and features in Google Cloud that a security team can use to implement both BC and DR plans. An important part of Google Cloud's BC and DR strategy is using the BCDR recovery tool. This tool is a powerful asset that provides additional assurance that your systems can get back up and running quickly after a disaster. Also, Google Cloud's automation features allow for automatic backups and failover systems. This key feature ensures that your data remains intact and your operations continue functioning even when disaster strikes. Business continuity and disaster recovery plans are important for any security team, and they should be tested continuously. Now that you know more about BC and DR plans, you can build effective plans to manage disasters and support your organization. As a security professional responsible for disaster recovery, it's important to consider who is impacted by a situation as you respond to it. In this video, you'll learn about the important role stakeholders play in disaster recovery planning. Because they're usually the decision makers, stakeholders should be prepared to participate when security disasters happen. There are 3 main groups of stakeholders that work in and around a disaster recovery plan. The first group includes executive stakeholders. These stakeholders are the decision makers. They establish the budget and outline the strategic course of action for recovery. A Chief Information Officer, or CIO, is an executive stakeholder. The CIO is responsible for setting the stage for the recovery process. They consider business requirements and technological capabilities, so they're ultimately accountable for a successful recovery. Next are operational stakeholders. Operational stakeholders work with executive stakeholders to ensure that recovery plans meet the organization's requirements. They're also responsible for implementing the plans. For example, managers of a security operations team are operational stakeholders. Managers implement the CIO's plan. Finally, technical stakeholders form the first line of defense in the event of a disaster. They work with operational stakeholders to make sure their organization's systems are safe and can get back up and running. During a disaster, technical stakeholders are responsible for the initial fallout. They document and mitigate risks and address any issues that arise. They also coordinate responses, implement emergency procedures, and help in the recovery process to restore operations with minimal downtime. They may have different roles, but these stakeholders don't work alone. Instead, they work together and communicate effectively to help an organization fully recover. Effective and timely communication keeps information moving so that everyone understands their responsibilities and can perform their duties when the time comes. What happens when existing communication channels become compromised or unavailable? It's important for teams to consider the possibility of limited communication and implement solutions in advance. This is where out-of-band communications come into play. Out-of-band communications are alternative methods of communicating that can be used when normal channels become compromised or unavailable. These methods are especially important to ensure stakeholders and team members can communicate during an event or disaster. In large organizations, it's common for teams to perform disaster recovery processes in isolation from other teams. Disasters can have wide-ranging impacts on an organization, so members from different departments, like legal or compliance, need to be aware of disaster recovery efforts. So, it's important to maintain communications across teams during disaster recovery to keep everyone up to date. While stakeholders have different roles, there are a few key things they should all be able to do during a disaster. First, stakeholders need to understand their role and what responsibility they have in their organization. Next, they should be able to implement clear and timely communication. And finally, stakeholders should value their role and the contributions they make during recovery, because they're an essential piece of the recovery effort. A successful disaster recovery plan depends on the coordination and communication of its dedicated stakeholders. The people who come together in a collaborative effort to recover from a disaster need to communicate effectively, share an understanding of recovery efforts, and acknowledge each stakeholder's role in the process. Nice work on completing another section. You've learned a lot. Let's take a moment to quickly revisit what you've learned. First, you learned about the critical aspects of recovery. Then, you learned about business continuity and disaster recovery, including tools and best practices. You learned about key recovery metrics that organizations consider when recovering information, like determining how long systems can remain down and how much data can be lost during a disaster. Finally, you learned all about responsibilities and stakeholders involved in recovery efforts and the relationship between business continuity and disaster recovery. Business continuity and disaster recovery is a critical part of an organization's security posture and response efforts. As a cloud security professional, you'll utilize BCDR tools to efficiently respond to security incidents and maintain operations.
Hi, I'm Patrick.
Hi, I'm Pedro.
It's time for another chance to join an interview that's in progress. In this interview, topics will cover cloud cybersecurity questions related to detecting, responding, and recovering from attacks.
We hope this will help you prepare for your next interview.
Hey Pedro, what interests you in a career in cloud cybersecurity, and what are you looking for in a new role?
Well, my background is in computer science, and I'm really interested in dealing with problems that have to do with scale. And all cloud does is centralize your infrastructure for your customer, for your project in one place. And it lets you focus on problems that are actually interesting instead of physical, for instance, like where is the data? Who's protecting the data center? And what I want out of a career in cloud cybersecurity is to grow. I want to learn, I want to find new problems and solve interesting challenges.
Tell me about a time you faced a challenge and how you responded.
When I started in sophomore year and I asked my professor whether or not I wanted to do research, he asked me, do you even know what that entails? And I said, absolutely not. And he was like, well, pick a topic, go figure out what a problem is that you think you can solve and would be interesting, and go solve it. It turns out that solving that is way more involved than you think. And it involves having and developing a variety of skills that you might never even have thought were relevant.
How long did it take you to find the topic?
About 6 months. We were dealing with IoT devices and cryptography, and I was trying to find some way of mixing those together. And we ended up measuring basically the performance efficiency of a yes on hardware in IoT. And just digging into that whole space, I realized that my interests lie in performance efficiency and cryptography, and those kind of mix the two together.
Pedro, could you give me an example of an incident that a cloud-based organization might have on their infrastructure? How could a cloud cybersecurity analyst detect such an incident?
So in the case of Log4j, there's a few ways that you might go about it. Number one, you might go for what's called static analysis. You might use Google Cloud's managed infrastructure to determine which packages are running the vulnerable versions of Log4j. Another way is you might look for indicators of compromise, IOCs, in the logs themselves, and you might use something like Google Logging and the Chronicle SIM to go and identify the places where the vulnerability was carried out successfully. And finally, you probably want to spin up a generic incident response team that handles any edge cases that you haven't thought of in advance, because the chaos always happens.
So from the Log4j example that you gave, what is a positive takeaway that you got from detecting such an incident?
One thing the world learned about as a result of the log4j thing is to be scared of strings. I think the entire world is much more familiar with the concepts of string interpolation and the implications that that might have. And as a result, it brings kind of these high, like complexity, hard computer science topics, like what is string interpolation? And it makes you realize, maybe I should learn about that.
Let's suppose you're going to use cloud data security controls to detect data storage related incidents. What are some examples of tools they would use and what do they detect?
So the very first thing I would do for my own managed infrastructure on cloud is look at the severity of the data. Are we talking PII, private information, or are we talking machine-to-machine transactions? And for this, I would rely heavily on cloud logging. I need to know exactly what information was being stored and who accessed it and at what time, and start correlating some of the activity around the access of the data to see exactly what happened.
Okay, so let's say you start doing that and you start seeing some of the logs and such, but you're not really sure what's going on. What would you do if you had concerns about the people that access the logs? Like who accessed the logs and why did they access it?
Yeah, no, this is a big problem. And it's actually solved, at least in part, by cloud, but this concept called audit logging. So you might have process logging that tells you what's happening on a system, which port is talking to which port, that kind of thing. But access logging is more like who touched the data, with what justification, was that a valid access? Did someone else authenticate them on their behalf, saying that they could perform such an action? And so we definitely, in addition to the analysis around what happened for the incident, would want to go and look at any data accesses, both during the incident and afterwards, right? We have to make sure that our responders are also following the rules.
So imagine a scenario where you're responsible for writing an incident report. What are some critical pieces of information that must be included in the report?
The report is super important, and it's very multifaceted too. So there's a part about the incident itself, right? How severe was it? What were the affected assets? What are the indicators of compromise? And ideally, you share those out broadly and contribute back to the community. So there's that kind of the incident itself and the outcomes and the learnings. But then there's also the organizational side, right? Where did we succeed? What were some misses? What are some opportunities for improvement? And it's always really important to include those two sections because you have to focus in on the fact that you are doing a good job and you are improving on catching these incidents.
Pedro, thank you. That's the end of the interview. And now it's your turn to ask me any questions you might have.
From your perspective, what keeps you up at night about information security?
The one that I feel like I'm thinking about a lot that I don't hear very often is that the ever-increasing layers of abstraction that we put onto all of the world's infrastructure have made it impossible for a person to actually reason about the risks of that infrastructure. And therefore, it's really hard to secure it or solve it.
Yeah, and that problem is not going to get easier to solve over time, especially as the cloud infrastructure scales.
Thanks for watching. In this scenario, Pedro demonstrated how to end responses with positive takeaways when answering questions. During an interview, you can demonstrate your ability to learn from your experiences and recover from difficult situations by sharing positive takeaways when relevant.
You made it to the end of the course. Congratulations, you did it. Personally, I love working in cybersecurity because it's ever evolving, challenging, yet so fun and rewarding. You get to help make the digital landscape, from everyday systems to emerging technologies, a safer place for everyone. You're well on your way to helping protect people and assets in the cloud. We've covered quite a bit. Let's take a moment to review what you've learned. First, we began with the foundations of incident detection. You learned about the role of security operations in detecting and mitigating threats. You explored these phases involved in incident management. And you considered the fundamentals of logging and the importance of monitoring and detection tools in providing alerts and notifications. Then, we focused on applied detection, where you learned about how cloud tools and techniques are used to identify threats. You learned about the anatomy of an attack using Lockheed Martin's cyber kill chain and the importance of managing false positives and alerts. You also explored cloud monitoring tools, indicators of compromise, and proactive detection through threat hunting. Next, you learned all about the various processes involved in incident response, such as importance of evidence preservation, effective documentation, and optimizing response through automation. Finally, we ended with incident recovery, where you learned about how security teams recover from a security incident using business continuity and disaster recovery planning. You learned a lot about incident response in the cloud. Great job! As a cloud security analyst, you'll find yourself dealing with challenges related to incidents. You'll use what you learned in this course to better manage the incidents you encounter. Coming up, you'll apply all you've learned in the final course with a capstone project. Good luck!
Welcome to the Career Preparation course. You're so close to being ready to apply for cloud security jobs. In this course, you'll put everything you've learned together to prepare for success in your job search. First, you'll learn ways to update your resume and portfolio to showcase the cloud security principles you've learned from prior courses. Next, we'll explore the interview process, including how to prepare for some common interview questions. Then, you'll apply your new skills and knowledge to create a capstone project that brings together all of your skills and knowledge from this course. Let me introduce myself. My name's Louis. I work as a cloud security architect at Google. This means that I blend security expertise, sales knowledge, and consultative skills to help companies establish and demonstrate cloud security. In my job, I help when a customer has a security objective to fulfill, but doesn't exactly know how to do so in the cloud. For example, they need to log activities and configure alerts so they're notified of suspicious actions. In this case, I guide them step by step to ensure they're logging the correct activities, configuring their alerts correctly, and ensuring that Google Cloud Security recommendations are applied. You're almost ready to showcase your new skills and begin applying for cloud security jobs. To get you started, we'll explore the cloud cybersecurity hiring process, including how to search for jobs. Then, we'll give you tips on how to update your resume and portfolio to reflect your skills and expertise so you can be successful in the interview preparation process. Next, you'll create a capstone project that brings together the main concepts you've learned. You can add your capstone project to your portfolio as well. Finally, you'll review what you've learned to complete the final tasks to earn your cloud cybersecurity badge. The job search skills you learn in this course will serve you throughout your career while you continue to gain new skills and take on more complex projects. You're so close to earning your certificate badge. Remember, you set the pace for this course. Feel free to rewatch videos and review new information as often as you need. Once you complete this course, you'll be ready to apply for a cloud security job. Let's get started. Hi, I'm Louis. I'm a security architect here at Google Cloud. A core part of my job is engaging both executive and technical stakeholders to help customers build the most secure deployments possible. This means I help customers protect their data and maintain adherence to regulatory and compliance obligations. I'm a New York native where I studied information science in college. Growing up, I was the most tech-savvy person I knew because I spent all of my time on the computer. But this also meant that when something broke, more accurately when I introduced malware, I had to figure out how to fix it. So it always felt natural to me to study technology, although I initially assumed that computer science was the only way to do so. After learning that I didn't enjoy programming as much, I decided to focus on information science since it had a mix of programming and other courses I found interesting, like data analysis, computer networking, and cybersecurity. I began my career in cybersecurity working on an internal audit team within a finance company. While I learned a tremendous amount about auditing, my biggest lesson was that a career in auditing was not for me. I made a slight pivot and worked in security for a cloud service provider where I was audited against common information security standards instead of being the auditor myself. I then discovered roles that would let me work with organizations to make the most of cloud technology and keep resources secure. I was drawn by the ability to be technical while also helping customers, and the title sounded pretty cool too. That's when I decided that I wanted to pursue a career as a solutions architect. After switching into this role and gaining experience as a solutions architect, I had an opportunity to work for Google in a similar role. Google was especially interested in my background in audit and compliance. I've been at Google and on the same team ever since. It's exciting thinking about all the career paths you can take, but how do you get to the one you want? Let's begin by outlining how you can prepare yourself for success when starting your career in cloud security. First, we'll start with an overview of the hiring process, including how to find and apply for jobs, what to expect from each interview stage, and how to highlight your skills, interests, and goals in a way that sets you apart from other candidates. Next, we'll discuss how to update your resume, or how to create one if you don't have one already. You'll also learn how to describe your skills and prior experience and tailor your resume to the job you want. Then, you'll incorporate the projects from this course into a professional portfolio that highlights your expertise, professionalism, and passion for the field. Finally, you'll learn how to prepare for an interview and plan your responses to some common interview questions. You'll also learn how to navigate interviews that include a project. You're one step closer to having a rewarding job search experience. Keep up the great work! The cloud security field is growing fast, and new job openings are added every day. The job search can be challenging, but the skills you've learned in this certificate, along with your prior experience, have prepared you for success. When exploring cloud security jobs, you should include titles like Cloud Cybersecurity Analyst, Cloud Cybersecurity Engineer, or Cybersecurity Specialist in your search. Many job descriptions require 1 to 3 years of experience, but don't let this stop you from applying for a job you want. An organization may be flexible on experience if the candidate is a good fit. To find entry-level jobs, you can include terms like entry-level, associate, or junior in your search. Before we explore the hiring process, let's review some of the common job duties for cloud cybersecurity analysts. First, cloud cybersecurity analysts are expected to plan, configure, document, and monitor cloud security solutions. Second, cloud security analysts use dedicated tools to check for vulnerabilities and respond to threats as needed. And finally, cloud security analysts are expected to stay up to date on security and technology developments and cyber threats to promote a culture of security throughout the organization. Job titles and duties usually vary between organizations, so be sure to read the full job description to determine whether a position is a good fit. You can use a few different strategies to help you find the cloud security job that's right for you. Networking, including attending security events and joining communities or forums, is a great way to learn about job opportunities, sometimes even before they've been posted publicly. LinkedIn is a professional networking site that includes job postings. LinkedIn is also a great way to learn about daily life at an organization. Other job boards like Indeed and Glassdoor allow you to search for jobs by keyword, job title, and location. On each of these job sites, you'll be able to submit an application along with your resume and portfolio. If a recruiter or hiring manager thinks you might be a good fit, they'll usually contact you to set up a brief screening call. On this call, a recruiter will share more details about the position and ask you about your skills and interests. Be sure to ask questions about the role and the interview process. You can also ask the recruiter for tips to help you prepare. If your screening call goes well, the recruiter will follow up to schedule an interview. Once you have an interview scheduled, the next step is researching the company and role. It's a good idea to learn more about the company's mission, vision, values, and culture. This information is usually available on the company's website or on social media. It's also important to map your skills to the job description and think about examples of time you've used each skill. An interview may be held over the phone, on a video call, or in person. The interviewer will likely ask about your background and experience and give you a chance to ask questions. An interview is your opportunity to understand more about the role so you can decide if the organization is a good fit for you. Some organizations may contact you for multiple rounds of interviews. If so, your recruiter will let you know what to expect for each round. Once you complete your final interview, you should follow up with a message thanking the interviewers for their time. You can also ask about when to expect a response regarding next steps. After that, it's time to wait for a response. You can use this time to improve your skills, work on your portfolio, or apply for other jobs. If the employer doesn't contact you during the time frame they gave, you can reach out to the hiring manager to check your application status. Now that you know what to expect from the hiring process, you're ready to prepare your resume and portfolio and start practicing your interview skills. If you've completed your Google Cybersecurity certificate or other cybersecurity projects, you may have already created an online portfolio. As a reminder, a portfolio is a collection of materials that can be shared with potential employers. A portfolio is a great way to share the skills and knowledge you have with potential employers. Having a portfolio also gives you a chance to share your passion for your work and commitment to personal growth. Hiring managers use your portfolio to evaluate your technical skills, like your experience in securing cloud environments and addressing threats, and skills like problem solving and analysis. Your portfolio is also a place to detail your communication and documentation skills, especially your ability to communicate technical concepts to non-technical audiences. You can make your portfolio accessible from your own custom website or use an existing platform. For example, you can use Git repositories or GitHub or GitLab to organize and customize your project portfolio. You can also use a cloud-hosted application like Dropbox or Google Drive to organize and share project documentation. Or you can use a website building platform like Google Sites, which includes resources to guide you through setting up your site and customizing its layout and appearance. Wherever you choose to host your portfolio, make sure it's well organized, visually appealing, and easy to navigate. This highlights your attention to detail and helps hiring managers understand how your projects relate to one another. If you need ideas, you can ask others in your network or search for example portfolios online. Once you've chosen a platform to host your portfolio, decide what you want to include. It's a good idea to start your portfolio with a short biography and cover statement. Describing your professional goals and experience can provide context for your portfolio projects and help you stand out from other applicants. Then, include documentation samples like risk management policies, control maps, implementation plans, incident reports, and audit or assessment documentation. These can be samples that you've created in an educational environment or on your own. For any projects you can't directly share resources for, like projects completed for an employer, include project descriptions that explain your role. You can also include code samples, like IAC scripts. A quick note on including code in your portfolio. If the platform you're using allows you to embed code, you're all set. If not, you may want to provide a link to code hosted elsewhere or include screenshots and descriptions of coding projects. Make sure to include a brief explanation of each asset in your portfolio, including the tools you used, the framework or standards you followed, and any areas for improvement. You may be asked to present your portfolio in an interview. This is a great opportunity to share your accomplishments. Be sure to highlight the skills you used or learned in each project. Show excitement about your favorite projects. Hiring managers want to know that you're passionate about the field. Finally, be sure to ask the hiring managers if they have any questions once you're done presenting your work. As you move forward in your career, it's important to update your portfolio with projects you complete through educational experiences or on your own. Projects you work on for an employer may deal with confidential information or fall under copyright, so make sure that you follow all applicable rules and regulations. If needed, you can summarize your role on a project using general terms to document your accomplishments without violating your employer's policies. Now it's time to create or update your portfolio. Take your time to create something you're happy with, since you'll continue adding to it as you take on more advanced projects and gain new skills. This is an exciting process. It allows you to communicate who you are and what you've accomplished. That's something to be proud of. Before you apply for a job, it's important to update your resume with your latest skills and experience and tailor it to the position you're applying for. A good resume can make a great first impression on a hiring manager and give you a better chance at becoming a candidate for a position. You might be familiar with some resume basics already. If not, here's a quick review of suggested resume sections. You'll want to include your name and contact information at the top of your resume. In some countries, your resume should include a photo. It's a good idea to research whether this is the case in the country you're applying in. You'll also want to include a brief professional summary statement of your experience and goals. It's a good idea to include a bulleted list of your skills, your work experience, and any volunteer experience relevant to the position you're applying for. Your resume should also list your education. Finally, you'll want to add a link to your portfolio so employers can review your work. However you choose to format your resume, it's important to customize it to the job you're applying for. Updating your resume to highlight your relevant skills lets a hiring manager know that you've put an effort to understand the role and are a good fit for the open position. You've learned lots of new skills you can apply in a cloud cybersecurity role, including configuring, improving, and monitoring cloud infrastructure, incident response, and communication and documentation of security concepts. It's a good idea to keep a running list of your cybersecurity skills. This makes it easier to customize your resume before applying for a job. You might find job descriptions listing programming languages, softwares, and skills you're less familiar with. If this happens, consider which tools and skills you have on your existing resume that may be transferable to the position you're applying for. Even if you haven't worked in a cloud cybersecurity job before, you most likely have transferable skills from other jobs you've had before, or from your personal life. For example, you could have great attention to detail from working in data entry, strong teamwork skills from a service industry job, or effective time management and prioritization skills from running a small business. These are just a few examples. Reflect on your experiences and try to think of any similar skills you may have. In the education section of your resume, you can include this certificate along with any other professional certifications you've completed. This is also where you can list your degree if you have one. You may choose to list relevant coursework here if applicable. For example, if you majored in an unrelated field but took a computer science class as an elective. Your resume and portfolio should complement each other. The qualifications included on your resume will help you get noticed by potential employers, while the projects in your portfolio will provide deeper evidence of your skills and accomplishments. Now you're ready to create a resume that shows off your skills and make employers want to learn more about you. If your portfolio and resume get a hiring manager's attention, they'll contact you to set up an interview. Interviews can be intimidating, but practicing interview skills and conducting research can help you feel confident. Before an interview, it's important to research the organization and role, practice responding to common interview questions, and update your portfolio and resume. It's also a good idea to do some research about the organization you're interviewing with. Understanding the organization's mission, core values, and culture can help you decide whether you and the organization are a good fit. You can usually find this information on the company's social media or website or in the job description. If the company makes products, you should also research the products, the customers who use them, and read news articles about the company to better understand their business. If you still have questions, you can ask the hiring manager. After you learn more about the company, it's a good idea to examine the job description again. If some skills listed in the description don't exactly match with your own, identify transferable skills you can emphasize in the interview. The cloud security hiring process usually involves a few stages of interviews. First, an introductory or screening interview with the hiring manager or a recruiter. Then, a one-on-one interview with the hiring manager. And finally, a panel interview with a few members of the team you'd be working with to get a sense of how well you'll fit in with the team's culture. Most recruiters or hiring managers will let you know how the interview process is structured ahead of time so you can prepare. In a cloud security interview, the hiring manager will ask a variety of questions to assess your skills, experience, and attitude. For example, the hiring manager may ask you behavioral questions, like what you did or would do in a specific situation, or how you'd handle a challenge at work. They might also ask you technical questions about the specifics of the technical tools you've used. An interviewer may also give you a technical problem and ask you to describe the steps you'd take to solve it. These questions are a chance for you to share your knowledge and your communication skills. You can structure your responses to behavioral questions using the STARO method. First, describe the situation, including any context the interviewer needs to know to understand the story. Then, identify the task or the problem or challenge you took on. Next, describe the action or actions you took to address the task. Then, explain the positive result of your actions. And finally, share what you learned. Before answering technical questions, it's important to make sure you understand what the interviewer is asking. Don't be afraid to ask clarifying questions. This lets the interviewer know that you're committed to answering accurately. When answering a technical question with multiple steps, it's a good idea to share your thought process with the interviewer as you answer. If you don't know the answer to a question, don't worry. Explain that you haven't learned that skill yet, but you're committed to learning what you need to know to be successful in the role. The interviewers will expect you to ask questions as well. Remember, you're interviewing each other. Asking questions is your chance to be curious and gather any information you need to decide if the role is a good fit for you. If interviewers ask you about the work in your portfolio, you can give them more information about your goals, the tools you used, and what you learned while working on each project. You should also connect the work in your portfolio to the skills and knowledge that would help you on the job. After an interview, be sure to send a quick email to each interviewer thanking them for their time and confirming your interest in a role. With a little bit of practice and preparation, you'll be interviewing with confidence.
Within my industry, I'm essentially the firewall at Google. I'm protecting user data, ensuring that the controls are in place and that they're applied within each application and service that we have. My name is Joel, and I'm a security engineer. I got started like a lot of people in technology as a power user, where you may be hired as desk job or intern, and then a new printer comes into place, and then you got to add the printer, and they look to you as a new person on the block to do those things. And eventually, I kind of liked doing that over and over, and I kind of transitioned into IT. Within IT, I moved into cloud, and eventually into security engineering. I think what made me decide to pursue security was that within IT, you kind of touch all types of technology, and security was always something that I enjoyed going down like the rabbit hole with. Like, someone doesn't have access, why don't they have access? Someone accessed something that they weren't supposed to, how did they get access to that? Or the fun things like, why was there a movie torrent downloaded onto our server? Like, who was able to do that? How did they do that, and when did they do that? So those kind of questions were always something that interested me, and that's kind of how I got within this career path. What I love most about working in this field is working with the unknown. I love the fact that I can come in any day and get a new problem, a new situation, a new scenario, and work to solve that. To be ready for a career in this industry, I researched YouTube videos, cloud certificates, different programs online, any course I could find, I attempted, practicing coding on my own, doing personal problems, because it all benefits, right? Even if you do a personal project where you're doing a script that rearranges your music in your files, that's something that's valuable, even if it's something that's not for work. Some job application tips and resume tips I would provide is your personal projects are valued on your resumes. I built a bot that looked at stock prices and kind of analyzed it. That's something I would add to my resume to bolster it. It shows that you have a personal interest. It shows that you took an effort other than just applying. You're actually working on those skills. Don't be afraid of coding. I think coding is a daunting task for a lot of folks, especially if you did it within school or college. You may have run into languages like Java or Cobalt or Rust, but the grass is greener on the other side. There's a language for everyone. You could always start with Python, SQL, just to get started. And the fundamentals are all the same across the board. So don't be afraid of coding. Really embrace it and try to make it a part of your tool belt.
Great work. You've come to the end of the career preparation section. You started off by learning what you need to successfully search and interview for your first cloud security analyst job. Then, you explored the cloud cybersecurity hiring process, from locating job openings to researching organizations and submitting applications. Next, you updated your resume with your new skills and prepared to tailor it to specific job descriptions as needed. We also cover how to identify skills from non-security jobs that will help you succeed in a cloud security analyst position. Then, you learned how to create a professional portfolio to share your dedication, passion for the field, and commitment to growth with hiring managers. Finally, you learned how to prepare to impress hiring managers and other interviewers during the interview process. We covered categories of interviews, question types and how to answer them, and how to present your portfolio in an interview. You now have job search and interview skills that will be useful throughout your entire career. Congratulations. Now let's move on to the next step of your learning journey. You're just steps away from completing your capstone project and receiving your certificate. This is a huge accomplishment. Coming up, we'll discuss your capstone project. You'll learn what to expect, tips to help you complete it, and how to make the most of your capstone project in your future cloud security career. First, we'll discuss what to expect and give you some tips to help you complete the project successfully. Then, we'll cover how you can use the capstone project in the job search and interview process. After that, you'll have all the necessary instructions and tools to start, finish, and assess your project. Finally, we'll wrap up your project and discuss some tips for success in your career. When you're ready, meet me in the next video. In this video, we'll discuss the various benefits of completing your capstone project. Your capstone project is an exciting opportunity for you to apply everything you've learned in the program. To complete the project, you'll create and configure it in the cloud. This will give you the chance to practice the tools and frameworks you've learned throughout the program. Let's discuss the benefits of completing the project. First, by completing your capstone project, you'll demonstrate your experience with cloud security concepts and tools. Because the project is similar to actual workplace tasks, completing it will give you a preview into what a cloud security job might be like. Plus, it will show future employers that you have what it takes to succeed in a cloud security role. Completing the project will also give you the opportunity to practice your problem-solving skills. As a cloud security professional, no 2 days will be the same. You'll likely deal with challenges on short notice, and as a new employee, you'll be presented with problems that you may have never seen before. Your capstone project will allow you to showcase your problem-solving skills, and your deliverables will let your employers know that you can successfully handle a challenge. The capstone project is an opportunity to let future employers know that you can identify and balance stakeholder needs and wants. By completing the project, you'll demonstrate that you can carry out delegated tasks and apply your knowledge to configure cloud resources based on stakeholder goals. And by completing your capstone project, you can add a significant achievement to your portfolio. Since it brings together everything you've learned, the capstone project is a great thing to showcase in your portfolio. And when presenting your portfolio to potential employers, you can use your capstone project to emphasize what you learned during this program. Are you ready to showcase your skills? Complete the capstone project to continue your cloud security journey. Hey there, future security professional. In this video, we'll discuss what to expect from your capstone project. I'll also provide you with more details about the project structure and give you some tips to help you along the way. Let's get started. During the capstone project, you'll have access to all the instructions and materials you need to complete it. And before you get started, you'll be able to review a completed example project. That way, you'll have a clear understanding of the expectations for your completed project. Once you've reviewed the instructions and the example project, you'll start your capstone project. The structure of the capstone project is similar to the labs and interactive activities you've worked on throughout this program. While the labs and activities focused on practicing specific concepts and skills, the capstone project is more comprehensive. To complete the project, you'll need to use all the skills you've developed along with the knowledge you've gained from completing the program. If you get stuck along the way, remember, you can always review the previous course materials, labs, and activities. To successfully complete the capstone project, you'll need to use what you've learned about configuring cloud resources, using tools to assess security posture, and documenting your processes. If you'd like, you can review these concepts before you get started. To get started, you'll create a project in Google Cloud. Remember to make sure your project has all the needed security controls in place before you begin. Completing the capstone project to the best of your ability will give you a high-quality work sample that you can share with potential employers. Good luck! Congratulations! You've completed the capstone project. You've done incredible work to get yourself here. Take a moment to congratulate yourself for your effort. By completing this project, you successfully used all the skills you learned throughout the certificate to complete a complex task similar to what you'll complete as a cloud security professional. The capstone project gave you practical experience configuring the security of cloud workloads. Now you can share this experience with future employers to showcase your skills. To share your capstone project, add it to your portfolio, include it on your resume, and present it during interviews. This course has been an exciting journey through cloud security, and finishing it is just the beginning. There are so many more opportunities to learn and grow ahead. To continue learning about cloud security, consider finding a mentor, joining online or in-person professional groups, and attending conferences to learn more from others. You can also continue building your portfolio by completing online practice projects. Before you do any of that, though, take another moment to congratulate yourself on all of your hard work. Congratulations, you've reached the end of the course. You're almost ready to claim your certificate. Throughout your learning journey, you've built on your cybersecurity knowledge and gained the skills you need for success in a cloud security career. I'm honored to congratulate you on all you've accomplished, but there are others who are waiting to join me.
Congratulations on completing this program. Well done. This is the first step of many more.
Congratulations on completing the program. What an achievement.
Incredible work.
Congratulations on completing the program. You did it.
Kudos on your success. Hope you take this moment to celebrate your hard work and perseverance.
Congratulations on completing this program. What an achievement.
Awesome job. I'm proud of all your effort.
Congratulations on finishing your certificate. There's more work to be done.
Congratulations! You did it!
Congratulations, you made it.
Nice going. You've learned so much throughout this program. I'm excited for you to use what you've learned on the job.
Congratulations on earning your certificate. Best of luck in your future endeavors, and I know you're going to do great.
Wow, great job. You finished the whole certificate. Congrats.
For now, you can celebrate. You have a solid foundation in cloud security that you'll build on throughout your career. Congratulations once again, and goodbye for now. You're off on an exciting new adventure, and I'll be cheering for you the whole way. You've just completed a Google Career Certificate. Great work. Let's check out some professional opportunities your new skills can unlock. With this certificate, you can share your accomplishments on any job search platform, like LinkedIn, Indeed, and Glassdoor. You can also add the certificate to your resume. Throughout these courses, you learned how to apply security concepts to cloud environments. You also gained the skills and knowledge you need to get off to a great start in the cloud cybersecurity field. Let's review what you learned in this program. You started by learning the basics of cloud computing. You discovered the security lifecycle and explored a cloud security analyst role in an organization. Next, you learned about security and risk management in cloud environments. You also learned about security and compliance frameworks, explored the compliance lifecycle, and worked with tools for risk management and compliance. Then, you learned to identify and protect against threats. You also learned to implement the principle of least privilege using access control and identity management. Next, you explored threat and vulnerability management. You also learned about the cloud-native concepts of ephemerality, immutability, and handling secrets, and the essentials of data protection and privacy. You also learned how to detect, respond to, and recover from cloud cybersecurity attacks. Finally, you learned about the cloud security hiring process and created a capstone project to add to your portfolio. You've accomplished so much and developed skills you can take with you throughout your future career. As you continue your cloud security journey, be sure to stay engaged in the cybersecurity community and up to date on the latest trends. As a cloud security professional, you'll always be learning. Some resources you can use to stay engaged in the community include social media, where you can follow organizations and individuals within the industry, virtual or in-person conferences and events where you can learn more about the field and meet other professionals, and professional associations. Congratulations again! I'm confident that you're well prepared for a successful cloud cybersecurity career. I wish you the best of luck.